Hi everyone and welcome to this fantastic machine learning Python full course. But before we begin, if you enjoy watching these kind of videos and find them interesting, then subscribe to our YouTube channel because we bring the best videos for you daily. Also hit the bell icon to never miss any updates from Simplilearn. So without any further delay, let's go through the agenda for today's video. We'll brief you with a machine learning introduction, and after that, we'll see the types of machine learning. Moving forward, we'll cover the machine learning roadmap, skills required for machine learning engineers, and the top applications and projects for machine learning. We'll walk you through some fantastic concepts like AI versus machine learning versus deep learning. Proceeding with the course, we'll teach you different machine learning algorithms with hands-on demo explanations in Python. We'll walk you through some unique projects like fake news detection and time series. These projects will serve you as the finest portfolios for your future interviews. Speaking of interviews, we have covered you along with the most frequently asked machine learning interview questions to help you crack the most challenging interviews. But before we begin, if you are an aspiring machine learning engineer looking for online training and certifications from prestigious universities and in collaboration with leading experts, then
Here we have our, it looks a little bit like Frankenstein, our Frankenstein-looking robot. Today, let me tell you what is machine learning. Machine learning works on the development of computer programs that can access data and use it to automatically learn and improve from experience. Watch a robot builder construct a house in 2 days. This was back in July 29th, 2016, so that's pretty impressive. This amount of time to continue to grow in its development. And it's smart enough to leave spaces in the brickwork for wiring and plumbing and can even cut and shape bricks to size. Amazon Echo relies on machine learning, and with more data it becomes more accurate. Play your favorite music, order pizza from Domino's, voice control your home, request rides from Uber. Have you ever wondered the difference between AI, machine learning, and deep learning? Artificial intelligence, a technique which enables machines to mimic human behavior. This is really important because this is how we are able to gauge how well our computations or what we're working on works, is the fact that we're mimicking human behavior. We're using this to replace human work and make it more efficient and make it more streamlined and more accurate. And so the center of artificial intelligence is the big picture of all of this put together. IBM Deep Blue Chess, electronic game characters. Those are just a couple examples of artificial intelligence. Machine learning, a technique which uses statistical methods, enabling machines to learn from their past data. So this means if you have your input from last time and you have your answer, you use that to help prove the next guess it makes for the correct answer. IBM Watson, Google search algorithm, email spam filters, these are all part of machine learning. And then deep learning, which is a subset of machine learning, composing algorithms that allow a model to train itself and perform tasks. AlphaGo, natural speech recognition. These are a couple examples. Deep learning is associated with tools like neural networks where it's kind of a black box. As it learns, it changes all these things that are, as a human, we would have a very hard time tracking. And it's able to come up with an answer from that. Now let's see how machine learning works. First, we start with training the data. Once we've trained the data, we go into the machine learning algorithm, which then puts the data into a processing, which then goes down to another machine learning algorithm. And then we take new data, because you have to test whatever you did and make sure it works correctly, and we put that into the same algorithm. Once we do that, we check our prediction, we check our results, and from the prediction, if we've set aside some training data and we find out it didn't do a good job predicting it, and it gets a thumbs down as you see, then we go back to the beginning and we retrain the algorithm. And a lot of times it's not just about getting the wrong answer, it's about continually trying to get a better answer. So you'll see the first time you might be like, oh, this is not the answer I want, depending on what domain you're working in, whether it's medical, economical, business, stocks, whatever. You try out your model, and if it's not giving you a good answer, you retrain it. If you think you can get a better answer, you retrain it, and you keep doing that until you get the best answer you can.
Now let's look into the types of machine learning. Machine learning is primarily of 3 types. First one is supervised machine learning. As the name suggests, you have to supervise your machine learning while you train it to work on its own. It requires labeled training data. Next up is unsupervised learning, wherein there will be training data but it won't be labeled. Finally, there is reinforcement learning, wherein the system learns on its own. Let's talk about all these types in detail. Let's try to understand how supervised learning works. Look at the pictures very carefully. The monitor depicts the model or the system that we are going to train. This is how the training is done. We provide a dataset that contains pictures of a kind of a fruit, say an apple. Then, we provide another dataset which lets the model know that these pictures were that of a fruit called apple. This ends the training phase. Now, what we will do is we provide a new set of data which only contains pictures of apple. Now here comes the fun part. The system can actually tell you what fruit it is. And it will remember this and apply this knowledge in future as well. That's how supervised learning works. You are training the model to do a certain kind of an operation on its own. This kind of a model is generally used into filtering spam mails from your email accounts as well. Yes, surprised, aren't you? So let's move on to unsupervised learning now. Let's say we have a dataset which is cluttered. In this case, we have a collection of pictures of different fruits. We feed this data to the model and the model analyzes the data to figure out patterns in it. In the end, it categorizes the photos into 3 types as you can see in the image based on their similarities. So, you provide the data to the system and let the system do the rest of the work. Simple, isn't it? This kind of a model is used by Flipkart to figure out the products that are well suited for you. Honestly speaking, this is my favorite type of machine learning out of all the 3. And this type has been widely shown in most of the sci-fi movies lately. Let's find out how it works. Imagine a newborn baby. You put a burning candle in front of the baby. The baby does not know that if it touches the flame, its fingers might get burned. So it does that anyway and gets hurt. The next time you put that candle in front of the baby, it will remember what happened the last time and would not repeat what it did. That's exactly how reinforcement learning works. We provide the machine with a dataset wherein we ask it to identify a particular kind of a fruit, in this case an apple. So what it does as a response, it tells us that it's a mango. But as we all know, it's a completely wrong answer. So as a feedback, we tell the system that it's wrong, it's not a mango, it's an apple. What it does, it learns from the feedback and keeps that in mind. When the next time, when we ask a same question, it gives us the right answer. It is able to tell us that it's actually an apple. That is a reinforced response. So that's how reinforcement learning works. It learns from its mistakes and experiences. This model is used in games like Prince of Persia or Assassin's Creed or FIFA, wherein the level of difficulty increases as you get better with the games. Just to make it more clear for you, let's look at a comparison between supervised and unsupervised learning. Firstly, the data involved in case of supervised learning is labeled. As we mentioned in the examples previously, we provide the system with a photo of an apple and let the system know that this is actually an apple. That is called label data. So the system learns from the label data and makes future predictions. Now, unsupervised learning does not require any kind of label data because its work is to look for patterns in the input data and organize it. The next point is that you get a feedback in case of supervised learning. That is, once you get the output, the system tends to remember that and uses it for the next operation. That does not happen for unsupervised learning. And the last point is that supervised learning is mostly used to predict data, whereas unsupervised learning is used to find out hidden patterns or structures in data. I think this would have made a lot of things clear for you regarding supervised and unsupervised learning.
Artificial intelligence and machine learning have permeated every aspect of our lives. If you are a programmer, chances are you have begun utilizing GitHub's Copilot, an AI tool that transforms natural language prompts into coding suggestions, streamlining the programming process. As a writer, you may have encountered OpenAI's GPT-3 or similar autoregressive language models that leverage deep learning to generate text resembling human language. Many of us dedicated a few hours to experimenting with DALL-E 2, the AI/ML powered text to image generator capable of producing intricate visuals based on the most unusual request. Not only is DALL-E 2 exponentially more powerful, but it also has the potential to revolutionize the field of digital art. Consider its impact on a digital artist, illustrator, or graphic designer career. Imagine creating a highly realistic image within seconds using an app. These technologies have significant real-world applications with far-reaching implications. Let me tell you some fascinating facts about machine learning. According to recent studies, machine learning related job postings have increased by a staggering 344% in the past 5 years. Companies across the globe are actively seeking professionals who can harness the power of data and build intelligent systems. The average salary is $190,000 in US and 26 lakhs per annum in India. Accelerate your career in AI and ML with our comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and hackathons and Ask Me Anything sessions by IBM. With 3 capstone and 25 plus industry projects using real data sets from Twitter, Uber, and more, you will gain practical experience. Master classes by Purdue faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist helps you get noticed by leading companies. Live sessions on AI trends like ChatGPT, generative AI, and explainable AI. This program covers statistics, Python, supervised and unsupervised learning, NLP, neural networks, computer vision, GANs, Keras, TensorFlow, and many more skills. Enroll now and unlock exciting AI and ML opportunities. The link is mentioned in the description box below. With that having said, now here is a comprehensive step-by-step guide to learning machine learning. Number 1 is skills required. Number 2, job roles in ML. Number 3, companies hiring ML engineers. And the number 4 is future scope of ML. Now starting with the number 1, that is fundamentals of machine learning. Familiarize yourself with the fundamentals of machine learning. In the initial stages of learning to drive, we are familiarized with the different elements, varieties, and regulations pertaining to operating a car. It is essential to delve into the fundamentals of machine learning to understand what lies ahead and the required knowledge. Now moving to number 2, that is acquiring proficiency in Python or R programming language. To excel in the field of artificial intelligence and machine learning, it is crucial to develop a strong command of Python or R programming language. Both Python and R are widely used in the data science community due to their versatility and extensive libraries for scientific computing. So now moving on to the third step, that is gain knowledge of essential Python libraries for machine learning. Once you have acquired proficiency in Python as part of our machine learning journey, the subsequent step involves familiarizing yourself with essential Python libraries crucial for working with data and implementing machine learning solutions. The key Python libraries that you should learn for machine learning are NumPy, Pandas, Matplotlib, and scikit-learn. Now moving to step 4, that is learn and implement various machine learning algorithms. After gaining proficiency in Python as part of our machine learning journey, the subsequent milestone involves learning various machine learning algorithms and their implementation using Python. Listed below are some of the key machine learning algorithms that are essential to learning. Number 1, linear regression. Number 2, logistic regression. Number 3, passive regression. Number 4, naive Bayes. Number 5, support vector machines. Now moving to step 5, master the concepts and implementation of neural networks. Once you have acquired knowledge of Python and machine learning algorithms, the next significant step in the machine learning roadmap is to learn neural network architecture and their implementations using Python. Outlined below are several crucial neural network architectures that are essential to learning. Number 1, artificial neural networks. Number 2, CNN. Number 3, RNN. Number 4, long short term memory. Now moving to step 6, that is engage hands-on projects to apply your knowledge and reinforce your understanding. After acquiring knowledge of Python, machine learning algorithms, and neural network architectures, the next crucial step is the machine learning roadmap and is to gain practical experience by working on projects that allow you to apply what you have learned. The first project is iris flower classification. Number 2, California house price prediction. Number 3, stock price prediction. Number 4, customer segmentation. Now we'll move to job roles in machine learning. Machine learning, as highlighted earlier, has gained immense popularity for its ability to elevate human efforts and enhance machine performance through autonomous learning. This popularity has resulted in lucrative and sought after career options within the field, including roles like machine learning engineer. So the duty of a machine learning engineer encompasses the creation, construction, and deployment of machine learning models. Collaborating closely with data scientists and software engineers, they participate in the development and execution of machine learning systems. According to Glassdoor, ML engineers can earn up to $150,000 in US and 11 lakhs per annum in India. Now moving to data scientist. The role of a data scientist involves gathering, scrutinizing, and interpreting extensive datasets. Leveraging machine learning algorithms, they uncover patterns and glean insights from the data, utilizing this knowledge to inform decisions and address challenges. According to Glassdoor, data scientists earn $145,000 in US and 13 lakhs per annum in India. Now moving to NLP engineers. The specific duties may vary based on the role and sector, but as outlined by Freelancer Map, an NLP engineer typically engage in tasks such as designing natural language processing systems and addressing speech patterns and AI speech recognition. According to Glassdoor, NLP engineer can earn $120,000 in US and 10 lakhs per annum in India. Now moving to computer vision engineer. Engineers specializing in computer vision operate within the realm of computer vision, employing machine learning to empower computers to comprehend and interpret visual data from their surroundings. Their responsibilities include tasks such as image and video analysis and object detection. According to Glassdoor, CV engineers earn $156,000 in US and 8 lakhs per annum in India. Now moving to business intelligence developer. The main role of a BI developer is to develop, deploy, and maintain BI tools and interfaces. They are also responsible for simplifying highly technical language and complex information into layman's terms for everyone else in the company to understand. According to Glassdoor, business intelligence developers earn $105,000 in US and 7 lakhs per annum in India. Now we'll see the top companies hiring for machine learning engineer. Number 1 is Amazon. Then we have Accenture, Google, Apple, Intel. So these are the top hiring companies that hire machine learning engineers. Now we'll talk about future of machine learning. Machine learning has a bright future but faces several difficulties. ML is predicted to grow increasingly pervasive as technology develops, revolutionizing sectors including healthcare, banking, and transportation. The work market will change due to AI-driven automation, necessitating new position and skills.
Welcome to our video on skills required for an ML engineer. Machine learning has been the talk of the town lately. Every organization has realized the potential of machine learning in improving their business objectives and attaining their enterprise goals. This expanding demand has led to a lot of people applying for machine learning jobs and upskilling themselves in the field of machine learning. You can take up this growing opportunity in the field of machine learning and utilize it to land yourself a very challenging, fulfilling, and high-paying job. In this video, we will be breaking down in complete detail each and every skill that you would need in order to crack the machine learning engineer job interview. Well, ML is not just a passing trend. It's a seismic shift that is reshaping our world and creating new avenues for innovation and discovery. So by embracing a career in ML, you become part of a dynamic field that thrives on solving complex problems, pushing boundaries, and making a profound impact on society. So the demand for ML professionals is skyrocketing across industries, from healthcare and finance to entertainment and transportation. Organizations are actively seeking talented individuals who can harness the power of AI to drive their business forward. But what skill does it take to become an ML engineer? How can you embark on this thrilling journey? We have the answers to all your questions. Also, accelerate your career in AI and ML with our comprehensive postgraduate program in AI and machine learning. Gain expertise in machine learning, deep learning, NLP, computer vision, and reinforcement learning. You will receive a prestigious certificate, exclusive alumni membership, and Ask Me Anything sessions by IBM. With 3 capstone projects and 25 plus industry projects using real datasets from Twitter, Uber, and more, you will gain practical experience. Masterclasses by Caltech faculty and IBM experts ensure top-notch education. Simplilearn's Job Assist help you get noticed by leading companies. This program covers Python, supervised and unsupervised learning, NLP, neural networks, computer visions, GANs, Keras, TensorFlow, and many more other skills. So enroll now and unlock exciting AI and ML opportunities. The link is in the description box below. So without any further delay, let's get started.
To become a machine learning engineer, you need a combination of technical skills, non-technical skills, and some bonus skills. So here are some essential skills required to pursue a career as an ML engineer. So first we will talk about some technical skills to become a ML engineer. So first one in the list is programming languages. Strong programming skills are essential. You should be proficient in at least one programming language such as Python or R. Python is widely used in the ML community due to its rich libraries, that is NumPy, Pandas, TensorFlow, and PyTorch, that supports ML tasks. And the second on the list is machine learning algorithms and techniques. You should have a solid understanding of various ML algorithms such as linear regression, logistic regression, decision trees, random forest, neural network, and deep learning. Familiarize yourself with the principles behind these algorithms, their pros and cons, and when to use them. So third one on the list is data pre-processing. ML models require clean and well-prepared data. You should know how to handle missing data, deal with normalized and standardized data, and the final is perform feature engineering. Understanding data pre-processing technique is crucial for effective ML model training. And the fourth one is data manipulation and analysis. Data is the foundation of ML model. You should be skilled in the data manipulation and analysis using libraries like NumPy and Pandas. This includes cleaning and transforming data, exploratory data analysis, which is EDA, and understanding the statistical properties of the data. And the fifth one is machine learning libraries and frameworks. Familiarity with popular ML libraries and frameworks is essential. Some commonly used one include NumPy, Pandas, TensorFlow, and PyTorch. These libraries provide pre-implemented ML algorithms, neural network architectures, and tools for model training and evaluation. Now that we have seen the technical machine learning engineering skills, let us have a look at the non-technical machine learning skills. So the first one is industry knowledge. Machine learning projects that effectively tackle genuine challenges are likely to achieve great success, regardless of the industry you are involved in. It is crucial to have a comprehensive understanding of its operation and identify ways to optimize business outcomes. And the second one on the list is effective communication. Effective communication plays a crucial role in facilitating these interactions. Companies seeking skilled ML engineer value candidates who can effectively convey technical discoveries to non-technical terms like marketing or sales, demonstrating clarity and fluency in their explanation. Moving forward, let's see some bonus skills to become a ML engineer. The first one on the list is reinforcement learning. In 2023, reinforcement learning emerged as a catalyst for numerous captivating advancements in deep learning and artificial intelligence. To pursue a career in robotics, self-driving cars, or any other AI-related field, it is crucial to comprehend this concept. And the second on the list is computer vision. Computer vision and machine learning are fundamental branches of computer science that can independently fuel highly advanced systems relying on CV and ML algorithm. However, their combination has a potential to unlock greater even possibilities and achievements. So remember that the field of ML is constantly evolving through continuous learning and staying updated with the latest development and the research papers.
Machine learning has improved our lives in a number of wonderful ways. Today, let's talk about some of these. I'm Rahul from Simplilearn, and these are the top 10 applications of machine learning. First, let's talk about virtual personal assistants. Google Assistant, Alexa, Cortana, and Siri. Now, we've all used one of these at least at some point in our lives. Now, these help improve our lives in a great number of ways. For example, you could tell them to call someone. You could tell them to play some music. You could tell them to even schedule an appointment. So how do these things actually work? First, they record whatever you're saying, send it over to a server, which is usually in a cloud, decode it with the help of machine learning and neural networks, and then provide you with an output. So if you've ever noticed that these systems don't work very well without the internet, that's because the server couldn't be contacted. Next, let's talk about traffic predictions. Now say I wanted to travel from Buckingham Palace to Lord's Cricket Ground. The first thing I would probably do is to get on Google Maps. So, search it. And let's put it here. So here we have the path you should take to get to Lord's Cricket Ground. Now here the map is a combination of red, yellow and blue. Now the blue regions signify a clear road, that is you won't encounter traffic there. The yellow indicate that they are slightly congested and red means they're heavily congested. So let's look at the map a different version of the same map. And here, as I told you before, red means heavily congested, yellow means slow moving, and blue means clear. So how exactly is Google able to tell you that the traffic is clear, slow moving, or heavily congested? So this is with the help of machine learning and with the help of two important measures. First is the average time that's taken on specific days at specific times on that route. The second one is the real-time location data of vehicles from Google Maps and with the help of sensors. Some of the other popular map services are Bing Maps, Maps.me, and here we go. Next up, we have social media personalization. So say I want to buy a drone, and I'm on Amazon and I want to buy a DJI Mavic Pro. The thing is, it's close to 1 lakh, so I don't want to buy it right now. But the next time I'm on Facebook, I'll see an advertisement for the product. The next time I'm on YouTube, I'll see an advertisement. Even on Instagram, I'll see an advertisement. So here, with the help of machine learning, Google has understood that I'm interested in this particular product. Hence, it's targeting me with these advertisements. This is also with the help of machine learning. Let's talk about email spam filtering. Now, this is the spam that's in my inbox. Now, how does Gmail know what's spam and what's not spam? So Gmail has an entire collection of emails which have already been labeled as spam or not spam. So after analyzing this data, Gmail is able to find some characteristics like the word lottery or winner. From then on, any new email that comes to your inbox goes through a few spam filters to decide whether it's spam or not. Now, some of the popular spam filters that Gmail uses is content filters, header filters, general blacklist filters, and so on. Next, we have online fraud detection. Now, there are several ways that online fraud can take place. For example, there's identity theft, where they steal your identity, fake accounts, where these accounts only last for how long the transaction takes place and stop existing after that, and man-in-the-middle attacks, where they steal your money while the transaction is taking place. The feed-forward neural network helps determine whether a transaction is genuine or fraudulent. So what happens with feed-forward neural networks are that the outputs are converted into hash values, and these values become the inputs for the next round. So for every real transaction that takes place, there's a specific pattern. A fraudulent transaction would stand out because of the significant changes that it would cause with the hash values. Stock market trading. Machine learning is used extensively when it comes to stock market trading. Now you have stock market indices like Nikkei. They use long short-term memory neural networks. Now these are used to classify, process, and predict data when there are time lags of unknown size and duration. Now this is used to predict stock market trends. Assistive medical technology. Now, medical technology has been innovated. With the help of machine learning, diagnosing diseases has been easier, from which we can create 3D models that can predict where exactly there are lesions in the brain. It works just as well for brain tumors and ischemic stroke lesions. They can also be used in fetal imaging and cardiac analysis. Now, some of the medical fields that machine learning will help assist in is disease identification, personalized treatment, drug discovery, clinical research, and radiology. And finally, we have automatic translation. Now, say you're in a foreign country and you see billboards and signs that you don't understand. That's where automatic translation comes of help. Now, how does automatic translation actually work? The technology behind it is the same as the sequence-to-sequence learning, which is the same thing that's used with chatbots. Here, the image recognition happens using convolutional neural networks, and the text is identified using optical character recognition. Furthermore, the sequence-to-sequence algorithm is also used to translate the text from one language to the other.
Finding a suitable job in the field of machine learning is becoming increasingly difficult. The ideal way to display your machine learning skill is in the form of portfolio of data science and machine learning projects. A solid portfolio of projects will illustrate that you can utilize those machine learning skills in your profile as well. Projects like movie recommendation system, fake news detection, and many more are the best way to improve your early programming skills. You may have the knowledge, but putting it to the use what is keep you competitive. Here are 10 machine learning projects that can increase your portfolio and enable you to acquire a job as a machine learning engineer. At number 10, we have loan approval prediction system. In this machine learning project, we will analyze and make prediction about the loan approval process of any person. This is a classification problem in which we must determine whether or not the loan will be approved. A classification problem is a predictive modeling problem that predict a class label for a given example of input data. Some classification problems include spam email, cancer detection, sentiment analysis, and many more. You can check the project link from the description box below to understand classification problem and how to build a loan prediction system. At number 9, we have fake news detection system. Do you believe in everything you read in social media? Isn't it true that not all news is true? But how will you recognize fake news? ML is the answer. You will be able to tell the difference between real and fake news by practicing this project of detecting fake news. This ML project for detecting fake news is concerned with the fake news and the true news. On our dataset, we create a TF-ID vectorizer with sklearn. The model is then fitted using a passive-aggressive classifier that has been initialized. Finally, the accuracy score and the confusion matrix indicate how well our model performs. The link for the project is in the description box below. At number 8, we have personality prediction system. The idea is based on determining an individual personality using machine learning techniques. A person's personality influences both his personal and professional life. Nowadays, many companies are shortlisting applicants based on their personality, which increases job efficiency because the person is working on what he is good at rather than what he is compelled to do. In our study, we attempted to combine personality prediction system using machine learning techniques such as SVD, naive-Bayes, and logistic regression to predict a person's personality and talent prediction using phrase frequency method. This model or method allows users to recognize their personality and technical abilities easily. To learn about more this project, check the link in the description box below. At number 7, we have Parkinson disease system. Parkinson disease is a progressive central nervous system ailment that affects movement and causes tremors and stiffness. It comprises 5 stages and affects more than 1 million worldwide each other. In this machine learning project, we will develop an SVM model using Python modules, scikit-learn, NumPy, and pandas. An SVM, we will import the data, extract the features and label and scale the features, split the dataset, design an SVM model, and calculate the model accuracy. And at the end, we will check the Parkinson disease for the individual. To learn about more this project, check the link in the description box below. At number 6, we have text-to-speech converter application. The machine learning domain of audio is undoubtedly cutting edge right now. The majority of the applications available today are the commercial. The community is building several audio-specific open source framework and algorithm. Other text-to-speech APIs are available for this project. We will utilize pyttsx3. pyttsx3 is a Python text-to-speech conversion library. It operates offline unlike other libraries and is compatible with Python 2 and Python 3. Before API, various pre-trained models were accessible in Python, but changing the voice or volume was often difficult. It also needed additional computational power. To learn more about this project, check the link in the description box below. At number 5, we have speech recognition system. Speech recognition, often known as speech to text, is the capacity of a machine or program to recognize and transfer words spoken aloud into readable text. ML speech recognition uses algorithms that model speech in terms of both language and sound to extract the more important parts of the speech, such as words, sentences, and acoustic modeling is used to identify the phonemes and the phonetics on the speech. For this project, we will utilize pyttsx3. pyttsx3 is a Python text-to-speech conversion library. It operates offline unlike other libraries and is compatible with Python 2 and Python 3. To learn more about this project, check the link in the description box below. At number 4, we have sentiment analysis. Sentiment analysis, also known as opinion mining, is a straightforward process of determining the author's feeling about a text. What was the user intention when he or she wrote something? To determine what could be personal information, we employ a variety of natural language processing and text analysis technology. We must detect, extract, and quantify such information from the text to enable classification and data manipulation. In this project, we will use the Amazon customer review dataset for the sentiment analysis. Check the link in the description box below. At number 3, we have image classification using CNN. Deep learning is a booming field currently. Most projects and problem statements use deep learning is an any sort of work. Many of you, like myself, would choose a conventional neural network as a deep learning technique for answering any computer vision problem statement. In this project, we will use CNN to develop an image processing project and learn about its capabilities and why it has become so popular. We will go over each stage of creating our CNN model and our first spectacular project. We will use the CFR10 dataset for image classification in this project. To learn more about this project, check the link in the description box below. At number 2, we have face recognition system. Currently, technology absolutely amazes people with incredible invention that makes life easier and more comfortable. Face recognition has shown to be the least intrusive and fastest form of the biometric verification over time. This project will use OpenCV and face recognition libraries to create a face detection system. OpenCV provides a real-time computer vision tool, library, and hardware. We can create amazing real-time projects using OpenCV. To learn how to create face recognition system for you, check the link in the description box below. And last but not the least, we have movie recommendation system. Almost everyone today uses technology to stream movies and television shows. While figuring out what to stream next can be disheartening. Recommendations are often made based on a viewer history and preferences. This is done through a machine learning and can be a fun and the easy project for the beginners. New programmers can practice by coding in either Python or R. And with the data from the Movie Lens dataset generated by the more than 6,000 users. To learn how to create movie recommendation system for yourself or for your loved ones, check the project in the description box below.
Human versus artificial intelligence. Humans are amazing. let's just face it, we're amazing creatures. We're all over the planet. We're exploring every niche and nook. We've gone to the moon. We've gone into outer space. We're just amazing creatures. We're able to use the available information to make decisions, to communicate with other people, identify patterns in data, remember what people have said, adapt to new situations. So let's take a look at this. So you can get a picture. You're a human being, so you know what it's like to be human. Let's take a look at artificial intelligence versus the human. Artificial intelligence develops computer systems that can accomplish tasks that require human intelligence. So we're looking at this. One of the things that computers can do is they can provide more accurate results. This is very important. Recently I did a project on cancer where I was identifying markers. And as a human being, you look at that and you might be looking at all the different images and the data that comes off of them and say, I like this person, so I want to give them a very good outlook. And the next person you might not like, so you want to give them a bad outlook. Well, with artificial intelligence, you're going to get a consistent prediction of what's going to come out. Interacts with humans using their natural language. We've seen that as probably the biggest development feature right now that's in the commercial market that everybody gets to use, as we saw with the example of Alexa. They learn from their mistakes and adapt to new environments. So we see this slowly coming in more and more. And they learn from the data and automate repetitive learning. Repetitive learning has a lot to do with the neural networks. You have to program thousands upon thousands of pictures in there, and it's all automated. So as today's computers evolve, it's very quick and easy and affordable to do this. What is machine learning and deep learning all about? Imagine this. Say you had some time to waste. Not that any of us really have a lot of time anymore to just waste in today's world. And you're sitting by the road, and you have a whole lot of time passes by. There's a few hours. And suddenly you wonder, how many cars, buses, trucks, and so on passed by in the 6 hours? Now, chances are you're not going to sit by the road for 6 hours and count buses, cars, and trucks, unless you're working for the city and you're trying to do city planning and you want to know, hey, do we need to add a new truck route? Maybe we need a bicycle lane because we have a lot of bicyclists here, that kind of thing. So maybe city planning would be great for this. Machine learning. Well, the way machine learning works is we have labeled data with features. Okay, so you have a truck or a car, a motorcycle, a bus, or a bicycle, and each one of those are labeled. It comes in, and based on those labels and comparing those features, it gives you an answer. It's a bicycle, it's a truck, it's a motorcycle. Let's look a little bit more in depth on this. In the model here, the features we're looking at would be like the tires. Someone sits there and figures out what a tire looks like. It takes a lot of work. If you try to figure the difference between a car tire, a bicycle tire, a motorcycle tire. So in the machine learning field, this could take a long time if you're going to do each individual aspect of a car and try to get a result on there. And that's what they did do. That was this is still used on smaller amounts of data where you figure out what those features are and then you label them. Deep learning. So with deep learning, one of our solutions is to take a very large unlabeled data set and we put that into a training model using artificial neural networks, and then that goes into the neural network itself when we create a neural network. And you'll see the arrows are actually kind of backward, but which actually is a nice point, because when we train the neural network, we put the bicycle in and then it comes back and says, if it said truck, it comes back and says, well, you need to change that to bicycle. And then it changes all those weights going backward, they call it back propagation, and let it know it's a bicycle, and that's how it learns. Once you've trained the neural network, you then put the new data in, and they call this testing the model, so you need to have some data you've kept off to the side where you know the answer to. And you take that and you provide the required output, and you say, okay, is this neural network working correctly? Did it identify a bike as a bike, a truck as a truck, a motorcycle as a motorcycle? Let's just take a little closer look at that. Determining what objects are present in the data. So how does deep learning do this? And here we have the image of the bike. It's 28 by 28 pixels. That's a lot of information there. Could you imagine trying to guess that this is a bicycle image by looking at each one of those pixels and trying to figure out what's around it? And we actually do that as human beings. It's pretty amazing. We know what a bicycle is, and even though it comes in as all this information. And what this looks like is the image comes in, It converts it into a bunch of different nodes. In this case, there's a lot more than what they show here. And it goes through these different layers and outcomes and says, okay, this is a bicycle. A lot of times they call this the magic black box. Why? Because as we watch it go across here, all these weights and all the math behind this, and it's a little complicated on the math side. You really don't need to know that when you're programming or working with the deep learning. But it's like magic. You don't know, you really can't figure out what's going to come out by looking what's in each one of those dots and each one of those lines are firing and what's going in between them. So we like to call it the magic box. So that's where deep learning comes in. And in the end, it comes up and you have this whole neural network that comes up and it says, okay, we fire all these different pixels and we connects all these different dots and gives them different weights, and it says, okay, this is a bicycle. And that's how we determine what the object is present in the data with deep learning. Machine learning. We're going to take a step into machine learning here, and you'll see how these fit together in a minute. The system is able to make predictions or take decisions based on past data. That's very important for machine learning, is that we're looking at stuff, and based on what's been there before, we're creating a decision on there. We're creating something out of there. We're coloring a beach ball. We're telling you what the weather is in Chicago. What's nice about machine learning is a very powerful processing capability. It's quick and accurate outcomes, so you get results right away. Once you program the system, the results are very fast. And the decisions and predictions are better. They're more accurate. They're consistent. You can analyze very large amounts of data. Some of these data things that they're analyzing now are petabytes and terabytes of data. It would take hundreds of people hundreds of years to go through some of this data and do the same thing that the machine learning can do in a very short period of time. And it's inexpensive compared to hiring hundreds of people. So it becomes a very affordable way to move into the future, is to apply the machine learning to whatever businesses you're working on. And deep learning. Systems think and learn like humans using artificial neural networks. Again, it's like a magic box. Performance improves with more data. So the more data the deep learning gets, the more it gives you better results. It's scalability. So you can scale it up, you can scale it down, you can increase what you're looking at. Currently, we're limited by the amount of computer processing power as to how big that can get. But that envelope continually gets pushed every day on what it can do. Problem solved in an end-to-end method. So instead of having to break it apart, and you have the first piece coming in and you identify tires, and the second piece is identifying labeling handlebars, and then you bring that together, that if it has handlebars and tires, it's a bicycle, and if it has something that looks like a large square, it's probably a truck. The neural networks does this all in one network. You don't really know what's going on in all those weights and all those little bubbles, but it does it pretty much in one package. That's why the neural network systems are so big nowadays and coming into their own. Best features are selected by the system, and this is important. They kind of put it's on a bullet on the side here. It's a subset of machine learning. This is important. When we talk about deep learning, it is a form of machine learning. There's lots of other forms of machine learning, data analysis, but this is the newest and biggest thing that they apply to a lot of different packages, and they use all the other machine learning tools available to work with it. And it's very fast to test. You put in your information, you then have your group of tests, and then you held some aside, you see how does it do. It's very quick to test it and see what's going on with your deep learning and your neural network. Are they really all that different? AI versus machine learning versus deep learning. Concepts of AI. So we have concepts of AI. You'll see natural language processing, machine learning, an approach to create artificial intelligence. So it's one of the subsets of artificial intelligence. Knowledge representation, automated reasoning, computer vision, robotics. Machine learning versus AI versus deep learning, or AI and machine learning and deep learning. So when we look at this, we have AI with machine learning and deep learning. And so we're going to put them all together. We find out that AI is the big picture. We have a collection of books. It goes through some deep learning. The digital data is analyzed. Text mining comes through. The particular book you're looking for, maybe it's a genre of books, is identified. And in this case, we have a robot that goes and gives a book to the patron. I have yet to be at a library that has a robot bring me a book, but that will be cool when it happens. So we'll look at some of the pieces here. This information goes into, as far as this example, the translation of the handwritten printed data to digital form. That's pretty hard to do. That's pretty hard to go in there and translate hundreds and hundreds of books and understand what they're trying to say if you've never read them. So in this case, we used a deep learning because you can already use examples where they've already classified a lot of books, and then they can compare those texts and say, oh, okay, this is a book on automotive repair. This is a book on robotic building. The digital data is then analyzed. Then we have more text mining using machine learning. So maybe we'd use a different program to do a basic classify what you're looking for and say, oh, you're looking for auto repair and computers. So you're looking for automated cars. Once it's identified, then of course it brings you the book. So here's a nice summation of what we were just talking about. AI with machine learning and deep learning. Deep learning is a subset of machine learning, which is a subset of artificial intelligence. So you can look at artificial intelligence as the big picture. How does this compare to the human experience in either doing the same thing as a human we do, or it does it better than us? And machine learning, which has a lot of tools, is something that learns from data, past experiences. It's programmed. It comes in there and it says, hey, we already had these 5 things happen. The 6th one should be about the same. And then there's a lot of tools in machine learning, but deep learning then is a very specific tool in machine learning. It's the artificial neural network, which handles large amounts of data and is able to take huge pools of experiences, pictures, and ideas and bring them together. Real life examples. Artificial intelligence, news generation. Very common nowadays as it goes through there and finds the news articles or generates the news based upon the news feeds or the backend coming in and says, okay, let's give you the actual news based on this. There's all the different things. Amazon Echo, they have a number of different Prime Music on there. Of course, there's also the Google Command, and there's also Cortana. There's tons of smart home devices now where we can ask it to turn the TV on or play music for us. That's all artificial intelligence. From front to back, you're having a human experience with these computers and these objects that are connected to the processing. Machine learning, spam detection, very common. Machine learning doesn't really have the human interaction part. So this is the part where it goes and says, okay, that's a spam, that's not a spam, and it puts it in your spam folder. Search engine result refining, another example of machine learning, whereas it looks at your different results and it is able to categorize them as far as this had the most hits, this is the least viewed, this has 5 stars, however they want to weight it. All good examples of machine learning. And then the deep learning. Deep learning, another example is as you have like a exit sign. In this case, is translating it into French. Sortie. I hope I said that right. The neural network has been programmed with all these different words and images, and so it's able to look at the exit in the middle, and it goes, okay, we want to know what that is in French, and it's able to push that out in French, and learn how to do that. And then we have chatbots. I remember when Microsoft first had their little paperclip. Boy, that was like a long time ago. They came up and you would type in there and chat with it. These are growing. It's nice to just be able to ask a question and it comes up and gives you the answer. And instead of it being where you're just doing a search on certain words, it's now able to start linking those words together and form a sentence in that chat box. Types of AI and machine learning. Types of artificial intelligence. This and the next few slides are really important. So one of the types of artificial intelligence is reactive machines. Systems that only react. They don't form memories, they don't have past experiences, they have something that happens to them and they react to it. My washing machine is one of those. If I put a ton of clothes in it and they get all clumped on one side, it automatically adds a weight to recenter it. So that my washing machine is actually a reactive machine working with whatever the load is and keeps it nice, and so when it spins it doesn't go thumping against the side. Limited memory. Another form of artificial intelligence. Systems look into the past. Information is added over a period of time and information is short-lived. When we're talking about this, and you look at like a neural network that's been programmed to identify cars, it doesn't remember all those pictures. It has no memory as far as the hundreds of pictures you process through it. All it has is, this is the pattern I use to identify cars as the final output for that neural network we looked at. So when they talk about limited memory, this is what they're talking about. They're talking about, I've created this based on all these things, but I'm not going to remember any one specifically. Theory of mind. Systems being able to understand human emotions and how they affect decision making to adjust their behaviors according to their human understanding. This is important because this is our page mark. This is how we know whether it is an artificial intelligence or not. Is it interacting with humans in a way that we can understand? Without that interaction, is just an object. So when we talk about theory of mind, we really understand how it interfaces. That whole, if you're in web development, user experience would be the term I would put in there. So the theory of mind would be user experience. How is the whole UI connected together? And one of the final things is, as we get into artificial intelligence, is systems being aware of themselves, understanding their internal states, and predicting other people's feelings and act appropriately. So as artificial intelligence continues to progress, we see ones that are trying to understand, well, what makes people happy? How would they increase our happiness? How would they keep themselves from breaking down if something's broken inside? They have that self-awareness to be able to fix it. And just based on all that information, predicting which action would work the best. What would help people? If I know that you're having a cup of coffee first thing in the morning is what makes you happy, as a robot, I might make you a cup of coffee every morning at the same time to help your life and help you grow. That'd be the self-awareness, is being able to know all those different things. Types of machine learning, and like I said on the last slide, this is very important. This is very important. If you decide to go in and get certified in machine learning or know more about it, these are the three primary types of machine learning. The first one is supervised learning. Systems are able to predict future outcome based on past data. Requires both an input and an output to be given to the model for it to be trained. So in this case, we're looking at anything where you have 100 images of a bicycle, and those 100 images are bicycle. So they're preset. Someone already looked at all 100 images and said, these are pictures of bicycles. And so the computer learns from those, and then it's given another picture, and maybe the next picture is a bicycle, and it says, oh, that resembles all these other bicycles, so it's a bicycle. And the next one's a car, and it says, it's not a bicycle. That would be supervised learning, because we had to train it. We had to supervise it. Unsupervised learning. Systems are able to identify hidden patterns from the input data provided by making the data more readable and organized. The patterns, similarities, or anomalies become more evident. You'll heard the term cluster. How do you cluster things together? Some of these things go together, some of these don't. This is unsupervised, where it can look at an image and start pulling the different pieces of the image out because they aren't the same. All the parts of the human are not the same as a fuzzy tree behind them because it's slightly out of focus, which is not the same as the beach ball. It's unsupervised because we never told it what a beach ball was, we never told it what the human was, and we never told it that those were trees. All we told it was, hey, separate this picture by things that don't match and things that do match and come together. And finally, there's reinforcement learning. Systems are given no training. It learns on the basis of the reward punishment it received for performing its last action. It helps increase the efficiency of a tool function or a program. Reinforced learning, or reinforcement learning, is kind of, you give it a yes or no. Yes, you gave me the right response. No, you didn't. And then it looks at that and says, oh, okay, so based on this data coming in, what I gave you was a wrong response, so next time I'll give you a different one. Comparing machine learning and deep learning. So remember that deep learning is a subcategory of machine learning. So it's one of the many tools. And so we're grouping a ton of machine learning tools all together. Linear regression, k-means clustering. There's all kinds of cool tools out there you can use in machine learning. Enables machines to make decisions on their own based on past data. Enables machines to make decisions with the help of artificial neural networks. So it's doing the same thing, but we're using an artificial neural network as opposed to one of the more traditional machine learning tools. Needs only a small amount of training data. This is very important. When you're talking about machine learning, they're usually not talking about huge amounts of data. We're talking about maybe your spreadsheet from your business and your totals for the end of the year. When you're talking about neural networks, you usually need a large amount of data to train the data. So there's a lot of training involved. If you have under 500 points of data, that's probably not going to go into machine learning. Or maybe you have, like the case of one of the things, 500 points of data and 30 different fields. It starts getting really confusing there in artificial intelligence or machine learning, and the deep learning aspect really shines when you get to that larger data that's really complex. Works well on a low-end systems. So a lot of the machine learning tools out there you can run on your laptop with no problem and do the calculations there. Where with the machine learning, you usually needs a higher end system to work. It takes a lot more processing power to build those neural networks and to train them. It goes through a lot of data. We're talking about the general machine learning tools. Most features need to be identified in advance and manually coded. So there's a lot of human work on here. The machine learns the features from the data it is provided. So again, it's like a magic box. You don't have to know what a tire is. It figures it out for you. The problem is divided into parts and solved individually and then combined. So in machine learning, you usually have all these different tools and use different tools for different parts. And the problem is solved in an end-to-end manner. So you only have one neural network or two neural networks that is bringing the data in and putting it out. It's not going through a lot of different processes to get there. And remember, you can put machine learning and deep learning together. So you don't always have just the deep learning solving the problem. You might have it solving one piece of the puzzle. With regular machine learning and most of the machine learning tools out there, they take longer to test and understand how they work. And with the deep learning, it's pretty quick. Once you build that neural network, you test it and you know. So we're dealing with very crisp rules, limited resources. You have to really explain how the decision was made when you use most machine learning tools. But when you use the deep learning tool inside the machine learning tools, the system takes care of it based on its own logic and reasoning. And again, it's like a magic black box. You really don't know how it came up with the answer. You just know it came up with the right answer. A glimpse into the future. So a quick glimpse into the future, artificial intelligence, using it to detecting crimes before they happen, humanoid AI helpers, which we already have a lot of. There'll be more and more. Maybe it'll actually be androids. That'd be cool to have an android that comes and gets stuff out of my fridge for me. Machine learning, increasing efficiency in healthcare. That's really big in all the forms of machine learning. Better marketing techniques. Any of these things, if we get into the sciences, it's just off the scale. Machine learning and artificial intelligence go everywhere. And then the subcategory deep learning, increased personalization. So what's really nice about the deep learning is it's going to start now catering to you. That'll be one of the things we see more and more of. And we'll have more of a hyper-intelligent personal assistant.
Simplilearn's postgraduate program in AI and machine learning from Purdue University in collaboration with the IBM should be your right choice. For more details, check out the link mentioned in the description box below. With that in mind, let's hand over this session to a training expert.
Everyone knows the algorithm is a step-by-step process to approach a particular problem. There are numerous examples of algorithm, from figuring out sets of numbers to finding routes through maps to showing data on a screen. Let's understand this by using an example. Every algorithm is built on inputs and outputs. Google search algorithm is no different. The input is the search field and the output is the page of result that appears when you enter a particular phrase or keyword, also known as SERP or Search Engine Result Page. Google has a search algorithm so it can sort results from various websites and provides the user the best result. When you start a search, you will see the search box will attempt to guess what you are looking for. In order to better understand what the user is looking for, the algorithm is trying to gather as many suggestions from them as possible. The results from the search field that best matches the query will be ranked. The choose with website will rank and in what position using more than 200 ranking variables. Now let's take an example of coding program and see how the algorithm works. Here we will use a case of computer program wherein we want to print the multiplication table of any number. Let's take 2. The algorithm starts here and then it assigns a value to a variable. The variable I is having an initial value of 1. The system will read the number. The number in case is 2. Now the system has a condition. A condition can now either be true or false. If the value of I reaches 11, then the loop will end. Otherwise, value of I will multiply by the number. The initial value of I is 1. So for the first time, the system output will be 2. Now value of I will be increased by 1. According to the loop condition, the system will then move back and check for the condition again. The new value of I is 2, which is still less than 11. The system will again print 2 into I, which is 2 into 2 on the screen. The new output result will be 4. The system will keep following the same procedure repeatedly until the value of I becomes 11. Once the value of I becomes 11, then only the algorithm will terminate. After discussing how an algorithm works, let's move forward and see some popular machine learning algorithms. Some popular machine learning algorithms are: first one is linear regression algorithm, second one is logistic regression algorithm, and the third one is decision tree, and the fourth one is support vector machine algorithm SVM, and the fifth one is KNN, K nearest neighbor algorithm, and the sixth one is K means clustering algorithms, and the seventh one is random forest algorithms, and the last but not the least algorithm is a priori algorithms. Let's go through them in detail one by one. Linear regression is one of the most famous and straightforward machine learning algorithms utilized for predictive analysis. Linear regression shows the linear connection between the dependent and the independent factors. The equation of line is y equals to mx plus b. Here, y stands for the response variable or a dependent variable, whereas x is for the predator variable or an independent variable. It attempts best to fit line between the dependent and the independent variables, and this best fit line is known as line of regression or regression line. Let's take a real application example. In predicting consumer behavior, businesses use linear regression to forecast things like how much a client is likely to spend. Things like targeted marketing and product development may benefit from this. Walmart, for instance, used linear regression to forecast which good would be in high demand across the nation. Moving forward, let's see types of linear regression. There are two types of linear regression algorithm. The first one is simple linear regression and the second one is multiple linear regression. In simple linear regression, if an independent variable is utilized to forecast the worth of a mathematical dependent variable, then at that point, such a linear regression algorithm is called simple linear regression. The equation of line will be y equals to a0 plus a1x. And the second one is multiple linear regression. If the dependent variable declines on the y and the independent variable on the x, then such a relationship is known as negative linear relationship. The line of equation will be minus of a0 plus a1x. Moving forward, let's see logistic linear regression. Logistic regression is the supervised machine learning algorithm utilized to anticipate all the categorical factors or discrete values. It could be very well used for the grouping issues in machine learning. And the result of the logistic regression can be either yes or no, 0 or 1, man or woman, and so on. It gives the values which lies between 0 and 1. For example, a credit card business is interested in knowing whether the transaction amount and the credit score have an impact on the probability that a particular transaction would be fraudulent. The business can use logistic regression to determine how these two predator values can relate the probability that a transaction is fraudulent. The response variable in the model has two possible outcomes. First one is the transaction is fraudulent, and the second one is the transaction is not fraudulent. In logistic regression, rather than fitting a regression line, we fit an S-form logistic capability, which predicts two greatest values, 0 or 1. The logistic regression equation can be calculated from linear regression equation. The steps to get logistic regression equations are: the equation of a straight line can be written as y equals to b0 plus b1x1 plus b2x2 till bn xn. In logistic regression, y can be between 0 and 1 only. So for that, let's divide the above equation by 1 minus y. then the equation will be y upon 1 minus y, that is 0 for y0 and infinity for y equals to 1. But range between minus infinity to plus infinity, then we have to take the logarithm of equation, and now it will become log of y upon 1 minus y equals to b0 plus b1 x1 plus b2 x2, so on till bn xn. Let's move forward and see types of logistic regression. There are three types of logistic regression that can be classified. First one is binomial. In binomial logistic regression, there can be only two possible types of dependent variables like yes or no, pass or fail, man, woman, and many more. And the second one is multinomial. In multinomial logistic regression, there can be three or more possible unordered ways of dependent variable such as horse, cow, and sheep. And the last one is ordinal. In ordinal logistic regression, there can be three or more possible ordered ways of dependent variable, such as small, medium, or large. Moving forward, let's see decision trees in detail. A decision tree is a tree structured classifier that could be used for classification and regression. A decision tree is a tree in which each non-leaf node is assigned to an attribute. Additionally, each arc contains one of the available values for its parent node, which is associated with each leaf node, that is, the node from where the arc is directed. Let's see some decision tree terminology. First one is root, that contains the entire dataset. The next one is node, a test for the data of a certain attribute. And the third one is branch, which connect the node to internal node or the internal node to leaf node. And the fourth one is leaf node, the terminal node that predicts the outcome. Let's move forward and see decision tree algorithms. The first one is select the best attribute to use the current node in the tree. The second one is for each possible values, select the attributes. The third one is partition the examples using the possible values of this attribute and assign these disjoint subset of the example to the appropriate child node. Recursively generate each child node until ideally all examples for a node have the same label, like class. Moving forward, let's understand the decision tree. For building a decision tree, step 1 is select an attribute. Then split the data into its children in a tree. Continue splitting with available attributes and keep splitting until leaf nodes are pure, like only one class remains, a maximum depth is reached, a performance metric is achieved. Let's move forward and see SVM algorithm, support vector machine algorithms. A support vector machine is a well-known supervised machine learning model. It is utilized for both information, classification, and regression. It is regularly utilized for the grouping issues. We can involve it in different life care systems, and we can involve it in typically happy or sad look arrangements. We can involve it in filters. If we make specific looks, it would add the particular filter according to the expression. The scope of articulation lies between happy and sad. Support vector machine helps in to recognize handwritten characters used widely, like checks continue to be a significant part of the majority of non-cash transactions and are frequently written by the pupil. The current check processing system in many developing nations involves a bank employee to read and manually enter the information in a check, while also verifying the data like signature and date. A handwritten text recognition system can reduce expenses and labor hours because a bank must handle several checks each day. Moving forward, let's see the algorithm of SVM. The objective of support vector machine is to make the best line or choice limit that can isolate n-dimensional space into classes. So we can undoubtedly put the new data of interest in the right category. Later on, this best decision boundary is known as a hyperplane. Let's move forward and see types of support vector machine. Support vector machine can be of two types. First one is linear SVM, second one is non-linear SVM. Let's move forward and see linear SVM. Linear SVM is utilized for linearly detachable information, which implies if a dataset can be ordered into two classes by utilizing a straight line, then such information are named linearly separable information. and a classifier is utilized called linear SVM classifier. Moving forward, let's see nonlinear SVM. Nonlinear SVM is utilized for non-directly isolated information, and that implies in the event that a dataset can't be categorized by utilizing a straight line. Such information is named non-directed information, and the classifier utilized is called a nonlinear SVM classifier. Moving forward, let's see KNN algorithm in detail. KNN is a supervised learning technique. KNN classifies new data into a targeted classes depending on the features of its neighboring points and also be used for the regression problems. It is an instance-based learning algorithm and a bit lazy learning algorithm. KNN calculation stores every one of its accessible information and orders another information point based on the likeliness. This means that when new data information appears, it usually tends to be successfully categorized into a good suit classes using the KNN algorithm. Let's imagine we have an image of animal that resembles a cow or ox. However, here we are not sure if it is a cow or ox. As KNN method is based on a likeness matrix, it will identify the properties of new data that are related to the image of cow or ox. And based on those quality, it will classify the data as belonging to either cow or ox group. Moving forward, let's see how does KNN work. The steps to implement KNN algorithms are: Step 1. Decide on the neighbors' k numbers. Step 2. Calculate the Euclidean distance between k neighbors in step 2. Third one is, based on the determined Euclidean distance, select the k closest neighbors. Step 4 is, count the numbers of data points in each category between these k neighbors. Step 5. Assign the fresh data points in the category where the highest neighbors count. And then KNN model is ready. Let's say we need to add a new data point to the vital category. At first, we will decide on the numbers of neighbors. Therefore, we will pick k equals to 5. Then, the Euclidean distance between the data points and then can be determined. The distance between 2 points, known as the Euclidean distance, can be determined by under root of x2 minus x1 का whole square plus y2 minus y1 whole square. Then we determine the closest neighbors by calculating the Euclidean distance. There are 3 closest neighbors in category A and 2 closest neighbor in category B. This new data point must fall within category A because, as we can see, its 3 closest neighbors are also from group A. After understanding KNN algorithm, let's move forward and see k-means algorithms in detail. The k-means is a cluster false. Under that is an unsupervised learning algorithm. It is used to address machine learning clustering problems and utilized to tackle the grouping issues in machine learning. It permits us to bunch the information into various gatherings. It is a helpful method for finding the classification of groups in the unlabeled dataset without the requirement of any training. This k-means algorithm groups the data into similar classes. Let's see some application of k-means clustering. Diagnostic system. The medical profession uses k-means clustering in creating smarter medical decision support system, especially in the treatment of liver alignments. The second one is search engines. Clustering forms a backbone of search engine. When a search engine is performed, the search result need to be grouped, and the search engines very often use clustering to do this. Moving forward, let's see how k-means algorithm works. The steps to implement k-means algorithms are: Step 1. Select the number k to set the number of clusters. Step 2. Select a random k points or centroid. Step 3. Assign each data point the closest centroid that forms to predefined k cluster. Step 4. Determine the variance and set a new gravity points for each cluster. Step 5. Repeat the third step. This means reallocating each data point to the new closest centroid cluster. Step 6. If a reassignment occurs, go to step 4, otherwise go to exit. Step 7. The model is ready to use. So now we have a clear understanding of how k-means algorithm work. Let's move forward to see the graphical representation of k-means algorithm. Consider that there are two variables m1 and m2. This is a scatter plot of these two variables along the x and y axis. We should accept the number of k of bunches, that is k equals to 2, to recognize the dataset and to place them into various groups. It implies here we will attempt to bunch these datasets into two unique groups. We will really want to pick an irregular key point or centroid to frame this group. These centroids can be either the focus of the dataset or some of other points. Thus, here we are choosing under 2 points as k points, which are not the piece of our dataset. We will assign every data of interest in the scatter plot to the nearest k point or centroid. We will register it by applying some math that we consider to find the distance between 2 points, that is Euclidean distance. Thus, we will draw a median between both the centroids. From the graph, the left half of the line are close points to the right and the K1 centroid. Green is near the orange centroid. We should variety them as green and orange for clear representation. As the need might arise to track down the nearest group, we will repeat the cycle by picking another centroid. To pick the new centroid, we will figure out the center point of gravity of these centroids and will track down new centroids. Then we will reassign every piece of information to highlight new centroid. For this, we will repeat a similar course of tracking down a middle line. The middle will be like as seen in the picture. One orange point is on the left half of the line and two green points are on the right. Thus, these 3 points will be appointed to the new centroids. As reassignment has occurred, we will again go to step 4, tracking down new centroids or K points. We will repeat the cycle by tracking down the center point of gravity of centroids. So the new centroids will be displayed as like this. We now have new centroids, so once more define the middle boundary and reassign the data of interest. By this graph, there are no unique pieces of information on one or the other side of the line, implying our model is shaped. By the previous graph, there are no unique pieces of information on one or the other line, implying our model is shaped. As our k-means model is ready, and the two last groups will be displayed as like these. Now we have a clear understanding of how k-means clustering algorithm works. Now let's move forward to understand random forest algorithm. Random forest is an adaptable, simple to utilize machine learning algorithm that produces, even without the hyperboundary tuning, an extraordinary outcome more often than not. It is likewise quite possibly the most utilized algorithm because of its effortlessness and variety. Like it tends to be utilized for both grouping and classification tasks. Random forest is a classifier that contains various choice trees on different subsets of the given dataset and takes the normal to work on the present exactness of the dataset. Instead of depending on the choice tree, the random forest takes the forecast from each tree and in light of the larger part of votes of expectation, it predicts the final result. Now let's move forward and see how does random forest work. We should see the random forest in order since the arrangement is now and again thought to be the structure block of machine learning. This is what a random forest would look like with two trees. The random forest has a similar hypermeter to our decision tree or a Bayesian classifier. Luckily, there is a compelling reason need to consolidate a decision tree with a Bayesian classifier, since you can undoubtedly utilize the classifier classes of random forest. With random forest, you can likewise manage tasks using the algorithm regression. Random forests add extra arbitrariness to the model while developing the trees, rather than looking for the main element while parting a node. It looks to the best component among an irregular subset of highlights. These outcomes in a wide variety often result in a superior model. Subsequently, in a random forest, just a random subset of the element is thought about the algorithm. You might make trees more random by involving random edges for each component instead of looking for the most ideal limits like a typical choice tree does. Let's move forward and see some application of random forest algorithms. Random forest is involved at work by researchers in numerous ventures, including banking, stock exchanging, medication, and many more. It is utilized to predict things which assist these businesses with running productively, like client activity, patient history, and safety. In banking, random forest is used to identify clients who are more likely to pay back their debts on schedule. Additionally, it is utilized to forecast who will make more frequent use of bank services. Even fraud detection uses it. The Robin Hood of algorithms, indeed. Random forest is a tool used by stock traders to forecast future stock behavior. Retail businesses utilize it to make product recommendation and forecast client satisfaction. Random forests can be used in healthcare industry to examine a patient medical history and detect disorders. Random forest is a tool used by pharmaceutical experts to determine the ideal mix of ingredients in treatment or to forecast drug sensitivity. By seeing application of random forest algorithm, let's move forward and see some difference between decision trees and random forest. Let's see the difference between random forest and decision tree. The first one is, while building a random forest, the number of rows is selected randomly. In decision trees, it builds several decision trees and find out the output. The second one is, it combines two or more decision trees together. In decision trees, whereas the decision is a collection of variables or datasets or attributes. The third one is, it gives accurate results, whereas it gives less accurate results. The fourth one is, by using random forest, it reduces the chance of overlifting, whereas decision trees, it has the possibility of overlifting. The fifth one is, random forest is more complicated to interpret, whereas the decision tree is simple, it is easy to read and understand. After seeing what is random forest, how it works, let's move forward to see a priori algorithms in detail. The a priori algorithm utilizes standard item sets to create affiliation rules and is intended to chip away the information bases containing exchanges. With the assistance of these affiliation rules, it decides how firmly or feebly two objects are associated. This algorithm utilizes a breadth first search and hash tree to work out the item set association effectively. It is the iterative interaction for finding out the successive item set from the huge dataset. Let's move forward and see steps for a priori algorithms. The steps for a priori algorithms are: step 1 is establish minimal support and confidence for item set in the transactional database. The second one is take all transaction supports with a greater support value, the minimum or chosen support value in step 2. The third one is track down all the rules in these subsets with confidence value greater than the threshold value. The fourth one is arrange the rules to lower the lift. At last, we will see some advantages and disadvantages of a priori algorithm. The advantages of a priori algorithms are easy to understand an algorithm, and the second one is the join and prune steps of the algorithms can be easily implemented on the large dataset. The disadvantages of a priori algorithms are the a priori algorithms work slowly as compared to the other algorithm. And the second one is the a priori algorithms times and space complexity are O of 2D, which is very low compared to the other ones. Let's move forward and see some hands-on lab demo. So we will see a hands-on lab demo on linear regression. As we know, linear regression is a way to find or to predict the relationship between two variables. Generally, we use x and y. So first we will open command prompt to write command to open Jupyter Notebook. So we will here write Jupyter Notebook and then press enter. So this is the landing page of Jupyter Notebook, and select open new Python file. So this is how Jupyter Notebook UI looks like. So at first we will import some major libraries of Python which will help us in mathematical functioning. So the first one is NumPy. NumPy is a Python library used for working with arrays. It also has functions for working in domains like linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. So we will write like import NumPy as NP. Here NP is used for denoting NumPy. So we will import the next library is Pandas. Pandas is a software library written for Python programming for like data manipulation and analysis. In particular, it offers data structures and operation for manipulating numerical labels and time series. So we will write import pandas as PD. Here PD is used for denoting pandas. So our next library is matplotlib. Matplotlib is a graph plotting library in Python that serves as a visualization utility. Matplotlib is open source, so we can use it freely, and it is most written in Python, a few segments in C and JavaScript for platform compatibility. For importing matplotlib, you have to write import matplotlib dot pyplot as plt. So after importing the libraries, we will move ahead and import dataset. So for importing dataset, we have to write dataset equals to pd dot read underscore csv, and here we have to give the path of the file dataset dot csv. Here pd is for pandas library and read is used for reading the dataset from the machine, and csv is used for the type of file which you want to read. So after reading, let's see our data. So we will write dataset dot head and press enter. Here head is used for retrieving the first 5 lines from the data, so our data is coming properly. So moving ahead, now let's first define x and y axis. For x, we have to write x equals to dataset dot ilog bracket colon comma colon again -1 dot values for x axis, and for y axis we have to write y equals to dataset dot ilog bracket colon comma 1 dot values. So if we will use dataset dot ilog for -1 values for x axis, it will select till the second last column of the data frame instead of the last column. And I know this is as the second last column value, and the last column value for the row is different. Whereas if we will use for the y-axis, values return a series vector. A vector does not have a column size. So moving ahead, let's see the value for x and y-axis. First, we will see the value for x, like just you have to write x and press enter. So these are the arrays value for x, and for y-axis you have to type y and then enter. So these are arrays value for y-axis. So after this, now let's split the dataset into training and testing. Separating data into training and testing set is an important part for evaluating data mining models. Typically, when you separate a dataset into a training set and a testing set, most of the dataset is used for training and a similar portion of dataset is used for testing. So we will split it into 70 and 30 ratio. So for splitting, we need to import some more libraries for this process. So we will write from sklearn dot model underscore selection import train underscore test underscore split. Scikit-learn, like sklearn, is most useful and robust library for machine learning in Python. It provides a selection of efficient tools for machine learning and statistical modeling, including classification, regression, and clustering. So after importing, let's write code for the splitting data. So we will write here x underscore train comma x underscore test comma y underscore train comma y underscore test equals to train underscore test underscore split. In brackets we have to write x comma y comma test underscore size equals to 0.3 comma random underscore state equals to 0. With random state equals to 0, we get the same train and test sets across different execution. So after this, let's see the values together. So we will write x underscore train, comma, x underscore test, comma, y underscore train, comma, y underscore test. So these are the values of array x and array y together. Moving ahead, now let's work with regression. First, we need to import the library for regression. So we will use from sklearn dot linear underscore model import linear regression. We already discussed sklearn is used for machine learning and linear regression is a major part of machine learning. So after this, let's make a function for regression as reg for easy use. So we will write reg equals to linear regression and brackets. First we try to train and then test and compare. So we will write here reg dot fit bracket x underscore train, comma, y underscore train. Now let's predict values, but prediction values are always different. So we will predict values for y first. So we will write y underscore predict equals to reg dot predict or x underscore test. So like y underscore predict, then enter. This is when the predict functions come into the picture. Python predict function enables us to predict the labels of the data values on the basis of training model. The predict function accepts only a single argument, which is x underscore test here, usually the data to be tested. So when you will check the value for y test, you will see the different values like y underscore test. So you can see there are totally different values from x-axis. Now let's display on graph for training dataset. So we have to write plt dot scatter x underscore train, comma, y underscore train, comma, color equals to, you can choose by yourself, I will choose red, and then plt dot plot x underscore train, comma, regression point for predicting values for x underscore train, comma, color equals to blue. So this color is for the regression line, and the plt dot title linear regression salary versus experience, and I will prefer the size would be 18. So let's set the labels for x and y axis. So x label year of employee, comma, size will be, I will prefer size will be 50. Then for y axis we will write here like salaries of employee, and I will prefer the same size 15. Let's show the plot by writing plt.show. Then hopefully we are fortunate, everything is going to be fine. Perfect. So you can see we have linear regression line fitting through our data set. So this is how the linear regression work for training dataset. Let's see how it will work for testing dataset. Now let's predict for test dataset. You can copy for the same and like you can change it. So we can copy here. So we can paste here. So we have to just change here train to test dataset. Test here, then again test here, then again test here. Everything we will reduce some size to 16. Let's see, then it will use 12 and it will be 12 and so perfect. So you can see we have linear regression line fitting through our dataset. So this is how the linear regression works for testing dataset.
If you are an aspiring AI/ML engineer, then there is no better time to train yourself in an exciting field of machine learning. If you are looking for a course that covers everything from fundamentals to advanced techniques like machine learning algorithm development and unsupervised learning, look no further than our Caltech in partnership with IBM. So why wait? Join now. Seats are filling fast. Find the course link from the description box below.
So what is the SciKit Learn? It's simple and efficient tool for data mining and data analysis. It's built on NumPy, SciPy, and Matplot library, so it interfaces very well with these other modules. And it's an open source, commercially usable BSD license. BSD originally stood for Berkeley Software Distribution License, but it means it's open source with very few restrictions as far as what you can do with it. Another reason to really like the SciKit Learn setup, so you don't have to pay for it as a commercial license versus many other copyrighted platforms out there. What we can achieve using the SciKit Learn, we use the two main things are classification and regression models. Classification, identifying which category an object belongs to. For one application very commonly used is spam detection. So is it a spam or is it not a spam? Yes, no. In banking, it might be, is this a good loan, bad loan? Today we'll be looking at wine. Is it going to be a good wine or a bad wine? And regression is predicting an attribute associated with an object. One example is stock prices prediction. What is going to be the next value? If the stock today sold for $23.05 a share, what do you think it's going to sell for tomorrow and the next day and the next day? So that'd be a regression model. Same thing with weather forecasting. Any of these are regression models where we're looking at one specific prediction on one attribute. Today we will be doing classification. Like I said, we're going to be looking at whether a wine's good or bad. But certainly the regression model, which is in many cases more useful because you're looking for an actual value, is also a little harder to follow sometimes. So classification is a really good place to start. We can also do clustering and model selection. Clustering is taking an automatic grouping of similar objects into sets. Customer segmentation is an example. So we have these customers like this, they'll probably also like this. Or if you like this particular kind of features on your objects, maybe you like these other objects. So a referral is a good one, especially on Amazon.com or any of your shopping networks. Model selection, comparing, validating, and choosing parameters and models. Now, this is actually a little bit deeper as far as a SciKit Learn. We're looking at different models for predicting the right course or the best course or what's the best solution. Today, like I said, we're looking at wines. So it's going to be, well, how do you get the best wine out of this? So we can compare different models, and we'll look a little bit at that, and improve the model's accuracy via different parameters and fine tuning. Now, this is only part one, so we're not going to do too much tuning on the models we're looking at, but I'll point them out as we go. Two other features, dimensionality reduction and pre-processing. Dimensionality reduction is we're reducing the number of random variables to consider. This increases the model efficiency. We won't touch that in today's tutorial, but be aware if you have, thousands of columns of data coming in, thousands of features, some of those are going to be duplicated, or some of them you can combine to form a new column, and by reducing all those different features into a smaller amount, you can increase the efficiency of your model. It can process faster, and in some cases you'll be less biased, because if you're weighing it on the same feature over and over again, it's going to be biased to that feature. And pre-processing. These are both pre-processing, but pre-processing is feature extraction and normalization. So we're going to be transforming input data such as text for use with machine learning algorithms. We'll be doing a simple scaling in this one for our pre-processing, and I'll point that out when we get to that, and we can discuss pre-processing at that point. With that, let's go ahead and roll up our sleeves and dive in and see what we got here. Now, I like to use the Jupyter Notebook, and I use it out of the Anaconda Navigator. So if you install the Anaconda Navigator, by default, it will come with the Jupyter Notebook, or you can install the Jupyter Notebook by itself. This code will work in any of your Python setups. I believe I'm running an environment of 3.7 setup on there. I'd have to go in here into environments and look it up for the Python setup. But it's one of the 3X's. And we go ahead and launch this, and this will open it up in a web browser. So it's kind of nice. It keeps everything separate. And in this Anaconda, you can actually have different environments, different versions of Python, different modules installed in each environment. So it's a very powerful tool if you're doing a lot of development. And the Jupyter Notebook is just a wonderful visual display. Certainly you can use, I know Spider is another one which is installed with the Anaconda. I actually use a simple Notepad++ when I'm doing some of my Python script. Any of your IDEs will work fine. Jupyter Notebook is Iron Python because it's designed for the interface, but it's good to be aware of these different tools. And when I launch the Jupyter Notebook, it'll open up, like I said, a web page in here. And we'll go over here to New and create a new Python setup. And like I said, I believe this is Python 3.7, but any of the three, the SciKit Learn works with any of the 3X's. There's even 2.7 versions. So it's been around a long time. So it's very big on the development side. And then the guys in the back, guys and gals, they went ahead and put this together for me. And let's go ahead and import our different packages. Now, if you've been reading some of our other tutorials, you'll recognize pandas as PD. Pandas library is pretty widely used. It's a data frame setup, so it's just like columns and rows in a spreadsheet with a lot of different features for looking stuff up. Seaborn sits on top of Matplot libraries. This is for our graphing, and we'll see that how quick it is to throw a graph out there to view in the Jupyter Notebook for demos and showing people what's going on. And then we're going to use the random forest, the SVC or support vector classifier, and also the neural network. So we're going to look at this. We're actually going to go through and look at 3 different classifiers that are most common, some of the most common classifiers, and let's show how those work in the SciKit Learn setup and how they're different. And then if you're going to do your setup on here, you'll want to go ahead and import some metrics. So the sklearn.metrics on here, and we're going to use the confusion metrics and the classification report out of that. And then we're going to use from the sklearn pre-processing the standard scalar and label encoder. Standard scalar is probably the most commonly used pre-processing. There's a lot of different pre-processing packages in the sklearn. And then model selection for splitting our data up. It's one of the many ways we can split data into different sections. And the last line here is our percentage matplot library inline. Some of the Seaborn and matplot library will go ahead and display perfectly inline without this, and some won't. It's good to always include this when you're in the Jupyter Notebook. This is Jupyter Notebook, so if you're in an IDE, when you run this, it will actually open up a new window and display the graphics that way. So you only need this if you're running it in a editor like this one, with specifically Jupyter Notebook. I'm not even familiar with other editors that are like this, but I'm sure they're out there. I'm sure there's a Firefox version or something. Jupyter Notebook just happens to be the most widely used out there. And we can go ahead and hit the run button, and this now has saved all this underneath the packages. So my packages are now all loaded. I've run them, whether you run it on top or you run it to the left, and all the packages are up there, so we now have them all available to us for our project we're working on. And I'm just going to make a little side note on that. When you're playing with these and you delete something out and add something in, even if I went back and deleted this cell and just hit the scissors up here, these are still loaded in this kernel. So until I go under kernel and restart and clear or restart and run all, I'll still have access to pandas. Important to know, because I've done that before. I've loaded up, maybe not a module here, but I've loaded up my own code and then changed my mind and wondering, why does it keep putting out the wrong output? And then I realized it's still loaded in the kernel and you have to restart the kernel. Just a quick side note for working with a Jupyter Notebook and one of the troubleshooting things that comes up. And we're going to go ahead and load up our data set. We're using the pandas, so if you haven't yet, go look at our pandas tutorial. A simple read the CSV with the separation on here. So let me go ahead and run that. And that's now loaded into the variable wine. And let's take a quick look at the actual file. I always like to look at the actual data I'm working with. In this case, we have wine quality-red. I'll just open that up. I have it in my open office setup. I'm separated by semicolons. That's important to notice. And when we open that up, you'll see we have, go all the way down here. It looks like 1,600 lines of data minus the first one, so 1,599 lines. And we have a number of features going across. The last one is quality. And right off the bat, we see the quality is has different numbers in it, 5, 6, 7. It's not really, I'm not sure how high of a level it goes, but I don't see anything over a 7. So it's kind of 5 through 7 is what I see here. 5, 6, and 7. 4, 5, 6, and 7, looking to see if there's any other values in there. Looking through the demo to begin with, I didn't realize the setup on this. So you can see there's the different quality values in there: alcohol, sulfates, pH, density, total sulfur dioxide, and so on. Those are all the features we're going to be looking at. And since this is a pandas, we'll just do wine head, and that prints the first 5 rows of data. And that's, of course, a pandas command. And we can see that looks very similar to what we were looking at before. We have everything across here. It's automatically assigned an index on the left. That's what pandas does if you don't give it an index. And for the column names, it has assigned the first row. So we have our first row of data pulled off our comma-separated variable file, in this case semicolon separated. And it shows the different features going across. And we have, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 features. 12 including quality, but that's the one we want to work on and understand. And then because we're in pandas data frame, we can also do wine.info. And let's go ahead and run that. This tells us a lot about our variables we're working with. You'll see here that there is 1,599. That's what I said from the spreadsheet, so that looks correct. Non-null float 64. This is very important information, especially the non-null. So there's no null values in here. That can really trip us up in pre-processing. And there's a number of ways to process non-null values. One is just to delete that data out of there. So if you have enough data in there, you might just delete your non-null values. Another one is to fill that information in with like the average or the most common values or other such means. But we're not going to have to worry about that. But we'll look at another way, because we can also do wine is null and sum it up. And this will give us a similar, it won't tell us that these are float values, but it will give us a summation. Oops, there we go, let me run that. It'll give us a summation on here, how many null values in each one. So if you wanted to, from here you would be able to say, okay, this is a null value, but it doesn't tell you how many are null values. This one would clearly tell you that you have maybe 5 null values here, 2 null values here. And you might just, if you had only 7 null values and all that different data, you'd probably just delete them out. Where if 90% of the data was null values, you might rethink either a different data collection setup or find a different way to deal with the null values. And we'll talk about that just a little bit in the models too, because the models themselves have some built-in features, especially the forest model, which we're going to look at. At this point, we need to make a choice. And to keep it simple, we're going to do a little pre-processing of the data, and we're going to create some bins. And bins we're going to do is 2, 6.5, 8. What this means is that we're going to take those values. If you remember up here, let me just scroll back up here. We had our quality. The quality comes out between 2 and 8, basically, or 1 and 8. We have 5, 5, 5, 6. You can see just in the first 5 lines of variation in quality. We're going to separate that into just 2 bins of quality. And so we've decided to create 2 bins. We have bad and good. It's going to be the labels on those 2 bins. We have a spread of 6.5 and an exact index of 8. The exact index is because we're doing 0 to 8 on there. The 6.5 we can change. We could actually make this smaller or greater, but we're only looking for the really good wine. We're not looking for the 0, 1, 2, 3, 4, 5, 6. We're looking for wines with 7 or 8 on them. So high quality. This is what I want to put on my dinner table at night. I want to taste the good wine, not the semi-good wine or mediocre wine. And then this is a pandas. So PD, remember, stands for pandas. Pandas cut means we're cutting out the wine quality and we're replacing it. And then we have our bins equals bins. That's the command. Bins is the actual command. And then our variable bins, 2, 6.58. So 2 different bins. And our labels, bad and good. And we can also do, let me just do it this way. Wine quality, since that's what we're working on. And let's look at unique. Another pandas command, and we'll run this. And I get this lovely error. Why did I get an error? Well, because I replaced wine quality and I did this cut here, which changes things on here. So I literally altered one of the variables that is saved in the memory. So we'll go up here to the kernel, restart and run all. That starts it from the very beginning. And we can see here that that fixes the error because I'm not cutting something that's already been cut. We have our wine quality unique, and the wine quality unique is bad or good. So we have two qualities objects. Bad is less than good, meaning bad's going to be 0 and good's going to be 1. And to make that happen, we need to actually encode it. So we'll use the label quality equals label encoder. And the label encoder, let me just go back there since this is part of SKLearn. That was one of the things we imported, was a label encoder. You can see that right here from the sklearn.processing import standard scalar, which we're going to use in a minute, and label encoder. And that's what tells it to use bad equals 0 and good equals 1. And we'll go ahead and run that, and then we need to apply it to the data. And when we do that, we take our wine quality that we had before, and we're going to set that equal to label quality, which is our encoder. And let's look at this line right here. We have dot fit transform. And you'll see this in the pre-processing. These are the most common used is fit, transform, and fit transform. Because they're so often that you're also transforming the data when you fit it, they just combine them into one command. And we're just going to take the wine quality, feed it back into there, and put that back in our wine quality setup and run that. And now when we do the wine and the head of the first 5 values, and we go ahead and run this, you can see right here underneath quality 0, 0, 0. Have to go down a little further to look at the better wines. Let's see if we have some that are 1s. Yeah, there we go. There's some 1s down here. So when we look at 10 of them, you can see all the way down to 0 or 1. That's our quality. And again, we're looking at high quality. We're looking at the 7 and the 8s, or 6.5 and up. And let's go ahead and grab our, where was it? Here we go, wine quality. And let's take another look at what else, more information about the wine quality itself. And we can do a simple pandas thing, value counts. Hopefully I typed that in there correctly. And we can see that we only have 217 of our wines which are going to be the higher quality. So 217, and the rest of them fall into the bad bucket, the 0, which is 1,382. So again, we're just looking for the top percentage of these. The top, what is that? It's probably about a little under 20% on there. So we're looking for our top wines, our 7 and 8s. And let's use our, let's plot this on a graph. So we take a look at this. And the SNS, if you remember correctly, that is, let me just go back to the top, that's our Seaborn. Seaborn sits on top of Matplot library. It has a lot of added features, plus all the features of the Matplot library. And it also makes it quick and easy to put out a graph. And we'll do a simple bar graph. And they actually call it count plot. And then we want to just do count plot the wine quality. So let's put our wine quality in there. And let's go ahead and run this and see what that looks like. And nice inline. Remember, this is why we did the inline, so make sure it appears in here. And you can see the blue space, or the first space, represents low quality wine, and our second bar is a high quality line. And you can see that we're just looking at the top quality wine here. Most of the wine, we want to just give it away to the neighbors. No, maybe if you don't like your neighbors. Maybe give them the good quality wine, and I don't know what you do with the bad quality wine. I guess use it for cooking. There we go. But you can see here it forms a nice little graph for us with the Seaborn on there, and you can see our setup on that. So now we've done some pre-processing. We've described our data a little bit. We have a picture of how much of the wine, what we expect it to be, high quality, low quality. Checked out the fact that there's none, we don't have any null values to contend with or any odd values. Some of the other things you sometimes look at these is if you have like some values that are just way off the chart. So the measurement might be off, or miscalibrated equipment if you're in the scientific field. So the next step we want to go ahead and do is we want to go ahead and separate our data set, or reformat our data set. And we usually use capital X, and that denotes the features we're working with. And we usually use a lowercase y. That denotes what, in this case, quality, what we're looking for. And we can take this and we can go wine. It's going to be our full thing of wine. Dropping, what are we dropping? We're dropping the quality. So these are all the features minus quality. And we'll make sure we have our axes equals 1. If you left it out, it would still come out correctly just because of the way it processes on the defaults. And then our y, if we're going to remove quality for our x, that's just going to be wine, and it is just the quality that we're looking at for y. So we put that in there. And we'll go ahead and run this. So now we've separated the features that we want to use to predict the quality of the wine and the quality itself. The next step is if you're going to create a data set and a model, we got to know how good our model is. So we're going to split the data, train and test splitting data. And this is one of the packages we imported from SKLearn. And the actual package was train test split, and we're going to do x, y, test size 0.2, random state 42. And this returns 4 variables, and most common you'll see is capital X train, that's what we're going to train our set with. Capital X test, that's the data we're going to keep on the side to test it with. Y train, Y remember stands for the quality or the answer we're looking for. So when we train it, we're going to use X train and Y train, and then Y test to see how good our X test does. And the train test split, let me just go back up to the top. That was part of the sklearn model selection, import train test split. There is a lot of ways to split data up. This is, when you're first starting, you do your first model, you probably start with the basics on here. You have one test for training, one for test. Our test size is 0.2 or 20%. And random state just means we just start with it's like a random seed number, so it's not too important back there. We're randomly selecting which ones we're going to use. Since this is the most common way, this is what we're going to use today. There is, and it's not even an sklearn package yet, so someone's still putting it in there. One of the new things they do is they split the data into thirds, and then they'll run the model on they combine each of those thirds into 2 thirds for training and 1 for testing. And so you actually go through all the data and you come up with 3 different test results from it, which is pretty cool. That's a pretty cool way of doing it. You could actually do that with this by just splitting this into thirds, and then, or have a test set, one test set third, and then split the training set also into thirds, and also do that and get 3 different data sets. This works fine for most projects, especially when you're starting out. It works great. So we have our X train, our X test, our Y train, and our Y test. And then we need to go ahead and do the scalar. And let's talk about this because this is really important. Some models do not need to have scaling going on. Most models do. And so we create our scalar variable. We'll call it SC, standard scalar. And if you remember correctly, we imported that here, along with the label encoder, the standard scalar setup. So there's our scalar, and this is going to convert the values. Instead of having some values that go from 0, if you remember up here we had some values are 54, 60, 40, 59, 102. So our total sulfur dioxide would have these huge values coming into our model. And some models would look at that and they'd become very biased to sulfur dioxide. It'd have the hugest impact. And then a value that had 0.076, 0.098, or chlorides would have very little impact because it's such a small number. So when we take the scalar, we kind of level the playing field. And depending on our scalar, it sets it up between 0 and 1 a lot of times is what it does. Let's go ahead and take a look at that. And we'll go ahead and start with our X train. And our X train equals SC fit transform. We talked about that earlier. That's an sklearn setup. It's going to both fit and transform our X train into our X train variable. And if we have an X train, we also need to do that to our test. And this is important because you need to note that you don't want to refit the data. We want to use the same fit we used on the training as on the testing. Otherwise, you get different results. And so we'll do just, not fit, transform. We're only going to transform the test side of the data. So here's our X test that we want to transform. And let's go ahead and run that. And just so we have an idea, let's go ahead and take and just print out our X train. Let's do first 10 variables, very similar to the way you do the head on a data frame. You can see here our variables are now much more uniform, and they've scaled them to the same scale, so they're between certain numbers. And with the basic scalar, you can fine-tune it. I just let it do its defaults on this, and that's fine for what we're doing. In most cases, you don't really need to mess with it too much. It does look like it goes between like probably -2 to 2 or something like that. That's just looking at the train variable. We'll go ahead and cut that one out of there. So before we actually build the models and start discussing the sklearn models we're going to use, we covered a lot of ground here. When you're working with these models, you put a lot of work into prepping the data. So we looked at the data, noticed that it's separated, loaded it up. We went in there, we found out there's no null values. That's hard to say, no null values. We have, there's none null value. I can't say it. And of course we sum it up. If you had a lot of null values, this would be really important coming in here. So is there a null summary? We looked at pre-processing the data as far as the quality. And we're looking at the bins. So this would be something you might start playing with. Maybe you don't want super fine wine. You don't want the 7 and 8s. Maybe you want to split this differently. So certainly you can play with the bins and get different values and make the bins smaller or lean more towards the lower quality. So you then have like medium to high quality. And we went ahead and gave it labels. Again, this is all pandas we're doing in here, setting it up with unique labels and group names. Bad, good, bad is less than good. That can be so important. You don't know how many times people go through these models and they have them reversed or something. And then they go back and they're like, why is this data not looking correct? So it's important to remember what you're doing up here and double check it. And we used our label encoder. So that was to set that up as quality 0, 1. Good, in this case we have bad, good, 0, 1. And we just double check that to make sure that's what came up in the quality there. And then we threw it into a graph because people like to see graphs. I don't know about you, but you start looking at all these numbers and all this text and you get down here and you say, oh, yes, here, this is how much of the wine we're going to label as subpar, not good. And this is how much we're going to label as good. And then we got down here to finally separating out our data so it's ready to go into the models. And the models take X and a Y. In this case, X is all of our features minus the one we're looking for, and then Y is the features we're looking for. So in this case, we dropped quality, and in the Y case, we added quality. And then because we need to have a training set and a test set so we can see how good our models do, we went ahead and split the models up: X train, X test, Y train, Y test. And that's using the train test split, which is part of the sklearn package. And we did, as far as our testing size, 0.2 or 20%. The default is 25%, so if you leave that out, it'll do default setup. And we did a random state equals 42. If you leave that out, it'll use a random state. I believe it's default 1. I'd have to look that back up. And then finally, we scaled the data. This is so important to scale the data. Going back up to here, if you have something that's coming out as 100, it's going to really outweigh something that's 0.071. That's not in all the models. Different models handle it differently. And as we look at the different models, I'll talk a little bit about that. We're going to only look at 3 models today, 3 of the top models used for this, and see how they compare and how the numbers come out between them. So we're going to look at 3 different setups. Oh, let me change my cell here to markdown. There we go. And we're going to start with the random forest classifier. So the 3 setups we're looking at is the random forest classifier, support vector classifier, and then a neural network. Now we start with the random forest classifier because it has the least amount of moving parts to fine tune. And let's go ahead and put this in here. So we're going to call it RFC for random forest classifier. And if you remember, we imported that. So let me go back up here to the top real quick. And we did an import of the random forest classifier from SciKit Ensemble. And then we also, let me just point this out. Here's our SVM where we imported our support vector classifier. So SVM is support vector model, support vector classifier. And then we also have our neural network. And we're going to, from there, the multi-layered perceptron classifier. Kind of a mouthful for the P, perceptron. Don't worry too much about that name. It's a neural network. There's a lot of different options on there and setups, which is where they came up with the perceptron. So we have our 3 different models we're going to go through on here. And then we're going to weigh them. Here's our metrics. So we're going to use a confusion metrics, also from the sklearn package, to see how good our model does with our split. So let's go back down there and take a look at that. And we have our RFS equals random forest classifier, and we have n estimators equals 200. This is the only value you play with a random forest classifier. How many forests do you need? Or how many trees in the forest. So how many models are in here. That makes it pretty good as a startup model because we're only playing with one number and it's pretty clear what it is, and you can lower this number or raise it. Usually start up with a higher number and then bring it down to see if it keeps the same value. So you have less, the smaller the model, the better the fit, and it's easier to send out to somebody else if you're going to distribute it. Now the random forest classifier, everything I read says it's used for kind of a medium-sized data set. So you can run it on big data, you can run it on smaller data obviously, but it tends to work best in the mid-range. And we'll go ahead and take our RFC, and I just copied this from the other side, .fit x train, y train. So we're sending it our features and then the quality in the Y train, what we want to predict in there. And we just do a simple fit. Now remember, this is sklearn, so everything is fit or transform. Another one is predict, which we'll do in just a second here. In fact, let's do that now. Predict RFC equals, and it's our RFC model, predict. And what are we predicting on? Well, we trained it with our trained values, so now we need our test, our X test. So this has done it. This is the 3 lines of code we need to create our random forest variable, fit our training data to it. So we're programming it to fit. In this case, it's got 200 different trees it's going to build, and then we're going to predict on here. And let me go ahead and just run that. And we can actually do something like, let's do predict RFC. Just real quick, we'll look at the first 20 variables of it. Let's go ahead and run that. And in our first 20 variables, we have 3 wines that make the cut, and the other 17 don't. So the other 17 are bad quality, and 3 of them are good quality in our predicted values. And if you can remember correctly, we'll go ahead and take this out of here. This is based on our test. So these are the first 20 values in our test, and this has, as you can see, all the different features listed in there, and they've been scaled. So when you look at these, they're a little bit confusing to look at and hard to read, but there's a -0.01, so this is 0.36, -0.01, so 0.164, -0.09, or no, it's still -1, so -0.9, all between 0 and 1 on here. I think I was confused earlier and I said 0 between 2, -2, but it's between -1 and 1, which is what it should be in the scale. And we'll go ahead and just cut that out of there. Run this. We have our setup on here. So now that we've run the prediction and we have predicted values, well, one, you could publish them, but what do we do with them? Well, what we want to do with them is we want to see how well our model performed. That's the whole reason for splitting it between a training and testing model. And for that, if you remember, we imported the classification report. That was again from the sklearn. There's our confusion matrix and classification report. And the classification report actually sits on the confusion matrix, so it uses that information. And our classification report, we want to know how good our Y test, that's the actual values, versus our predicted RFC. So we'll go ahead and print this report out, and let's take a look. And we can see here we have a precision out of the 0. We had about 0.92 that were labeled as bad that were actually bad. And out of precision for the quality wines, we're running about 78%. So you kind of give us an overall 90%. And you can see our F1 score, our support set up on there, our recall. You could also do the confusion matrix on here, which gives you a little bit more information. But for this is going to be good enough for right now. We're just going to look at how good this model was, because we want to compare the random forest classifier with the other 2 models. And you know what, let's go ahead and put in the confusion matrix, just so you can see that on there, with Y-test and prediction RFC. So in the confusion matrix, we can see here that we had 266 correct and 7 wrong. These are the mislabels for bad wine, and we had a lot of mislabels for good wine. So our quality labels aren't that good. We're good at predicting bad wine, not so good at predicting whether it's a good quality wine. Important to note on there. So that is our basic random forest classifier. And let me go ahead, change cell type to markdown and run that so we have a nice label. Let's look at our SVM classifier, our support vector model. And this should look familiar. We have our CLF we're going to create. We'll call it, just like we call this an RFC. And then we'll have our CLF.fit. And this should be identical to up above. X train, Y train. And just like we did before, let's go ahead and do the prediction. And here is our CLF predict. And it's going to equal the CLF.predict. And we want to go ahead and use X_test. And right about now, you can realize that you can create these different models and actually just create a loop to go through your different models and put the data in. And that's how they designed it. They designed it to have that ability. And let's go ahead and run this. And then let's go ahead and do our classification report. And I'm just going to copy this right off of here. They say you shouldn't copy and paste your code. And the reason is when you go in here and edit it, you invariably will miss something. We only have 2 lines, so I think I'm safe to do it today. And let's go ahead and run this. And let's take a look how the SVM classifier came out. So up here we had a 90%, and down here we're running about an 86%. So it's not doing as good. Now remember, we randomly split the data, so if I run this a bunch of times, you'll see some changes down here. So these numbers, this size of data, if I ran it 100 times, it would probably be within plus or minus 3 or 4 on here. In fact, if I ran this 100 times, you'd probably see these come out almost the same as far as how well they do in classification. And then on the confusion matrix, let's take a look at this one. This had 22 by 25. This one has 35 by 12. So it's doing not quite as good. That shows up here 71% versus 78%. And then if we're going to do a SVM classifier, we also want to show you one more. And before I do that, kind of tease you a little bit here, before we jump into neural networks, the big save-all deep learning, because everything else must be shallow learning, that's a joke. Let's just talk a little bit about the SVM versus the random forest classifier. The SVM tends to work better on smaller numbers. It also works really good on, because a lot of times you convert things into numbers and bins and things like that. The random forest tends to do better with those. At least that's my brief experience with it. Where if you have just a lot of raw data coming in, the SVM is usually the fastest and easiest to apply model on there. So they each have their own benefits. You'll find though again that when you run these like 100 times, the difference between these two on a data set like this is going to just go away. There's randomness involved depending on which data we took and how they classify them. The big one is the neural networks, and this is what makes the neural networks nice is they can look into huge amounts of data. So for a project like this, you probably don't need a neural network on this, but it's important to see how they work differently and how they come up differently. So you can work with huge amounts of data. You can also, in many respects, they work really good with text analysis, especially if it's time sensitive. More and more you have an order of text, and they've just come out with different ways of feeding that data in, where the series and the order of the words is really important. Same thing with starting to predict in the stock market. If you have tons of data coming in from different sources, the neural network can really process that in a powerful way to pull up things that aren't seen before. And when I say lots of data coming in, I'm not talking about just the high lows that you can run an SVM on real easily. I'm talking about the data that comes in where you have, maybe you pulled off the Twitter feeds and have word counts going on, and you've pulled off the different news feeds that business are looking at, and the different releases when they release the different reports. So you have all this different data coming in, and the neural network does really good with that. Pictures. Picture processing now is really moving heavily into the neural network. If you have a Pixel 2 or Pixel 3 phone put out by Google, it has a neural network for doing, it's kind of goofy, but you can put little Star Wars androids dancing around your pictures and things like that. That's all done with the neural network. So it has a lot of different uses, but it's also requires a lot of data and is a little heavy-handed for something like this. And this should now look familiar because we've done it twice before. We have our multi-layered perceptron classifier. We'll call it an MLPC, and it's just as what we imported, MLPC classifier. There's a lot of settings in here. The first one is the hidden layers. You have to have the hidden layers in there. We're going to do 3 layers of 11 each. So that's how many nodes are in each layer as it comes in. And that was based on the fact we have 11 features coming in. Then I went ahead and just did 3 layers. Probably get by with a lot less on this. But I didn't want to sit and play with it all afternoon. Again, this is one of those things you play with a lot because the more hidden layers you have, the more resources you're using. You can also run into problems with overfitting, with too many layers, and you also have to run higher iterations. The max iteration we have is set to 500. The default's 200. Because I use 3 layers of 11 each, which is, by the way, kind of a default I use. I realized that usually you have about 3 layers going down and the number of features going across. You'll see that's pretty common for the first classifier when you're working in neural networks. But it also means you have to do higher iterations. So we up the iterations to 500. So that means it's going through the data 500 times to program those different layers and carefully adjust them. And we do have a full tutorials you can go look up on neural networks and understand the neural network settings a lot more. And of course we have, you're looking over here where we had our previous model where we fit it. Same thing here, MLPC, fit, X train, Y train. And then we're going to create our prediction. So let's do our predict and MLPC, and it's going to equal the MLPC. And we'll just take the same thing here, predict X test. Let's just put that down here, .predict X test. And if I run that, we've now programmed it. We now have our prediction here, same as before. And we'll go ahead and do the copy print again. Always be careful with the copy paste because you always run the chance of missing one of these variables. So if you're doing a lot of coding, you might want to skip that copy and paste and just type it in. And let's go ahead and run this and see what that looks like. And we came up with an 88%. We're going to compare that with the 86 from our tree, our SVM classifier, and our 90 from the random forest classifier. And keep in mind, random forest classifiers, they do good on mid-sized data. The SVM on smaller amounts of data, although to be honest, I don't think that's necessarily the split between the two. And these things will actually come together if you ran them a number of times. And we can see down here the amount of good wines mislabeled with setup on there. It's on par with our random forest. So it had 22, 25. Shouldn't be a surprise, it's identical. It just didn't do as good with the bad wines labeling, what's a bad wine and what's not. Let's see, yeah, because they had 266 and 7. We had down here 260 and 13. So it mislabeled a couple of the bad wines as good wines. So we've explored 3 of these basic classifiers. These are probably the 3 most widely used right now. I might even throw in the random tree. If we open up their website and we go under supervised learning, there's a linear model. We didn't do that. Most of the data usually just start with a linear model because it's going to process the quickest and use the least amount of resources. But you can see they have linear quadratic, they have kernel ridge. There's our support vector, stochastic gradient, nearest neighbors. Nearest neighbors is another common one that's used a lot. Very similar to the SVM. Gaussian process, cross decomposition, naive Bayes. This is more of an intellectual one that I don't see used a lot, but it's like the basis of a lot of other things. Decision tree. There's another one that's used a lot. Ensemble methods, not as much. Multi-class and multi-label algorithms, feature selection, neural networks, that's the other one we use down here, and of course the forest. So you can see there's in sklearn there are so many different options, and they've just developed them over the years. We covered 3 of the most commonly used ones in here and went over a little bit over why they're different. Neural network, just because it's fun to work in deep learning and not in shallow learning, as I told you. That doesn't mean that the SVM is actually shallow. It covers a lot of things, and same thing with the decision tree, the random forest classifier. And we notice that there's a number of other different classifier options in there. These are just the 3 most common ones, and I'd probably throw the nearest neighbor in there and the decision tree, which is usually part of the decision forest depending on what the backend you're using. And since, as human beings, if I was in the shareholder's office, I wouldn't want to leave them with a confusion matrix. They need that information for making decisions, but we want to give them just one particular score. And so I would go ahead and we have our sklearn metrics. We're going to import the accuracy score, and I'm just going to do this on the random forest since that was our best model. And we have our CM accuracy score, and I forgot to print it. If you remember in Jupyter Notebook, we can just do the last variable we leave out there, it'll print. And so our CM accuracy score we get is 90%. And that matches up here. We should already see that up here in precision. So you can either quote that, but a lot of times people like to see it highlighted at the very end. This is our precision on this model. And then the final stage is we would like to use this for future. So let's go ahead and take our wine. If you remember correctly, we'll do wine head of 10. We'll run that. Remember our original data set? We've gone through so many steps. Now we're going to go back to the original data. And we can see here we have our top 10 on the list. Only 2 of them make it as having high enough quality wine for us to be interested in them. And then let's go ahead and create some data here. We'll call it x new equals, and this is important. This data has to be, we just kind of randomly selected some data. It looks an awful lot like some of the other numbers on here, which is what it should look like. And so we have our x new equals 7.3, 0.58, and so on. And then it is so important. This is where people forget this step. X new equals SC. Remember SC? That was our standard scalar variable we created. If we go right back up here, before we did anything else, we created an SC, we fit it, and we transformed it, and then we need to do what? Transform the data we're going to feed in. So we're going to go back down here, and we're going to transform our X new, and then we were going to go ahead and use the, where are we at? Here we go. Our random forest, and if you remember, all it is our RFC predict model right there. Let's go ahead and just grab that down here. And so our Y new equals, here's our RFC predict. We're going to do our X new in, and then it's kind of nice to know what it actually puts out. So according to this, it should print out what our prediction is for this wine. And, oh, it's a bad wine. Okay, so we didn't pick out a good wine for our X new. And that should be expected. Most of the wine, if you remember correctly, only a small percentage of the wine met our quality requirements. So we can look at this and say, oh, we'll have to try another wine out, which is fine by me because I like to try out new wines, and I certainly have a collection of old wine bottles, and very few of them match. But you can see here we've gone through the whole process. Just a quick rehash. We had our imports. We touched a lot on the sklearn, our random forest, our SVM, and our NLP classifier. So we had our support vector classifier. we had our random forest, and we have our neural network, three of the top used classifiers in the sklearn system. And we also have our confusion matrix and our classification report, which we used, our standard scaler for scaling it, and our label encoder. And of course, we needed to go ahead and split our data up in our mplot line train. And we explored the data in here for null values. We set up our quality into bins. We took a look at the data and what we actually have and put a nice little plot to show our quality, what we're looking at. And then we went through our three different models. And it's always interesting because you spend so much time getting to these models, and then you kind of go through the models and play with them until you get the best training on there without becoming biased. That's always a challenge, is to not overtrain your data to the point where you're training it to fit the test value. And finally, we went ahead and actually used it and applied it to a new wine, which unfortunately didn't make the cut. It's going to be the one that we drink a glass out of and save the rest for cooking. Of course, that's according to the random forest on there because we used the best model that it came up with.
If you are an aspiring AI ML engineer, then there is no better time to train yourself in an exciting field of machine learning. If you are looking for a course that covers everything from fundamentals to advanced techniques like machine learning algorithm development and unsupervised learning, look no further than our Caltech in partnership with IBM. So why wait? Join now. Seats are filling fast. Find the course link from the description box below.
Naive Bayes classifier. Have you ever wondered how your mail provider implements spam filtering, or how online news channels perform news text classification, or how companies perform sentimental analysis of their audience on social media? All of this and more is done through a machine learning algorithm called Naive Bayes classifier. Welcome to Naive Bayes tutorial. My name is Richard Kirshner. I'm with the Simplilearn team. That's www.simplilearn.com. Get certified. Get ahead. What's in it for you? We'll start with what is Naive Bayes, a basic overview of how it works. We'll get into Naive Bayes and machine learning, where it fits in with our other machine learning tools. Why do we need Naive Bayes? And understanding Naive Bayes classifier, a much more in-depth of how the math works in the background. Finally, we'll get into the advantages of the Naive Bayes classifier in the machine learning setup. And then we'll roll up our sleeves and do my favorite part. We'll actually do some Python coding and do some text classification using the Naive Bayes. What is Naive Bayes? Let's start with a basic introduction to the Bayes theorem, named after Thomas Bayes from the 1700s, who first coined this in the Western literature. Naive Bayes classifier works on the principle of conditional probability as given by the Bayes theorem. Before we move ahead, let us go through some of the simple concepts in the probability that we will be using. Let us consider the following example of tossing two coins. Here we have two quarters, and if we look at all the different possibilities of what they can come up as, we get that they can come up as head-heads, they can come up as head-tail, tail-head, and tail-tail. When doing the math on probability, we usually denote probability as a P, a capital P. So the probability of getting two heads equals 1/4. You can see on our data set we have two heads, and this occurs once out of the four possibilities. And then the probability of at least one tail occurs 3/4 of the time. You'll see on 3 of the coin tosses we have tails in them, and out of 4 that's 3/4. And then the probability of the second coin being head given the first coin is tail is 1/2, and the probability of getting two heads given the first coin is a head is 1/2. We'll demonstrate that in just a minute and show you how that math works. Now when we're doing it with two coins it's easy to see, but when you have something more complex you can see where these formulas really come in and work. So the Bayes theorem gives us the conditional probability of an event A given another event B has occurred. In this case, the first coin toss will be B and the second coin toss A. This can be confusing because we've actually reversed the order of them and go from B to A instead of A to B. You'll see this a lot when you work in probabilities. The reason is we're looking for event A. We want to know what that is. So we're going to label that A since that's our focus. And then given another event B has occurred. In the Bayes theorem, as you can see on the left, the probability of A occurring given B has occurred equals the probability of B occurring given A has occurred times the probability of A over the probability of B. This simple formula can be moved around just like any algebra formula. And we could do the probability of A after a given B times probability of B equals the probability of B given A times probability of A. You can easily move that around and multiply it and divide it out. Let us apply Bayes' theorem to our example. Here we have our two quarters, and we'll notice that the first two probabilities of getting two heads and at least one tail we compute directly off the data. So you can easily see that we have one example, HH, out of 4, 1/4, and we have 3 with tells in them, giving us 3/4, or 3/4, 75%. The second condition, the second set, 3 and 4, we're going to explore a little bit more in detail. Now, we stick to a simple example with 2 coins because you can easily understand the math. The probability of throwing a tell doesn't matter what comes before it, and the same with the heads. So it's still going to be 50% or 1/2. But when that probability gets more complicated, let's say you have a d6 dice or some other instance, then this formula really comes in handy. But let's stick to the simple example for now. In this sample space, let A be the event that the second coin is head, and B be the event that the first coin is tells. Again, we reversed it because we want to know what the second event's going to be, so we're going to be focusing on A. And we write that out as the probability of A given B. And we know this from our formula that equals the probability of B given A times the probability of A over the probability of B. And when we plug that in, we plug in the probability of the first coin being tells given the second coin is heads, and the probability of the second coin being heads given the first coin being over the probability of the first coin being tells. When we plug that data in, and we have the probability of the first coin being tells given the second coin is heads times the probability of the second coin being heads over the probability of the first coin being tells. You can see it's a simple formula to calculate. We have 1/2 times 1/2 over 1/2, or 1/2 equals 0.5, or 1/4. So the Bayes theorem basically calculates the conditional probability of the occurrence of an event based on prior knowledge of conditions that might be related to the event. We will explore this in detail when we take up an example of online shopping further in this tutorial. Understanding naive Bayes and machine learning. Like with any of our other machine learning tools, it's important to understand where the naive Bayes fits in the hierarchy. So under the machine learning, we have supervised learning, and there is other things like unsupervised learning. There's also a reward system. This falls under the supervised learning. And then under the supervised learning, there's classification. There's also regression, but we're going to be in the classification side. And then under classification is your naive Bayes. Let's go ahead and glance into where is naive Bayes used. Let's look at some of the use scenarios for it. As a classifier, we use it in face recognition. Is this Cindy or is it not Cindy or whoever? Or it might be used to identify parts of the face that they then feed into another part of the face recognition program. This is the eye, this is the nose, this is the mouth. Weather prediction, is it going to be rainy or sunny? Medical recognition, news prediction. It's also used in medical diagnosis. We might diagnose somebody as either as high risk or not as high risk for cancer or heart disease or other ailments. And news classification. When you look at the Google News and it says, well, is this political or is this world news? Or a lot of that's all done with the naive Bayes. Understanding naive Bayes classifier. Now, we already went through a basic understanding with the coins and the 2 heads and 2 tells and head tell, tell heads, etc. We're going to do just a quick review on that and remind you that the naive Bayes classifier is based on the Bayes theorem, which gives a conditional probability of event A given event B. And that's where the probability of A given B equals the probability of B given A times probability of A over probability of B. Remember, this is an algebraic function, so we can move these different entities around. We can multiply by the probability of B, so it goes to the left-hand side, and then we could divide by the probability of A given B, and just as easily come up with a new formula for the probability of B. To me, staring at these algebraic functions kind of gives me a slight headache. It's a lot better to see if we can actually understand how this data fits together in a table. And let's go ahead and start applying it to some actual data so you can see what that looks like. So we're going to start with the shopping demo problem statement. And remember, we're going to solve this first in table form so you can see what the math looks like, and then we're going to solve it in Python. And in here we want to predict whether the person will purchase a product. Are they going to buy or don't buy? Very important if you're running a business, you want to know how to maximize your profits, or at least maximize the purchase of the people coming into your store. And we're going to look at a specific combination of different variables. In this case, we're going to look at the day, the discount, and the free delivery. And you can see here under the day, we want to know whether it's on the weekday. You know, somebody's working, they come in after work, or maybe they don't work. Weekend, you can see the bright colors coming down there, celebrating not being in work, or holiday. And did we offer a discount that day? Yes or no? Did we offer free delivery that day? Yes or no? And from this, we want to know whether the person's going to buy based on these traits so we can maximize them and find out the best system for getting somebody to come in and purchase our goods and products from our store. Now, having a nice visual is great, but we do need to dig into the data. So let's go ahead and take a look at the data set. We have a small sample data set of 30 rows. We're showing you the first 15 of those rows for this demo. Now, the actual data file you can request. Just type in below under the comments on the YouTube video and we'll send you some more information and send you that file. As you can see here, the file is very simple, columns and rows. We have the day, the discount, the free delivery, and did the person purchase or not. And then we have under the day whether it was a weekday, a holiday, was it the weekend. This is a pretty simple set of data, and long before computers, people used to look at this data and calculate this all by hand. So let's go ahead and walk through this and see what that looks like when we put that into tables. Also note, in today's world, we're not usually looking at 3 different variables in 30 rows. Nowadays, because we're able to collect data so much, we're usually looking at 27, 30 variables across hundreds of rows. The first thing we want to do is we're going to take this data and based on the data set containing our 3 inputs, day, discount, and free delivery, we're going to go ahead and populate that to frequency tables for each attribute. So we want to know if they had a discount, how many people buy and did not buy. Did they have a discount, yes or no? Did we have a free delivery, yes or no? On those days, how many people made a purchase and how many people didn't? And the same with the 3 days of the week. Was it a weekday, a weekend, a holiday? And did they buy, yes or no? As we dig in deeper to this table for our Bayes theorem, let the event buy be A. Now remember when we looked at the coins, I said we really want to know what the outcome is. Did the person buy or not? And that's usually event A is what you're looking for. And the independent variables, discount, free delivery, and day, be B. So we'll call that probability of B. Now let us calculate the likelihood table for one of the variables. Let's start with day, which includes weekday, weekend, and holiday. And let us start by summing all of our rows. So we have the weekday row, and out of the weekdays there's 9 plus 2, so it's 11 weekdays. There's 8 weekend days and 11 holidays. Wow, that's a lot of holidays. And then we want to sum up the total number of days. So we're looking at a total of 30 days. Let's start pulling some information from our chart and see where that takes us. And when we fill in the chart on the right, you can see that 9 out of 24 purchases are made on the weekday, 7 out of 24 purchases on the weekend, and 8 out of 24 purchases on a holiday. And out of all the people who come in, 24 out of 30 purchase. You can also see how many people do not purchase. On the weekday, it's 2 out of 6 didn't purchase, and so on and so on. We can also look at the totals, and you'll see on the right we put together some of the formulas. The probability of making a purchase on the weekend comes out at 11 out of 30. So out of the 30 people who came into the store throughout the weekend, weekday, and holiday, 11 of those purchases were made on the weekday. And then you can also see the probability of them not making a purchase. And this is done for, doesn't matter which day of the week. So we call that probability of no buy. It would be 6 over 30 or 0.2. So there's a 20% chance that they're not going to make a purchase no matter what day of the week it is. And finally, we look at the probability of B if A. In this case, we're going to look at the probability of the weekday and not buying. 2 of the no buys were done out of the weekend out of the 6 people who did not make purchases. So when we look at that, probability of the weekday without a purchase is going to be 0.33 or 33%. Let's take a look at this at different probabilities, and based on this likelihood table, let's go ahead and calculate conditional probabilities as below. The first 3 we just did. The probability of making a purchase on the weekday is 11 out of 30, or roughly 36 or 37%, 0.367. The probability of not making a purchase at all, doesn't matter what day of the week, is roughly 0.2 or 20%. And the probability of a weekday no purchase is roughly 2 out of 6. So 2 out of 6 of our no purchases were made on the weekday. And then finally we take our P of AB. If you look, we've kept the symbols up there. We got P of probability of B, probability of A, probability of B if A. We should remember that the probability of A if B is equal to the first one times the probability of no buys over the probability of the weekday. So we could calculate it both off the table we created. We can also calculate this by the formula, and we get the 0.367, which equals, or 0.33 times 0.2 over 0.367, which equals 0.179, or roughly 17 to 18%. And that'd be the probability of no purchase done on the weekday. And this is important because we can look at this and say, as the probability of buying on the weekday is more than the probability of not buying on the weekday, we can conclude that customers will most likely buy the product on a weekday. Now, we've kept our chart simple and we're only looking at one aspect. So you should be able to look at the table and come up with the same information or the same conclusion. That should be kind of intuitive at this point. Next, we can take the same setup. We have the frequency tables of all three independent variables. Now we can construct the likelihood tables for all three of the variables we're working with. We can take our day like we did before. We have weekday, weekend, and holiday. We filled in this table. And then we can come in and also do that for the discount, yes or no. Did they buy, yes or no? And we fill in that full table. So now we have our probabilities for a discount and whether the discount leads to a purchase or not, and the probability for free delivery. Does that lead to a purchase or not? And this is where it starts getting really exciting. Let us use these three likelihood tables to calculate whether a customer will purchase a product on a specific combination of day, discount, and free delivery, or not purchase. Here, let us take a combination of these factors. Day equals holiday, discount equals yes, free delivery equals yes. Let's dig deeper into the math and actually see what this looks like. And we're going to start with looking for the probability of them not purchasing on the following combinations of days. We are actually looking for the probability of A equal no buy, no purchase. And our probability of B we're going to set equal to, is it a holiday? Did they get a discount? Yes. And was it a free delivery? Yes. Before we go further, let's look at the original equation. The probability of A if B equals the probability of B given the condition A and the probability times the probability of A over the probability of B occurring. Now this is basic algebra, so we can multiply this information together. So when you see the probability of A given B, in this case the condition is B, C, and D, or the three different variables we're looking at. And when you see the probability of B, that would be the conditions. We're actually going to multiply those three separate conditions out. Probability of, you'll see that in just a second in the formula, times the full probability of A over the full probability of B. So here we are back to this, and we're going to have let A equal no purchase, and we're looking for the probability of B on the condition A, where A sets for three different things. Remember that equals the probability of A given the condition B. And in this case, we just multiply those three different variables together. So we have the probability of the discount times the probability of free delivery times the probability is the day equal a holiday. Those are our three variables of the probability of A if B. And then that is going to be multiplied by the probability of them not making a purchase. And then we want to divide that by the total probabilities, and they're multiplied together. So we have the probability of a discount, the probability of a free delivery, and the probability of it being on a holiday. When we plug those numbers in, we see that 1 out of 6 were no purchase on a discounted day, 2 out of 6 were a no purchase on a free delivery day, and 3 out of 6 were a no purchase on a holiday. Those are our three probabilities of A if B multiplied out. And then that has to be multiplied by the probability of a no purchase. And remember, the probability of a no buy is across all the data. So that's where we get the 6 out of 30. We divide that out by the probability of each category over the total number. So we get the 20 out of 30 had a discount, 23 out of 30 had a yes for free delivery, and 11 out of 30 were on a holiday. We plug all those numbers in, we get 0.178. So in our probability math, we have a 0.178 if it's a no buy for a holiday, a discount, and a free delivery. Let's turn that around and see what that looks like if we have a purchase. I promise this is the last page of math before we dig into the Python script. So here we're calculating the probability of the purchase using the same math we did to find out if they didn't buy. Now we want to know if they did buy. And again, we're going to go by the day equals a holiday, discount equals yes, free delivery equals yes, and let A equal buy. Now right about now you might be asking, why are we doing both calculations? Why would we want to know the no buys and buys for the same data going in? Well, we're going to show you that in just a moment, but we have to have both of those pieces of information so that we can figure it out as a percentage as opposed to a probability equation. And we'll get to that normalization here in just a moment. Let's go ahead and walk through this calculation. And as you can see here, the probability of A on the condition of B, B being all three categories. Did we have a discount with a purchase? Did we have a free delivery with a purchase? And is a day equal to holiday? And when we plug this all into that formula and multiply it all out, we get our probability of a discount, probability of a free delivery, probability of the day being a holiday, times the overall probability of it being a purchase divided by, again, multiplying the three variables out, the full probability of there being a discount, the full probability of being a free delivery, and the full probability of there being a day equal holiday. And that's where we get this 19 over 24 times 21 over 24 times 8 over 24 times the P of A, 24 over 30, divided by the probability of the discount, the free delivery times the day, or 20 over 30, 23 over 30 times 11 over 30, and that gives us our 0.986. So, what are we going to do with these two pieces of data we just generated? Well, let's go ahead and go over them. We have a probability of purchase equals 0.986. We have a probability of no purchase equals 0.178. So, finally, we have a conditional probabilities of purchase on this day. Let us take that, we're going to normalize it, and we're going to take these probabilities and turn them into percentages. This is simply done by taking the sum of probabilities, which equals 0.986 plus 0.178, and that equals the 1.164. If we divide each probability by the sum, we get the percentage. And so the likelihood of a purchase is 84.71%, and the likelihood of no purchase is 15.29%, given these three different variables. So it's if it's on a holiday, if it's with a discount and has free delivery, then there's an 84.71% chance that the customer is going to come in and make a purchase. Hooray! They purchased our stuff. We're making money. If you're owning a shop, that's is the bottom line, is you want to make some money so that you can keep your shop open and have a living. Now, I promised you that we were going to be finishing up the math here with a few pages. So we're going to move on and we're going to do two steps. The first step is I want you to understand why you want to use the naive Bayes. What are the advantages of naive Bayes? And then once we understand those advantages, we'll just look at that briefly, then we're going to dive in and do some Python coding. Advantages of naive Bayes classifier. So let's take a look at the 6 advantages of the naive Bayes classifier, and we're going to walk around this lovely wheel. It looks like an origami folded paper. The first one is very simple and easy to implement. Certainly you could walk through the tables and do this by hand. You got to be a little careful because the notations can get confusing. You have all these different probabilities, and I certainly mess those up as I put them on, is it on the top or the bottom? You got to really pay close attention to that. When you put it into Python, it's really nice because you don't have to worry about any of that. You let the Python handle that, the Python module. But understanding it, you can put it on a table and you can easily see how it works, and it's a simple algebraic function. It needs less training data, so if you have smaller amounts of data, this is a great, powerful tool for that. Handles both continuous and discrete data. It's highly scalable with number of predictors and data points. So as you can see, you can just keep multiplying different probabilities in there, and you can cover not just 3 different variables or sets. You can now expand this to even more categories. Number 5, it's fast. It can be used in real-time predictions. This is so important. This is why it's used in a lot of our predictions on online shopping carts, referrals, spam filters, is because there's no time delay as it has to go through and figure out a neural network, or one of the other many setups where you're doing classification. And certainly there's a lot of other tools out there in the machine learning that can handle these, but most of them are not as fast as the naive Bayes. And then finally, it's not sensitive to irrelevant features. So it picks up on your different probabilities, and if you're short on data on one probability, you can it automatically adjust for that. Those formulas are very automatic, and so you can still get a very solid predictability even if you're missing data or you have overlapping data for 2 completely different areas. We see that a lot in doing census and studying of people and habits, where they might have one study that covers one aspect and another one that overlaps, and because the 2 overlap, they can then predict the unknowns for the group that they haven't done the second study on, or vice versa. So it's very powerful in that it is not sensitive to the irrelevant features, and in fact you can use it to help predict features that aren't even in there. So now we're down to my favorite part. We're going to roll up our sleeves and do some actual programming. We're going to do the use case text classification. Now, I would challenge you to go back and send us a note on the notes below underneath the video and request the data for the shopping cart. So you can plug that into Python code and do that on your own time so you can walk through it, since we walk through all the information on it. But we're going to do a Python code doing text classification, very popular for doing the naive Bayes. So we're going to use our new tool to perform a text classification of news headlines and classify news into different topics for a news website. As you can see here, we have a nice image of the Google News, and then related on the right, subgroups. I'm not sure where they actually pulled the actual data we're going to use from. It's one of the standard sets. But certainly this can be used on any of our news headlines and classification. So let's see how it can be done using the naive Bayes classifier. Now we're at my favorite part. We're actually going to write some Python script. Roll up our sleeves. And we're going to start by doing our imports. These are very basic imports, including our news group. And we'll take a quick glance at the target names. Then we're going to go ahead and start training our data set and putting it together. We'll put together a nice graph, because it's always good to have a graph to show what's going on. And once we've trained it and we've shown you a graph of what's going on, then we're going to explore how to use it and see what that looks like. Now, I'm going to open up my favorite editor, inline editor for Python. You don't have to use this. You can use whatever your editor that you like, whatever interface IDE you want. This just happens to be the Anaconda Jupyter Notebook. And I'm going to paste that first piece of code in here so we can walk through it. Let's make it a little bigger on the screen so you have a nice view of what's going on. And we're using Python 3, in this case 3.5. So this would work in any of your 3x. If you have it set up correctly, it should also work in a lot of the 2x. You just have to make sure all of the versions of the modules match your Python version. And in here, you'll notice the first line is your percentage matplot library in line. Now, 3 of these lines of code are all about plotting the graph. This one lets the notebook know, since it's an inline setup, that we want the graphs to show up on this page. Without it in a notebook like this, which is an Explorer interface, it won't show up. Now, a lot of IDEs don't require that. A lot of them, like if I'm working on one of my other setups, it just has a pop-up and the graph pops up on there. So you have that setup also. But for this, we want the matplot library inline. And then we're going to import NumPy as NP. That's NumberPython, which has a lot of different formulas in it that we use for both of our sklearn module. And we also use it for any of the upper math functions in Python. And it's very common to see that as NP, NumPy as NP. The next 2 lines are all about our graphing. Remember I said 3 of these were about graphing? Well, we need our matplotlibary.pyplot as PLT, and you'll see that PLT is a very common setup, as is the SNS, and just like the NP. And we're going to import Seaborn as SNS, and we're going to do the SNS.set. Now, Seaborn sits on top of pyplot, and it just makes a really nice heat map. It's really good for heat maps. And if you're not familiar with heat maps, that just means we give it a color scale. The term comes from the brighter red it is, the hotter it is in some form of data, and you can set it to whatever you want. And we'll see that later on. So you'll see that those 3 lines of code here are just importing the graph function so we can graph it. And as a data scientist, you always want to graph your data and have some kind of visual. It's really hard just to shove numbers in front of people and they look at it and it doesn't mean anything. And then from the sklearn.datasets, we're going to import the fetch 20 news groups. Very common one for analyzing, tokenizing words and setting them up and exploring how the words work and how do you categorize different things when you're dealing with documents. And then we set our data equal to fetch 20 news groups. So our data variable will have the data in it. And we're going to go ahead and just print the target names, data.targetNames. And let's see what that looks like. And you'll see here we have alt atheism, comp graphics, comp OS, MS, Windows.miscellaneous. And it goes all the way down to talkpolitics.miscellaneous, talkreligion.miscellaneous. These are the categories they've already assigned to this news group. And it's called Fetch 20 because you'll see I believe there's 20 different topics in here, or 20 different categories as we scroll down. Now, we've gone through the 20 different categories, and we're going to go ahead and start defining all the categories and set up our data. So we're actually going to go ahead and get the data all set up and take a look at our data. And let's move this over to our Jupyter Notebook, and let's see what this code does. First, we're going to set our categories. Now, if you noticed up here, I could have just as easily set this equal to data.target_names, because it's the same thing. But we want to kind of spell it out for you so you can see the different categories. It kind of makes it more visual so you can see what your data is looking like in the background. Once we've created the categories, we're going to open up a train set. So this training set of data is going to go into fetch 20 news groups, and it's a subset in there called train, and categories equals categories. So we're pulling out those categories that match. And then if you have a train set, you should also have the testing set. We have test equals fetch 20 news groups, subset equals test, and categories equals categories. Let's go down one size so it all fits on my screen. There we go. And just so we can really see what's going on, let's see what happens when we print out one part of that data. So it creates train, and under train it creates train.data, and we're just going to look at data piece number 5. And let's go ahead and run that and see what that looks like. And you can see when I print train.data number 5 under train, it prints out one of the articles. This is article number 5. You can go through and read it on there. And we can also go in here and change this to test, which should look identical because it's splitting the data up into different groups, train and test. And we'll see test number 5 is a different article, but it's another article in here. And maybe you're curious and you want to see just how many articles are in here. We could do length of train.data, and if we run that, you'll see that the training data has 11,314 articles. So we're not going to go through all those articles. That's a lot of articles. But we can look at one of them just so you can see what kind of information is coming out of it and what we're looking at. And we'll just look at number 5 for today. And here we have it. Rewording the Second Amendment IDs, VTT, lines 58 in article, etc. And you can scroll all the way down and see all the different parts to there. Now, we've looked at it, and that's pretty complicated when you look at one of these articles to try to figure out how do you weight this. If you look down here, we have different words, and maybe the word from. Well, from is probably in all the articles, so it's not going to have a lot of meaning as far as trying to figure out whether this article fits one of the categories or not. So trying to figure out which category it fits in based on these words is where the challenge comes in. Now that we've viewed our data, we're going to dive in and do the actual predictions. This is the actual naive Bayes. And we're going to throw another model at you, or another module at you here in just a second. We can't go into too much detail, but it deals specifically working with words and text and what they call tokenizing those words. So let's take this code and let's skip on over to our Jupyter Notebook and walk through it. And here we are in our Jupyter Notebook. Let's paste that in there. And I can run this code right off the bat. It's not actually going to display anything yet, but it has a lot going on in here. So at the top, we had the print module from the earlier one. I didn't know why that was in there. So we're going to start by importing our necessary packages. And from the sklearn features extraction.txt, we're going to import tf-idf vectorizer. I told you we're going to throw a module at you. We can't go too much into the math behind this or how it works. You can look it up. The notation for the math is usually tf.idf. And that's just a way of weighing the words. And it weighs the words based on how many times they're used in a document, how many times or how many documents they're used in. And it's a well-used formula. It's been around for a while. It's a little confusing to put this in here, but let's let it know that it just goes in there and weights the different words in the document for us. That way we don't have to wait. And if you put a weight on it, if you remember I was talking about that up here earlier, if these are all emails, they probably all have the word from in them. From probably has a very low weight. It has very little value in telling you what this document's about. Same with words like in article, in articles, in, cost of, un, maybe cost might, or where words like criminal, weapons, destruction, these might have a heavier weight because they describe a little bit more what the article's doing. Well, how do you figure out all those weights in the different articles? That's what this module does. That's what the tf-idf vectorizer is going to do for us. And then we're going to import our sklearn.naive Bayes, and that's our multinomial NB. Multinomial naive Bayes. Pretty easy to understand that, where that comes from. And then finally we have the sklearn pipeline import make pipeline. Now the make pipeline is just a cool piece of code because we're going to take the information we get from the tf-idf vectorizer and we're going to pump that into the multinomial NB. So a pipeline is just a way of organizing how things flow. It's used commonly. You probably already guessed what it is. If you've done any businesses, they talk about the sales pipeline. If you're on a work crew or a project manager, you have your pipeline of information that's going through, or your projects and what has to be done in what order. That's all this pipeline is. We're going to take the tf-id vectorizer and then we're going to push that into the multinomial NB. Now, we've designated that as the variable model. We have our pipeline model. And we're going to take that model, and this is just so elegant. This is done in just a couple lines of code. Model.fit. And we're going to fit the data, and first the train data, and then the train target. Now, the train data has the different articles in it. You can see the one we were just looking at. And the train.target is what category they already categorized that particular article as. And what's happening here is the trained data is going into the TF-ID vectorizer. So when you have one of these articles, it goes in there, it weights all the words in there. So there's thousands of words with different weights on them. I remember once running a model on this, and I literally had 2.4 million tokens go into this. So when you're dealing like large document bases, you can have a huge number of different words. It then takes those words, gives them a weight, and then based on that weight, based on the words and the weights, and then puts that into the multinomial NB. And once we go into our naive Bayes, we want to put the trained target in there. So the trained data that's been mapped to the TF-ID vectorizer is now going through the multinomial NB, and then we're telling it, well, these are the answers. These are the answers to the different documents. So this document that has all these words with these different weights from the first part is going to be whatever category it comes out of. Maybe it's the talk show or the article on religion, miscellaneous. Once we fit that model, we can then take labels, and we're going to set that equal to model.predict. Most of the sklearn use the term .predict to let us know that we've now trained the model and now we want to get some answers. And we're going to put our test data in there because our test data is the stuff we held off to the side. We didn't train it on there and we don't know what's going to come up out of it, and we just want to find out how good our labels are. Do they match what they should be? Now, I've already run this through. There's no actual output to it to show. This is just setting it all up. This is just training our model, creating the labels so we can see how good it is, and then we move on to the next step to find out what happened. To do this, we're going to go ahead and create a confusion matrix and a heat map. So the confusion matrix, which is confusing just by its very name, is basically going to ask how confused is our answer. Did it get it correct, or did it miss some things in there or have some missed labels? And then we're going to put that on a heat map so we'll have some nice colors to look at to see how that plots out. Let's go ahead and take this code and see how that, take a walk through it and see what that looks like. So back to our Jupyter notebook, I'm going to put the code in there, and let's go ahead and run that code. Take it just a moment. And remember, we had the inline, that way my graph shows up on the inline here. And let's walk through the code and then we'll look at this and see what that means. So, make it a little bit bigger. There we go. No reason not to use the whole screen. Too big. So we have here from sklearn metrics import confusion matrix. And that's just going to generate a set of data that says the prediction was such, the actual truth was either agreed with it or is something different. And it's going to add up those numbers so we can take a look and just see how well it worked. And we're going to set a variable mat equal to confusion matrix. And we have our test target, our test data that was not part of the training. Very important in data science, we always keep our test data separate. Otherwise, it's not a valid model if we can't properly test it with new data. And this is the labels we created from that test data. These are the ones that we predict it's going to be. So we go in and we create our SN heat map. The SNS is our seaborn, which sits on top of the pie plot. So when we create a SNS.heatmap, we take our confusion matrix, and it's going to be mat.t. And do we have other variables that go into the SNS.heatmap? We're not going to go into detail what all the variables mean. The annotation equals true. That's what tells it to put the numbers here. So you have the 166, the 1, the 0001. Format D and C bar equals false have to do with the format. If you take those out, you'll see that some things disappear. And then the X tick labels and the Y tick labels, those are our target names. And you can see right here, that's the alt atheism, comp graphics, comp OS, MS, Windows.miscellaneous. And then finally, we have our plt.x label. Remember, the SNS or the seaborn sits on top of our matplot library, our PLT. And so we want to just tell it x label equals a true is true. The labels are true. And then the y label is prediction label. So when we say a true, this is what it actually is, and the prediction is what we predicted. And let's look at this graph, because that's probably a little confusing the way I rattled through it. And what I'm going to do is I'm going to go ahead and flip back to the slides, because they have a black background they put in there that helps it shine a little bit better so you can see the graph a little bit easier. So in reading this graph, what we want to look at is how the color scheme has come out. And you'll see a line right down the middle, diagonally, from upper left to bottom right. What that is if you look at the labels, we have our predicted label on the left and our true label on the right. Those are the numbers where the prediction and the true come together. And this is what we want to see, is we want to see those lit up. That's what that heat map does, is you can see that it did a good job of finding those data. And you'll notice that there's a couple of red spots on there where it missed. It's a little confused when we talk about talk religion miscellaneous versus talk politics miscellaneous, social religion Christian versus alt atheism. It mislabeled some of those. And those are very similar topics, so you could understand why it might mislabel them. But overall, it did a pretty good job. If we're going to create these models, we want to go ahead and be able to use them. So let's see what that looks like. To do this, let's go ahead and create a definition, a function to run. And we're going to call this function, let me just expand that just a notch here. There we go. I like mine in big letters. Predict categories. We want to predict the category. We're going to send it S, a string. And then we're sending it train equals train. We have our training model. And then we had our pipeline, model equals model. This way we don't have to resend these variables each time. The definition knows that because I said train equals train, and I put the equal for model. And then we're going to set the prediction equal to the model.predict s. So it's going to send whatever string we send to it. It's going to push that string through the pipeline, the model pipeline. It's going to go through and tokenize it and put it through the TF, IDF, convert that into numbers and weights for all the different documents and words, and then it'll put that through our naive Bayes. And from it, we'll go ahead and get our prediction. We're going to predict what value it is. And so we're going to return train.targetNamesPredict of 0. And remember that the train.targetNames, that's just categories. I could have just as easily put categories in there .predict of 0. So we're taking the prediction, which is a number, and we're converting it to an actual category. We're converting it from, I don't know what the actual numbers are, but let's say 0 equals alt atheism. So we're going to convert that 0 to the word, or 1, maybe it equals comp graphics. So we're going to convert number 1 into comp graphics. That's all that is. And then we got to go ahead and then we need to go ahead and run this. So I load that up. And then once I run that, we can start doing some predictions. I'm going to go ahead and type in predict category. And let's just do predict category Jesus Christ. And it comes back and says it's social, religion, Christian. That's pretty good. Now, note I didn't put print on this. One of the nice things about the Jupyter Notebook Editor and a lot of inline editors is if you just put the name of the variable out as returning the variable train.target_names, it'll automatically print that for you. In your own IDE, you might have to put in print. Let's see where else we can take this. And maybe you're a space science buff. So how about sending load to International Space Station? And if we run that, we get science space. Or maybe you're a automobile buff. And let's do, they were going to tell me Audi is better than BMW, but I'm going to do BMW is better than an Audi. So maybe you're a car buff. And we run that, and you'll see it says recreational. I'm assuming that's what REC stands for. Autos. So I did a pretty good job labeling that one. How about if we have something like a caption running through there? President of India. And if we run that, it comes up and says talk, politics, miscellaneous.
If you are an aspiring AI ML engineer, then there is no better time to train yourself in an exciting field of machine learning. If you are looking for a course that covers everything from fundamentals to advanced techniques like machine learning algorithm development and unsupervised learning, look no further than our Caltech in partnership with IBM. So why wait? Join now. Seats are filling fast. Find the course link from the description box below.
In this lesson, you are going to understand the concept of text mining. By the end of this lesson, you will be able to explain text mining, execute text processing tasks. So let's go ahead and understand text mining in detail. Let's first understand what text mining is. Text mining is the technique of exploring large amounts of unstructured text data and analyzing it in order to extract patterns from the text data. It is aided by software that can identify concepts, patterns, topics, keywords, and other attributes in the data. It utilizes computational techniques to extract and summarize the high-quality information from unstructured textual resources. Let's understand the flow of text mining. There are 5 techniques used in text mining system. information extraction or text pre-processing. This is used to examine the unstructured text by searching out the important words and finding the relationships between them. Categorization or text transformation attribute generation. Categorization technique labels the text document under one or more categories. Classification of text data is done based on input-output examples with categorization. Clustering or attribute selection. Clustering method is used to group text documents that have similar content. Clusters are the partitions, and each cluster will have a number of documents with similar content. Clustering makes sure that no document will be omitted from the search, and it derives all the documents that have similar content. Visualization technique. The process of finding relevant information is simplified by visualization technique. This technique uses text flags to represent a group of documents or a single document, and compactness is indicated using colors. Visualization technique helps to display textual information in a more attractive way. Summarization or interpretation or evaluation. Summarization technique will help to reduce the length of the document and summarize the details of the documents. It makes the document easy to read for users and understand the content at the moment. Let's understand the significance of text mining. Document clustering. Document clustering is an important part of text mining. It has many applications in knowledge management and information retrieval. Clustering makes it easy to group similar documents into meaningful groups, such as in newspapers where sections are often grouped as business, sports, politics, and so on. Pattern identification. Text mining is the process of automatically searching large amount of text for text patterns and recognition of features. Features such as telephone numbers and email addresses can be extracted using pattern matches. Product insights. Text mining helps to extract large amounts of text, for example, customer reviews about the products. Mining consumer reviews can reveal insights like most loved feature, most hated feature, improvements required, and reviews of competitors' products. Security monitoring. Text mining helps in monitoring and extracting information from news articles and reports for national security purposes. Text mining makes sure to use all of your available information. It is a more effective and productive knowledge discovery that allows you to make better informed decisions, automate information-intensive processes, gather business-critical insights, and mitigate operational risk. Let's look at the applications of text mining. Speech recognition. Speech recognition is the recognition and translation of spoken language into text and vice versa. Speech often provides valuable information about the topics, subjects, and concepts of multimedia content. Information extraction from speech is less complicated, yet more accurate and precise than multimedia content. This fact motivates content-based speech analysis for multimedia data mining and retrieval, where audio and speech processing is a key enabling technology. Spam filtering. Spam detection is an important method in which textual information contained in an email is extracted and used for discrimination. Text mining is useful in automatic detection of spam emails based on the filtering content. Using text mining, an email service provider such as Gmail or Yahoo Mail checks the content of an email, and if some malicious text is found in the mail, then that email is marked as spam and sent to the spam folder. Sentiment analysis. It is done in order to determine if a given sentence expresses positive, neutral, or negative sentiments. Sentiment analysis is one of the most popular applications of text analytics. The primary aspect of sentiment analysis includes data analysis of the body of the text for understanding the opinion expressed by it and other key factors comprising modality and mood. Usually, the process of sentiment analysis works best on text that has a subjective context than on that with only an objective context. E-commerce personalization. Text mining is used to suggest products that fit into a user's profile. Text mining is increasingly being used by e-commerce retailers to learn more about the consumers, as it is the process of analyzing textual information in order to identify patterns and gain insights. E-commerce retailers can target specific individuals or segments with personalized offers and discounts to boost sales and increase customer loyalty by identifying customer purchase patterns and opinions on particular products. Let's look at Natural Language Toolkit library in detail. Natural Language Toolkit is a set of open-source Python models that are used to apply statistical natural language processing on human language data. Let's see how you can do environment setup of NLTK. Go to Windows Start and launch Python Interpreter from Anaconda prompt and enter the following commands. Enter command Python to check the version of Python installed on your system. Enter import NLTK to link you to the NLTK library available to download. Then enter NLTK.download function that will open the NLTK download window. Check the download directory, select all packages, and click on Download. This will download NLTK onto your Python. Once you have downloaded the NLTK, you must check the working and functionality of it. In order to test the setup, enter the following command in Python idle. From nltk.corpus import brown, brown.word parenthesis parenthesis. The brown is an NLTK corpus that shows the systematic difference between different genres available. Words function will give you the list available words in the genre. The given output shows that we have successfully tested the NLTK installed on Python. Let's now understand how you can read a specific module from NLTK corpora. If you want to import an entire module from NLTK corpora, use asterisk symbol with that module name import command. Enter the command from nltk.book import asterisk. It will load all the items available in NLTK's book module. Now, in order to explore brown corpus, enter the command nltk.corpus import brown. This will import brown corpus on the Python. Enter brown.categories function to load the different genres available. Select a genre and assign that genre to a variable using the following syntax. Variable name is equal to brown.words. Categories is equal to genre name. Now, in order to see the available words inside the selected genre, just enter the defined variable name as a command. Let's understand text extraction and pre-processing in detail. So let's first understand the concept of tokenization. Tokenization is the process of removing sensitive data and placing unique symbols of identification in that place in order to retain all the essential information concerned with the data by its security. It is a process of breaking running streams of text into words and sentences. It works by segregating words using punctuation and spaces. Text extraction and pre-processing n-grams. Now let's look at what n-gram is and how it is helpful in text mining. N-gram is the simplest model that assigns these probabilities to sequences of words or sentences. N-grams are combinations of adjacent words or letters of length n in the source text. So n-gram is very helpful in text mining when it is required to extract patterns from the text. As in the given example, this is a sentence. All of these words are considered individual words and thus represent unigrams. A 2-gram or bigram is a two-word sequence of words like this is a, or a sentence, and a 3-gram or trigram is a three-word sequence of words like this is a, or is a sentence. Let's now understand what stop words are and how you can remove them. Stop words are natural language words that have negligible meaning, such as a, an, and, or, the, and other similar words. These words also will take up space in the database or increase the processing time, so it is better to remove such words by storing a list of stop words. You can find the list of stop words in the NLTK data directory that is stored in 16 different languages. Use the following command to list the stop words of English language defined in NLTK corpus. Importing NLTK will import the NLTK corpus for that instance. Enter from NLTK.corpus import. Stop words will import stop words from NLTK corpus. Now set the language as English, so use set function as set under braces stop words dot words. Set genre as English. Stop words are filtered out before processing of natural language data, as they don't reveal much information. So as you can see in the given example, before filtering the sentence, the tokenization of stop word is processed in order to remove these stop words, and the filtering is applied in order to filter the sentence based on some criteria. Text extraction and pre-processing stemming. Stemming is used to reduce a word to stem or base word by removing suffixes such as helps, helping, helped, and helper to the root word help. The stemming process or algorithm is generally called a stemmer. There are various stemming algorithms such as Porter stemmer, Lancaster stemmer, Snowball stemmer, etc. Use any of the stemmers defined under NLTK stem corpus in order to perform stemming as shown in the example. Here we have used Porter stemmer. When you observe the output, you will see that all of the words given have been reduced to their root word or stem. Text extraction and pre-processing lemmatization. Lemmatization is the method of grouping the various inflected types of a word in order that they can be analyzed as one item. It uses vocabulary list or morphological analysis to get the root word. It uses WordNet database that has English words linked together by their semantic relationship. As you can observe, the given example, the different words have been extracted to their relevant morphological word using lemmatization. Text extraction and pre-processing POS tagging. Let's now look at different part-of-speech tags available in the National Language Toolkit library. A POS tag is a special label assigned to each token or word in a text corpus to indicate the part of speech and often also other grammatical categories such as tense, number, either plural or singular, case, etc. POS tags are used in text analysis tools and algorithms and also in corpus searches. So look at the given example. Here, Alice wrote a program is the source text given. The POS tags given are Alice is a noun, wrote is a verb, a is an article, and program is an adjective. Look at the given example to understand how POS tags are defined. So the given sentence or paragraph contains different words that represent different parts of speech. We will first use tokenization and removal of stop words, and then allocate the different POS tags. These are shown with different words in the given sentence. POS tags are useful for lemmatization in building named entity recognition and extracting relationships between words. Text extraction and pre-processing named entity recognition. Now let's understand what named entity recognition is all about. NER seeks to extract a real-world entity from the text and sorts it into predefined categories, such as names of people, organizations, locations, etc. Many real-world questions can be answered with the help of name entity recognition. Were specified products mentioned in complaints or reviews? Does the tweet contain the name of a person? Does the tweet contain the person's address? As you can see in the given example, Google, America, Larry, Page, etc. are the names of a person, place, or an organization. So these are considered named entities and have different tags such as person, organization, GPE, or geopolitical entity, etc. NLP process workflow. Now you have an understanding of all NLTK tools. So now let's understand the natural language processing workflow. Step 1, tokenization. It splits text into pieces, tokens, or words and removes punctuation. Step 2, stop word removal. It removes commonly used words such as the, is, are, etc., which are not relevant to the analysis. Step 3, stemming and lemmatization. It reduces words to base form in order to be analyzed as a single item. Step 4, POS tagging. It tags words to be part of speech such as noun, verb, adjective, etc. based on the definition and context. Step 5, information retrieval. It extracts relevant information from the source. Demo 1, Brown Corpus. Problem statement. The Brown University Standard Corpus of Present-Day American English, also known popularly as Brown Corpus, was compiled in the 1960s as a general corpus in the field of corpus linguistics. It contains 500 samples of English language text, totaling roughly 1 million words, compiled from works published in the United States in 1961. We will be working on one of the subset dataset and perform text processing tasks. Let us import the NLTK library and read the CA_10 corpus. Import NLTK. We will have to make sure that there are no slashes in between. Hence, we will use the replace function within pandas for the same. Let's have a look at the data once. Tokenization. After performing sentence tokenization on the data we obtain, similarly, after applying Sentence Tokenizer, the resulting output shows all individual words, tokens. Stop word removal. Let's import the stop word library. From nltk.corpus, import stop words. We also need to ensure that the text is in the same case. NLTK has its own list of stop words. We can check the list of stop words using stopwords.words and English inside the parenthesis. Map the lowercase string with our list of word tokens. Let's remove the stop words using the English stop words list in NLTK. We will be using set checking as it is faster in Python than a list. By removing all stop words from the text, we obtain Often we want to remove the punctuations from the documents too. Since Python comes with batteries included, we have string.punctuation. From string, import punctuation. Combining the punctuation with the stop words from NLTK. Removing stop words with punctuation. Stemming and lemmatization. We will be using stemming and lemmatization to reduce words to their root form. For example, walks, walking, walked will be reduced to their root word walk. Importing Porter Stemmer as the stemming library. From NLTK.stem, import Porter Stemmer. Printing the stem words. Import the WordNet lemmatizer from NLTK.stem. Printing the root words. We also need to evaluate the POS tags for each token. Create a new word list and store the list of word tokens against each of the sentence tokens in Data 2. For I in tokenized, also, we will check if there were any stop words in the recently created word list. We will now tag the word tokens accordingly using the POS tags and print the tagged output. For our final text processing task, we will be applying named entity recognition to classify named entities in text into predefined categories such as the names of persons, organizations, locations, expressions of times, quantities, monetary values, percentages, etc. Now press the tagged sentences under the chunk parser. If we set the parameter binary equals true, then named entities are just tagged as NE. Otherwise, the classifier adds category labels such as person, organization, and GPE. Create a function named as extract entity names along with an empty list named as entity names. We will now extract named entities from a NLTK chunked expression and store them in the empty created above. Again, we will set the entity names list as an empty list and will extract the entity names by iterating over each tree in chunked sentences. Great, we have seen how to explore and examine the corpus using text processing techniques. Let's quickly recap the steps we've covered so far. 1. Import the NLTK library. 2. Perform tokenization. 3. Perform stemming and lemmatization. 4. Remove stop words. 5. Perform named entity recognition. Structuring sentences, syntax. Let's first understand what syntax is. Syntax is the grammatical structure of sentences. In the given example, this can be interpreted as syntax, and it is similar to the ones you use while writing codes. Knowing a language includes the power to construct phrases and sentences out of morphemes and words. The part of the grammar that represents a speaker's knowledge of these structures and their formation is called syntax. Phrase structure rules are rules that determine what goes into a phrase, that is, constituents of a phrase, and how the constituents are ordered. Constituent is a word or group of words that operate as a unit and can be used to frame larger grammatical units. The given diagram represents that a noun phrase is determined when a noun is combined with a determiner, and the determiner can be optional. A sentence is determined when a noun phrase is combined with a verb phrase. A verb phrase is determined when a verb is combined optionally with the noun phrase and prepositional phrase. And a prepositional phrase is determined when a preposition is combined with a noun phrase. A tree is a representation of syntactic structure of formulation of sentences or strings. Consider the given sentence. The factory employs 12.8% of Bradford County. What can be the syntax for pairing this statement? Let's understand this. A tree is produced that might help you understand that the subject of the sentence is the factory. The predicate is employs, and the target is 12.8%, which in turn is modified by Bradford County. Syntax parses are often a first step toward deep information extraction or semantic understanding of text. Rendering syntax trees. Download the corresponding .exe file to install the Ghost script rendering engine based on your system configuration in order to render syntax trees in your notebook. Let's understand how you can set up the environment variable. Once you have downloaded and installed the file, go to the folder where it is installed and copy the path of the file. Now go to System Properties, and under Advanced Properties, you will find the Environment Variable button. Click on that to open the pop-up box tab of the environment. Now open the bin folder and add the path to the bin folder in your environment variables. Now you will have to modify the path of the environment variable. Use the given code to test the working of syntax tree after the setup is successfully installed. Structuring sentences, chunking and chunk parsing. The process of extraction of phrases from unstructured text is called chunking. Instead of using just simple tokens which may not represent the actual meaning of the text, it is advisable to use phrases such as Indian team as a single word instead of Indian and team as separate words. The chunking segmentation refers to identifying tokens, and labeling refers to identifying the correct tag. These chunks correspond to mixed patterns in some way. To extract patterns from chunks, we need chunk parsing. The chunk parsing segment refers to identifying strings of tokens, and labeling refers to identifying the correct chunk type. Let's look at the given example. You can see here that yellow is an adjective, dog is a noun, and the is the determiner, which are chunked together into a noun phrase. Similarly, chunk parsing is used to extract patterns and to process such patterns from multiple chunks while using different parsers. Let's take an example and try to understand how chunking is performed in Python. Let's consider the sentence, "The little mouse ate the fresh cheese," assigned to a variable named cent. Using the word tokenize function under NLTK corpora, you can find out the different tags associated with the sentence provided. So as you can see in the output, different tags have been allocated against each of the words from the given sentence using chunking. NP chunk and parser. You will now create grammar from a noun phrase and will mention the tags you want in your chunk phrase within the function. Here you have created a regular expression matching the string. The given regular expression indicates optional determiner followed by optional number of adjective followed by a noun. You will now have to parse the chunk. Therefore, you will create a chunk parser and pass your noun phrase string to it. The parser is now ready. You will use the parse parenthesis parenthesis within your chunk parser to parse your sentence. The sentence provided is "The little mouse ate the fresh cheese." This sentence has been parsed and the tokens that match the regular expressions are chunked together into noun phrases, NP. Create a verb phrase chunk using regular expressions. The regular expression has been defined as optional personal pronoun followed by 0 or more verbs with any of its type followed by any type of adverb. You'll now create another chunk parser and pass the verb phrase string to it. Create another sentence and tokenize it. Add POS tags to it. So the new sentence is, "She is walking quickly to the mall," and the POS tag has been allocated from NLTK corpora. Now use the new verb phrase parser to parse the tokens and run the results. You can look at the given tree diagram, which shows a verb parser where a pronoun followed by two verbs and an adverb are chunked together into a verb parse. Structuring sentences, chinking. Chinking is the process of removing a sequence of tokens from a chunk. How does chunking work? The whole chunk is removed when the sequence of tokens spans an entire chunk. If the sequence is at the start or the end of the chunk, the tokens are removed from the start and end, and a smaller chunk is retained. If the sequence of tokens appears in the middle of the chunk, these tokens are removed, leaving two chunks where there was only one before. Consider you create a chinking grammar string containing three things: chunk name, the regular expression sequence of a chunk, the regular expression sequence of your chink. Here in the given code, we have the chunk regular expression as optional personal pronoun, followed by 0 or more occurrences of any type of the verb type followed by 0 or more occurrences of any of the adverb types. The chink regular expression says that it needs to check for the adverb in the extracted chunk and remove it from the chunk. Inside the chinking block with open curly braces and closing curly braces, you have created one or more adverbs. You will now create a parser from NLTK.regexp parser and pass the chink grammar to it. Now use the new chink parser to parse the tokens sent3 and run the results. As you can see, the parse tree is generated. While comparing the syntax tree of the chink parser with that of the original chunk, you can see that the token is quickly, adverb, chinked out of the chunk. Let's understand how to use context-free grammar. A context-free grammar is a four-tuple sum NTRS where sum is an alphabet and each character in sum is called a terminal. NT is a set, and each element in NT is called a non-terminal. R, the set of rules, is a subset of NT times the set of sum UNT. S, the start symbol, is one of the symbols in NT. A context-free grammar generates a language L capturing constituency and ordering. In CFG, the start symbol is used to derive the string. You can derive the string by repeatedly replacing a non-terminal on the right-hand side of the production until all non-terminals have been replaced by terminal symbols. Let's understand the representation of context-free grammar through an example in context-free grammar. A sentence can be represented as a noun phrase followed by a verb phrase. Noun phrase can be a determiner, nominal. A nominal can be a noun. VP represents the verb phrase. A can be called a determiner. Flight can be called a noun. Consider the string below where you have certain rules. When you look at the given context-free grammar, a sentence should have a noun phrase followed by a verb phrase. A verb phrase is a verb followed by a noun. A verb can either be Saul or met. Noun phrases can either be John or Jim, and a noun can either be a dog or a cat. Check the possible list of sentences that can be generated using the rules. Use the join function to create the possible list of sentences. You can check the different rules of grammar for sentence formation using the production function. It will show you the different tags used and the defined context-free grammar for the given sentence. Demo 2, Structuring Sentences. Problem statement. A company wants to perform text analysis for one of its data sets. You are provided with this data set named tweets.csv, which has tweets of 6 U.S. airlines along with their sentiments, positive, negative, and neutral. The tweets are present in the text column and sentiments in airline_sentiment column. We will be retrieving all tags starting with @ in the dataset and save the output in a file called references.txt. Let us first import the pandas library and read the tweets dataset. Extract the features, text, and airline sentiment. We will iterate through the dataset using regex, find the relevant tweets. Now we will import the itertools module. It returns efficient iterators. The result is stored in a file named references.txt. Let's extract all noun phrases and save them in a file named noun phrases for _airline_sentiment review.txt. Here, _airline_sentiment has 3 different values, positive, negative, and neutral, so 3 files will be created. Now we will iterate all the leaf nodes and assign them to noun phrases variable. This means that the functions in itertools operate on iterators to produce more complex iterators. Using the map function, we will get all the noun phrases from the text. Putting it into list. Creating a file name in the name of review.txt. Great, we have now seen how to explore and examine the corpus using text processing techniques.
If you are an aspiring AI ML engineer, then there is no better time to train yourself in an exciting field of machine learning. If you are looking for a course that covers everything from fundamentals to advanced techniques like machine learning algorithm development and unsupervised learning, look no further than our Caltech in partnership with IBM. So why wait? Join now. Seats are filling fast. Find the course link from the description box below.
So first we will import some major libraries of Python. So here I will write import pandas as pd and import numpy as np. Then import cborn as sns. Okay. Then import sklearn dot model selection import train underscore test underscore split. Before that I will import matplotlib dot pyplot as plt. Okay, then I will write here from sklearn dot matrix import accuracy score. Then from sklearn dot matrix import classification to report. Then import re, then import string. Okay, then press enter. So it is saying, okay, here I have to write from everything seems good. Loading, let's see. Okay, till then, NumPy is a Python library used for working with arrays. It also has function for working with the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. Pandas. So Panda is a software library written for Python programming language for data manipulation and analysis. In particular, it offers data structure and operation for manipulating numerical tables and time series. Then, Seaborn. An open source Python library based on Matplotlib is called Seaborn. It is utilized for data exploration and data visualization. With data frames and the Pandas library, Seaborn functions with ease. Then, Matplotlib. For Python and its numerical extension NumPy, Matplotlib is a cross-platform for the data visualization and graphical charting package. As a result, it presents a strong open source suitable for MATLAB. The APIs for Matplotlib allow programmers to incorporate graphs into GUI applications. Then this train test split. We may build our training data and the test data with the aid of sklearn train test split function. This is so because the original dataset often serves as both the training data and the test data. Starting with a single dataset, we divide it into two datasets to obtain the information needed to create a model, like hone and test. Accuracy score. The accuracy score is used to gauge the model's effectiveness by calculating the ratio of total true positive to total true negative across all the model prediction. This RE, regular expression. The functions in the model allow you to determine whether a given text fits a given regular expression or not, which is known as RE. Okay, then string. A collection of letters, words, or other characters is called a string. It is one of the basic data structure that serves as the foundation of manipulating data. The str class is a built-in string class in Python. Because Python strings are immutable, they cannot be modified after they have been formed. Okay, so now let's import the dataset. We will be going to import two datasets, one for the fake news and one for the true news, or you can say not fake news. Okay, so I will write here pf underscore fake equals to pd dot read underscore csv, or what can I say, df fake. Okay, data underscore fake. Okay, then fake dot csv. You can download this dataset from the description box below. Then data dot true equals to pd dot read underscore csv. Sorry, csv. Then fake news. Sorry, true. True dot csv. Okay. Then press enter. So these are the two datasets. You can download these datasets from the description box below. So let's see the board dataset. Okay. Then I will write here data underscore fake dot head. So this is the fake data. Okay. Then data underscore true dot head. And this is the true data. Okay. This is not fake. So if you want to see your top 5 rows of the particular dataset, you can use head. And if you want to see the last 5 rows of the dataset, you can use tail instead of head. Okay. So let me give some space for the better visual. So now we will insert column class as a target feature. Okay. Then I will write here data underscore fake class equals to 0. Then data underscore true and class equals to 1. Okay. Then I will write here data underscore fake dot shape and data underscore true dot shape. Okay, then press enter. So the shape method returns the shape of an array. The shape is a tuple of integers. These numbers represent the length of the corresponding array dimension. In other words, a tuple containing the quantities of entries on each axis is an array shape dimension. So what's the meaning of shape? In the fake world, in this dataset, we have 2, 3, 4, 8, 1 rows and 5 columns. And in this dataset, true, we have 2, 1, 4, 1, 7 rows and 5 columns. Okay, so these are the rows, column for the particular dataset. So now let's move and let's remove the last 10 rows for the manual testing. Okay, then I will write here data underscore fake. Let's go manual testing was to data underscore fake dot tail. For the last 10 rows, I have to write here 10. Okay, so for I in range 2, 3, 4, 8, 1, sorry, 0, comma, 2, 3, 4, 7, 0, comma, -1. Okay, then df underscore, not df, data underscore fake dot drop 1. Yeah, instead of 1, I can write here I, comma, axis equals to 0, in place equals to true. Then data, not here, data underscore same I will write for, I will copy from here and I will paste it here and I will make the particular changes. So here I can write true, here I can write true. Okay, then I have to change a number. 2, 1, 4, 1, 6. Write 2, 1, 4, 0, 6, -1. Same. So press enter. X is equals to 0. Valid syntax. Maybe you mean 00 or show of this. Okay, we will put here double equals. And I'm putting this. Fake dot drop I x is equal to 0. Acha, in place. Okay. Here also write equals to equals to. Yeah. So okay, axis is not defined. Now it's working. So let me see now data underscore fake dot shape. Okay, and data dot true and data underscore true dot shape. As you can see, 10 rows are deleted from each dataset. Yeah. So I will write here data underscore fake underscore manual testing and class equals to 0 and data underscore true underscore manual underscore testing class equals to 1. Okay. Just ignore this warning. Then let's see data underscore fake underscore manual testing dot head. As you can see, we have this, and then data dot underscore true underscore manual testing dot head. Done. Okay. This is the true data set. So here I will merge data underscore merge equals to pd dot concat. Concat is used for the concatenation. Data underscore fake data underscore true comma axis equals to 0. Then data underscore merge dot head the top 10 rows. Yeah, as you can see, the data is merged here. Okay. First it will come for the fake news and then with the for the true news. And let's merge true and fake data frames. Okay, we did this, and let's merge the column. Then data dot merge dot columns, or let's see the columns. It is not defined, but I did data underscore merge. These are the columns name, title, text, subject, date, class. Okay, now let's remove those columns which are not required for the further process. So here I will write data underscore or equals to data underscore merge prop title we don't need, then subject we don't need, then so 1. So let's check some null values. It's giving error where because of this. That's good. Then data dot is null dot sum center. So no null values. Okay. Then let's do the random shuffling of the data frames. Okay. For that, we have to write here data equals to data dot sample one. Then data, okay, data dot hat. Okay. Now you can see here the random shuffling is done, and one for the true data set and 0 for the fake news one. Okay. Then let me write here data dot reset underscore index place equals to true. Data dot drop comma axis equals to 1, then comma in place equals to true. Okay. Then let me see columns now. Data dot columns. So here we have two columns only, rest we have deleted. Okay. So let me see data dot add. Yeah, everything seems good. Let's proceed further and let's create a function to process the text. Okay. For that, I will write here word. Okay. You can use any name text, and text equals to text dot lower. Okay. And text equals to re dot for the substring remove these things from the datas. Okay. So for that, I'm writing here comma okay. Then text equals to re dot substring comma comma text. Okay. Then I have to write text equals to re dot substring www dot s plus comma comma text. Okay, then text equals to re dot substring, then dot comma okay, then text equals to re dot substring, then percentage s, again percentage for re.sk function, right here string dot punctuation, okay, comma, then text, right? Then text equals to re dot substring and n, comma, text equals to re dot substring, right here, and again d, then again, okay, then comma, then again text here, okay. Then at the end I have to write here return text. So everything like these type of special character will be removed from the data set. Okay, let's run this. Let's see. Yeah. So here I will write df. Sorry, not df. Data. Then text pursue data. Okay. Dot apply to the function name word opt. Okay. Then press enter. Yeah. So now let's define the dependent and independent variables. Okay, x equals to data text and y equals to data class. Okay, then splitting training and testing data. Okay, sorry. So here I will write x underscore train, comma x underscore test, then y underscore train, comma y underscore test equals to train underscore test underscore split, then x comma y comma test underscore size equals to 0.25. Okay, press enter. So now let's convert text to vectors. For that I have to write here z, it's x. So here I will write from sklearn dot feature extraction dot text import t vectorizer. Okay, then vectorization equals to tfid vectorizer. Okay, then xv underscore train equals to vectorization or tion vectorization dot fit, then transform x underscore train. Okay, then xv underscore test equals to factorization dot transform x underscore test. Okay, then press enter. So now let's see our first model, logistic regression. So here I will write from sklearn dot linear underscore model. Okay, import logistic regression. Okay. Then lr equals to logistic regression, and I have to write here lr dot fit, then xv dot not dot xv dot train comma xv underscore test. Okay, press enter. L dot xv dot train. Okay, here I have to write y train. Okay, then press enter. Will work. So here I will write prediction underscore linear regression equals to lr dot predict xv underscore test. Okay, let's see the accuracy score. For that I have to write lr dot score, then xv underscore test comma y underscore test. Okay, let's see the accuracy. So here as you can see, accuracy is quite good, 98%. Okay, now let's print the classification port y underscore test comma prediction of linear regression. Okay, so this is, you can see, precision score, then f1 score, then support value, accuracy. Okay, so now we will do this same for the decision tree gradient boosting classifier, random forest classifier. Okay, then we will do model testing, then we will predict the score. Okay, so now for the decision tree classification. So for that I have to import from sklearn dot tree import decision tree classifier. Okay, then at the short form I will write here, I will copy it from here, then okay, then I have to write the same as this, so I will copy it from here and here. Just change linear regression to decision tree classifier. Okay, then I will write here same, go dt equals to dt dot predict xv underscore test. It's v still loading, it will take time. Okay, till then let me write here for the accuracy dt dot score v underscore test comma y. Okay. Let's wait. Okay, let's run the accuracy. So as you can see, accuracy is good than this linear regression. Okay, logistic regression. Okay, so let me show you the. Let me print. Okay, so this is the accuracy score. This is the all the report. Yeah. So now let's move for the gradient boosting classifier. Okay, for that I've write from SciLearn dot ensemble port gradient boosting classifier. Classifier. I will write here GB equals to, let me copy it from here. Okay. I will give here random underscore state equals to 0. Wait. So I will write here GB dot fit xv underscore train comma y underscore train. Okay, then press enter. Here I will write predict underscore GB equals to GB dot fit, sorry, predict xv dot test, not dot underscore test. Till then it's loading, so I will write here for the score, then I will add GB dot score, then xv underscore test comma y underscore test. Okay, so let's wait, it is running this part. Till then let me write for the printing this. Okay, it's taking time. Still taking time. What if I will run this? It's not coming because of this. Yeah, it's done now. So you can see the accuracy is not good than decision tree, but yeah, it is also good, 99.4 something. Okay, so now let's check for the last one, random forest. First I will do, for the random forest we have to write from sklearn dot ensemble import random forest classifier. Okay, then here I will write rf equals to, right, I will copy it from here. Then random state equals to 0. Then rf dot fit xv underscore train comma y underscore train. Okay, then press enter and predict underscore rc or f equals to rf dot predict sv underscore test. Okay, till then I will write here, it's still loading, it will take time. So till then I will write for the score accuracy score xv underscore test comma y underscore test. Okay, then I will write here till then print classification port and y underscore test comma it will take time little bit so it run the accuracy score is 99, it is also good. So now I will write the code for the model testing, so I will get back to you but after writing the code. So I have made two functions, one for the output label and one for the manual testing. Okay, so it will predict the all the from the all models from the repeat. So it will predict the news is fake or not from all the models. Okay, so for that let me write here news was to string put. Okay, then I will write here manual underscore testing. Okay. So here I will you can add any news from the you can copy it from the internet or whatever from wherever you want. So I'm just copying from the internet, okay, from the Google, the news which is not fake. Okay, I'm adding which is not fake because I already know I searched on Google. So I'm entering this. So just run it. Let's see what is showing. Okay, string input object is not callable. Okay, let me check this first. Okay, I have to give here str only. Yeah, let's check. Okay, I have to add here again the script. Yeah, the manual testing is not defined. Let me see manual testing. Okay, I have to edit something. It is just GB and it is just RF. Still GBC is not defined. Okay, okay. So what I have to do? I have to remove this. Okay, everything seems sorted now. Yeah. So as I said to you, I just copied this news from the internet. I already know the news is not fake, so it is showing not a fake news. Okay, so now what I will do, I will copy one fake news from the internet and let's see it is detecting it or not. Okay, so let me run this and let me add the news for this. So all the models are predicting right it is a fake news, or you can add your own script like this is the fake news. Okay, I hope you guys understand till here. So I hope you guys must have understand how to detect a fake news using machine learning. You can copy any news from the internet and you can check what is time series forecasting. Making scientific projection based on the data with historical timestamps is known as time series forecasting. It entails creating models through historical study, using them to draw conclusion and guide strategic decision making in the future. The fact that the future result is wholly unknown at the time of the task and can only be anticipated through analysis and evidence based priors is an essential distinction in forecasting. Give yourself a chance to Simplilearn's professional certificate program in AI and machine learning, which comes with completion certificate and in-depth knowledge of AI and machine learning. Check this course detail from the description box below. So here is one question for you guys. I will give you exactly 1 minute for this. You can comment or you can give your answer in the chat section so I can see if the answers given by you are right or wrong. Okay. So the question is, which type of programming does Python support? I'm repeating again. Which type of programming does Python support? Option A, object oriented programming. Option B, structured programming. Option C, functional programming. And option D, all of the above. So let us know in your answer in the chat section or in the comment section. So I'm starting a timer of 1 minute. Just type your answer in the comment section or in the chat section. Do let me know your answers, please. So I'm starting the timer of 1 minute. Which type of programming does Python support? Object oriented, structured programming, functional, or all of the above? Do let me know your answers, please. You can comment or you can give your answer in the chat section so I can see if the answers given by you are right or wrong. Which type of programming does Python support? Object oriented, structured, functional, or all of the above? 30 seconds remaining. Which type of programming does Python support? Object oriented, structured, functional, or all of the above? Let us know your answers in the chat section or in the comment section below. 10 seconds more. Which type of programming does Python support? 5 seconds more. So the allotted time is over. We will give a reply to those who gave the correct answer. And for those who didn't give the correct answer, we will give you reply with the correct answer. Okay. Now let's move to our programming part. So we will open command prompt to write a command to open Jupyter Notebook. So here I will write Jupyter Notebook. Press OK, Jupyter Notebook. Press enter. Will take time. It's open. So this is the landing page of Jupyter Notebook, and here I will select new Python kernel file. So this is how Jupyter kernel look like. So here what we will do, we will import some major libraries of Python which will help us in analyzing the data. Okay, import numpy as np. Okay, then import pandas as pd. Then import seaborn as sns. The fourth one is from matplotlib port pyplot as plt. Okay, then we will import some model libraries. So here I will write from stats models dot tsa dot api import exponential smoothing and comma, then simple XP smoothing. Then one more hold. We will write here from sklearn dot linear underscore model import linear regression. Okay. Then import warnings. Warnings. Then we will write here warnings dot filter warnings. It should be ignore. Yes, there will be no error. Oh, it's still loading. Yeah. So NumPy. NumPy is a Python library used for working with arrays. It also has a function for working with the domain of linear algebra and matrices. It is an open source project and you can use it freely. NumPy stands for numerical Python. Second is Panda. Pandas is a software library written for the Python programming language for data manipulation and analysis. In particular, it offers data structure and operations for manipulating numerical data and time series. Then Seaborn. An open source Python library based on Matplotlib is called Seaborn. It is utilized for data exploration and data visualization. With data frames and the pandas library, Seaborn function with ease. Matplotlib. For Python and its numerical extension NumPy, Matplotlib is a cross-platform data visualization and graphical charting package. As a result, it presents a strong open source substitute for Matplotlib. The APIs for Matplotlib allow programmers to incorporate graphs into GUI applications. Linear regression. The machine learning method regression built on linear supervised learning. Analysis regression is done. Regression creates a value for the aim prediction using independent variables as inputs. Its main goal is to investigate the relationship between factors and forecasting. Exponential smoothing. The exponential windows function is a general method for smoothing time series data known as exponential smoothing. It contrasts to the ordinary moving average, which weights previous data quality. Exponential function use weights that decrease exponentially with time. And there is one more simple exponential smoothing. The simple exponential smoothing classes use simple exponential smoothing models to give very simple time series analysis. A weight average of the most recent value and the preceding smooth value constitute the predicted value. The contribution of older value degrade exponentially as a result of the smoothing parameter. Okay, so after importing libraries, let's import dataset. For this, I will write here df, or you can write data frame pd dot read underscore csv. Here I will write monthly underscore csv dot csv. Okay, this is my file name. You can download this file from the description box below. And for seeing the data, I will write here df dot head. Okay, then press enter. Yeah. So here PD is for pandas library, read is used for reading the dataset from the machine, and CSV is used for the type of file which you are using, okay, or which you want to read. And if you want to see the top 5 rows of your dataset, you can use head. And if you want to see the last 5 rows of your dataset, you can use tail instead of head. Okay, this one you can write here tail. So moving forward, let's see how many rows and columns are present in our dataset. For that, I have to write df dot shape. Okay, then press enter. Okay, it will give error. Why? Because this. Yeah. So here you can see 847 rows and 2 columns, date and price only. So moving forward, let's do some EDA, exploratory data analysis. Okay, for that I have to write here print data date range of gold prices available from then here I have to give curly brackets, then df dot location loc, then colon comma date. Okay, D is capital here, so I have to write date. Then from location 0 to again same thing df dot loc date to the length of df minus 1. Oh, everything seems good. Yeah. Then press enter. Okay. We have date range of gold prices available from this 1950 to 2020. Okay, in our data set. Then here I will write date equals to pd dot date range start from /1 slash 1950 comma and equals to 8/1 slash 2020 comma frequency equals to median. Okay, then here I will write date, then press enter. Yeah. So here you can see date time index. Okay, from starting till end, these dots, and here I will write df month was to date. Df dot drop is date comma axis is 1 comma in place was to true. T should be capital. Okay. Then df equals to df dot set index and month, and df dot head, press enter. So instead of this date we have adjusted this month, okay, for particular value. So moving forward, let's see the graph, different graphs. Okay, df dot plot, then figure set should be equals to 20 comma 8, then plot dot title is like gold prices monthly since 1950 and onwards. Okay, title should be this. Then X label should be plt dot X label will be months. Then plt dot Y labels should be price. Then I will write here plt dot grid. Okay, press enter. Okay, title spelling, my bad, title. Okay, then press enter. Oh, Y label it is, sorry. Yeah. Here you can see gold prices monthly since 1950 and onwards. Okay, till from 1950 and from till 2020. Okay, this is the price. Then moving forward, let's see another graph. So I will write here for that round df dot describe comma 3. And here you can see the count variable and the average is 416.557 standard deviation. That minimum price value is this, 20% this, and the maximum value is this. Okay, so so the average gold price in last 70 years is this 416.557. Okay, only 25% of the time the gold price is above 447. The highest gold price ever touched is this one, 1840, 807. So we will do visual analysis. So here I will write AX equals to PLT dot subplots. Okay. Then figure size equals to 25 comma art. Okay. Then SNS dot box plot is X equals to df dot index dot year comma y equals to df dot values colon comma 0 comma ax equals to ax. Okay, then same plt dot title gold price monthly 1950 onwards. Same graph will come but in the different format. Okay, let me remove this. Then plt dot x label must be year, plt dot y label price, and plt dot xticks will be rotation equals to, okay, I will give rotation 90 plt dot grid. Can write here instead of grid, I can write here directly show. So grid is this format, this box format. Okay, so press enter. It's loading. Yeah. So here you can see from 1950, every year is here till 2020. So how the gold prices are decreasing and increasing. Okay. Let's see the another graph. I will write here from sets models dot graphics dot TSA plots quote month plot. Okay. Then I will write here figure comma AX equals to then PLT dot subplots figure size equals to 22 comma 8. Okay. Then month plot df comma y label equals to gold price. Okay, comma then ax equals to ax, and I will give the title plt dot title. So I will copy from here. Okay. And plt dot x label month and plt dot y label the price plt dot grid. So here you can see gold prices monthly since 1950, like for every month, like January, February, March, April, so on till December. Okay. We will cover one more graph. Okay, and many more graphs. So we will go with the next graph. For that, I will write here. Let's go, comma ax equals to plt dot subplots and figure size equals to 22 comma 8. Then same sns dot box plot x equals to df dot index dot month name. Okay, then y equals to df dot values comma 0 comma ax equals to ax. Okay, then plt dot title, will put same title so I can copy from it here. Let's copy from here and paste it here. Okay, and plt dot x label and plt dot y label is price, and plt dot grid. Okay, plt dot show. This time let's not use grid. Okay. Okay, something pdf month name. Yes, you can see for every month. This is another type of graph. Okay, box plot graph. So why we are creating so much graphs? Because we are doing EDA, exploratory data analysis. In this, we have to see the multiple different types of graph. Okay, so moving forward, let's see average gold price per year, like trend since 1950. So for that, I have to write here df underscore yearly underscore sum equals to df dot resample sample, then a dot mean df underscore yearly underscore sum dot plot plt dot title, and here I will write average gold price yearly since 1950, or you can write onwards from onwards 1950. So here I will write plt dot x label year and plt dot y label price. Okay, then plt dot grid. This time we'll use grid. So here you can see the average gold price yearly since 1950. Okay, this is the chart till 2020, like sometimes up, sometimes down. Okay, and we will see now like average gold price per quarter, like trends, like since 1950. So here I will write df dot, not dot, df dot quarterly. Okay, underscore sum equals to df dot resample quarter q dot mean. Okay, okay, move this. Then df underscore quarterly score sum dot plot. Then the same plt dot title from here. Here I will write average gold price quarterly. Quarterly. Okay, since 1950. Then plt dot x label is now here quarter. Plt dot y label is price. Okay. Now plt dot show it this time. Okay, df underscore quarterly. Okay, quarterly. Yeah. So here you can see the price prediction. Okay, let me set to the grid only. It's not visuals are not good, so grid. Yeah. So here you can see the quarterly prices prediction. Okay, average gold price quarterly prediction. So like moving forward, we will see now average gold price per decade, like per 10 years. Okay, so from 1950 only. So here I will write df underscore decade underscore sum equals to df dot resample every 10 year. Okay, 10 year dot mean. We are writing mean because we are like putting out average. Okay, so df underscore decade underscore sum dot plot plt dot title average gold price per decade since 1950. Okay, it's since 1950. Yeah, perfect. So here I will get plt dot x label, then decade is of like every 10 year. Plt dot y label, and plt dot grid. Yeah. So here you can see the average gold price per decade, like from 1950 to 1960, like this, straight, then again straight, then up, then sometimes down, then up and down. Okay. Every 10 year, you can see a 1990, 2000, 2010, and 2020. So moving forward, let's do like analysis in coefficient of variation. The coefficient of variation CV is a statistical measure of the relative dispersion of data points in a data series around the mean. And in finance, the coefficient of variation allows investor to determine how much volatility or risk is assumed in comparison of the amount, like amount to the return expected from investors. Okay, the lower the ratio of the standard deviation to mean return, the better risk return trade off. Okay, let us look now the CV values for each year in gold prices. So CV means coefficient of variation in prices. Okay, so here I will write df underscore 1 equals to df dot group by df dot index dot year dot mean dot name dot columns equals to, I will write price and mean. Okay. Then again df underscore 1 equals to df underscore 1 dot range, or what we can do instead of range we can write merge df dot group by scope df dot index dot year standard deviation rename columns equals to price standard deviation, comma left index equals to true, then comma right index equals to true. Okay, then here df underscore 1 score equals to df underscore 1 standard deviation slash df underscore 1 into 100 like dot round figure should be like 2 after decimal, how much like numbers you want to see, then df underscore 1 dot head, press enter. Yeah, so here you can see for every year I have mean, standard deviation, and this coefficient of variation. Okay, for every year. So like moving forward, let's see the average gold price per year again. So for that figure underscore figure dot comma ax equals to plt dot subplots figure size 15 comma 10. Okay. Then I will write here df underscore 1 is like cov underscore dot plot plt dot title average gold price yearly since 1950. Okay, then plt dot x label is year, or plt dot y label coefficient of variation. I'm writing cv in percent. Okay, then plt dot show. Get df underscore invalid syntax. Okay, what I covc is capital ect the dot plot okay co df underscore 1 df underscore 1 right, it here valid syntax. Okay. So here you can see average gold price since 1950. Okay. This is like percentage, CV in percent. Okay. Like good, you can say the chart. So the CV value reached its highest in 1978, like somewhere here, like 1980, 1978. Okay. Like near to 25%, which could have made the asset as a highly risky. But in 2020, the CV value is closer to 5%, which makes the asset variable via good investment. Okay. So now what we will do time series forecasting. Okay. We will train model, we will build model, different model. We will train and test split to build time series forecasting model. So for that, let me do like this first. Yeah. So here I will write train equals to df dot index dot per year. Okay, equals to 2015. And for the testing, we will write df dot index dot year 2015. Okay, for training we are taking till 2015, for the testing we are taking till 2020 from 2015. Okay, then I will write here how many columns present in train or test. So for that I will write print train dot shape and print test dot shape. Press enter. 792 rows and one column in training for training the model and 55 to test the model. Okay. So now let's see the training data and testing data. So train it's like square brackets. So price dot plot, then figure size equals to 13 comma 5, and font size should be equals to 15. Test size dot plot figure size, let me give same 13 comma 5, and font size should be 15. Okay, then plt dot, let me add grid, plt dot grid, then plt dot legend training data comma test data. Okay, then plt dot show. I will tell you what the legend is. Okay, so here you can see the training data in blue and the testing data. Okay, this is known as the legend, this portion. And yeah, so here you can see month wise. Okay, till 2020 and from 1950, right? These are the prices and this is the chart. So moving forward, let's do model formation now. Okay, we will do two models, linear linear regression and the naive Bayes one. Okay, so first we will go from linear regression. For that, I will write train underscore time equals to I plus 1 for I in range train. Test underscore time equals to I plus length like train one for I in range, then length should be test. Okay, so for length, training time comma length should be test time. Press enter. Okay, this is the training and this for the testing. 792 rows and here 55 rows in testing. So LR underscore LR means linear regression. Let me make it capital. Train equals to make a copy LR underscore test equals to test copy dot copy. Then LR, okay, so LR train time equals to train time. Okay, and LR underscore test time equals to test time. Okay, underscore is there. Yeah. So here I will write LR equals to linear regression dot fit to the model was LR train, and for the time LR LR underscore train price values. Linear regression is not defined. Okay, my bad. L should be capital. Yeah. So now see the graph. So test underscore prediction score model 1 equals to LR dot predict LR underscore test time LR underscore test cost equals to test underscore predictions score model 1. Okay, let's create the graph figure size should be to 14,6. PLT dot plot train price, comma, label should be train. Okay, then plot PLT dot plot test price, label equals to test. PLT dot plot then LR train or tests forecast, comma, label equals to regression on time. Okay, regression on time. Then again PLT dot legend LOC equals to best PLT dot grid. That's enter. Okay, here I have to write predict. Loading. One more error. Price. Just price. Okay, is the price. So here you can see regression on time test data is this green one, and this training data and the testing data. Okay, let's find the map now. So for this, we'll write here DEF map actual comma prediction, then return count p dot mean ABS actual prediction actual by 100 comma 2. Okay, forgot to give the yeah. So for getting the map, you have to write a map underscore model underscore test equals to map test price dot values comma test underscore section underscore model 1. Okay, then print is percent 3 dot 3 f, then here I put percent ape model 1 underscore test comma, percentage. Press enter. Next. Okay. Actual is not defined. Map test. Model 1 test. Map test. Values. The test predictions. Model 1. Okay. Here A is small. So map here you can see 29.760. So you are a bit confused, like what is MAP? MAP is a measure of prediction of accuracy of a forecasting method in statistical model. Okay, is a measure of prediction accuracy of forecasting method in statistical method. Okay. And now results equals to PD dot data frame test MAP in percent MAP underscore model 1 comma index equals to regression on time. Okay, then I will print the results. Okay, D should be capital. Module pandas has no attribute data frame. Okay. Model 1 is not defined. Let's go test. Well, it's in there. Perhaps you got to forget a comma. Colon. Model 1. Okay. Here you can see the test map, regression on time. So let's do with the name now. We have to perform the same pattern. So what I will do, I will write the code and get back to you. Okay. So I'm done with the code. So here you can see I have same pattern, train and test copy. And this is the name forecast on the test data. So this is the line and this is the training and this orange one is testing. The same we have got map like 19.380. Okay. So and regression is this, the name model. So what we will do, we will create now final model of ours. Okay. And we will forecast, final forecasting we'll do. For that I have to write final model equals to exponential smoothing. Okay, df comma trend equals to additive comma seasonal equals to additive comma fit smoothing level equals to 0.4 comma smoothing trend equals to 0.3 comma smoothing seasonal equals to 0.6. Okay, press enter. Exponential. So map go final underscore model is equals to map like df price dot values comma final underscore model dot fitted values. Okay. Then print map comma map underscore final underscore model. Okay, so map is 17.24, which is quite good for the final model. Okay, so getting the prediction for the same number of timestamps at the present time in the test data. So I will write here predictions equals to final underscore model dot forecast steps equals to length dot test center. Now we will compute 95% of confidence interval for the predicted value. So TKF equals to PD dot data frames data frame. Then lower CI prediction 1.96 into NP dot standard deviation of final model dot 1. Okay, and comma right here prediction okay, then upper CI prediction plus 1.96 into dot standard deviation the same final model dot to 1. Okay, then prediction underscore df dot at So this is lower CI prediction and the upper CI. Okay, how much it will forecast. Or now at the end, at the final state, what we will do, we will plot a graph. Okay, forecast graph along with the confidence band. So for that, x is equals to df dot plot label equals to actual comma figure size 16 comma 9 prediction df dot plot ax equals to this comma label underscore df, it's lower CI. What I will do instead of this, label equals to forecast comma alpha equals to 0.5. Okay, this dot fill between function underscore df dot index comma prediction underscore df lower underscore ci comma prediction underscore df this ci. Okay, then color equals to m comma alpha equals to 0.15. Okay, then axis dot set underscore x label year month. Okay, axis dot set y label is plt dot legend should be location equals to best. Then plt dot grid plt dot show. Okay, this is plt only. Then press enter. Okay, 16 comma 9 positional argument follows keyword argument. Okay, right, 15. Oh, okay, I have to give you another upper CI. I've read upper CI. So here you can see our final model forecasting. So till 2020 it is showing like normal, and after that till 2030, okay, this will be the forecast as per the data. Okay, so here you can see we have the map is 17.24. Okay, then here I did the prediction for the testing data, and here I created the data frames. These are the data frames, lower CI prediction and upper CI, and then I have created the final graph of the forecasting. Okay,
If you're an aspiring AI ML engineer, then there is no better time to train yourself in an exciting field of machine learning. If you are looking for a course that covers everything from fundamentals to advanced techniques like machine learning algorithm development and unsupervised learning, look no further than our Caltech in partnership with IBM. So why wait? Join now. Seats are filling fast. Find the course link from the description box below.
OpenCV, Open Source Computer Vision Library, is an open source computer vision and machine learning software library. It is written in C++ but has a binding for various programming languages such as Python, Java, MATLAB. OpenCV was designed with the goal of providing a common infrastructure for computer vision applications and to accelerate the use of machine learning perception in commercial products. OpenCV is widely used in a variety of industries, including robotics, automotive, and healthcare. It's supported by a large community of developers, researchers, and users who contribute to its development and provide support to its users. It is supported by a large community of developers, researchers, and users who contribute to its development and provide support to its users. So now let's see what is object detection. Object detection is a computer vision technology that involves identifying and localizing the object of interest within an image or a video. It is a challenging task as it involves not only recognizing the presence of an object but also detecting its precise location and size within the image or video. Object detection algorithms typically use deep learning techniques such as CNN to analyze the image or video for identifying the objects. These algorithms can also determine the boundaries of the object by drawing a bounding box around them. So after understanding what is object detection, now let's move on to the programming part. So this is a kernel, Python kernel. Here we will change this name. So here I will write object detection demo. Okay, so first we will import some major library like OpenCV. So for that we will write import cv2, and the next one is import matplotlib .pyplot as plt. So why we are writing plt? Because we can't write again and again matplotlib.pyplot. Okay, it's a long one, so we can write a short form plt. So yeah, so let's run this. So what is OpenCV? OpenCV is an open source software library for computer vision and machine learning. The OpenCV full form is Open Source Computer Vision Library. It was created to provide a shared infrastructure for application for computer vision and to speed up the use of machine learning perception in consumer products. OpenCV as a BSD licensed software make it simple for companies to use and change the code. Okay, so there are some predefined packages and libraries that make our life simple, and OpenCV is one of them. Second one is Matplotlib. Matplotlib is a easy to use and an amazing visualize library in Python. It is built on NumPy array and designed to work with broader SciPy stack and consists of several plots like line, bar, scatter, histogram, and many others. Okay, so moving forward we will import our file. Okay, so here I will write config file equals to, this is our file name, ssd underscore mobilenet v3 large coco 22 14.pb. Okay, so you can find this file on the description box below. Frozen model equals to, I'll explain you every single thing. Inference graph.pb. Okay, so let me run it first. MobileNet. As a name applied, the MobileNet model is designed to use in mobile application and it's TensorFlow first mobile computer vision model. MobileNet used depth-wise separable convolutions. It significantly reduces the numbers of parameters when compared to the network with regular convolutions with the same depth in the nets. This results in the lightweight of the deep neural network. So MobileNet is a class of CNN that was open sourced by Google, and therefore this gives us an excellent starting point for training our classifiers that are insanely small and insanely fast. Okay, so what is this large COCO? This is a dataset, COCO dataset.
Like with applications such as object detection, segmentation, and captioning, the COCO dataset is widely understood by the state of the art of neural network. Its versatility and the multi-purpose scene variations serve best to train a computer vision model and benchmark its performance. Okay, so what is COCO? The common object in context is one of the most popular large-scale labeled images dataset available for public use. It represents a handful of objects we encounter on a daily basis and contains image annotations in 80 categories. I will show you the categories I have with over 1.5 million object instances. Okay, so modern day AI driven solutions are still not capable of producing absolute accuracy in result, which comes down to the fact that COCO dataset is a major benchmark for CV to train, test, and polish refined models for faster scaling of the annotation pipeline. On the top of that, the COCO dataset is a supplement to transfer learning where the data used for one model serves as a starting point for the another. So what is frozen inference graph? Like freezing is the process to identify and save all the required graphs like weights and many others in a single file that you can easily use. A typical TensorFlow model contains 4 files and this contains a complete graph. Okay, so forward, let's create one model. Here I will write model equals to cv2.dnn model frozen model and then config file. So here I am giving the parameters, two parameters like frozen model and config file. Let's go here. Yeah, we run it first. Okay, there is error. Return error. Okay, so error is cv2.dnn detection model returned as result with an exception set. The question comes, what is the meaning of detection model or DNN detection model? So this class represents a high-level API for object detection networks. Detection models allows to set parameters for pre-processing input image. Detection model creates net from file and with trained weights and config, sets its processing input, runs forward pass and return the result detection. Okay, moving forward, let's set the class labels. Okay, class labels. File name also labels.txt. I will put this file on the description box below. You can download from there. Open file name. Class labels. Strip. So here I created one array of name class labels. So this is the file name. What I'm doing, I'm putting this label file into this class labels. Okay. So here, if I will print class labels, so these are the 80 categories in the COCO dataset. Okay, this person, bicycle, car, motorbike, aeroplane, bus, train, these all are the 80 categories. I will put this file label.txt in the description box below. You can download from there. Okay, fine. So let's print the length of the COCO dataset, or you can see class labels. This is 80. As you can see, I have already told you the length will be 80. So here let's set this some model input size, scaling, mean, and all. So I will write here model dot set input size 320 320. model dot set input scale 1.0 slash 127.5. Okay, I will explain you, don't worry. Model dot set input mean 127.5 comma 127.5 comma 127.5. Okay, and then model dot set input swap b will be, what is set input size? Okay, so set input size is a size of new frame, the shape of the new blob less than 0. Okay, so this is the size of the new frame. The second one is set input scale. So set input scale is a scale factor of the value for the frame, or you can say the parameter will be the multiplier of the frame values, or you can say multiplier for the frame values. Okay, so set input mean, so it set the mean value for the frame in which the photo will come, the video will come, or my webcam will come. So it set the mean value for the frame, or the for parameters mean is scalar with the mean values which are subtracted from the channels, you can say. And the last one is set input swap RB. So it set the flag swap RB for the every frame. We don't have to put every time a single frame for a particular image. It will be set the true for the all the images. Okay, so parameters will be swap RB flag, which indicates the swap first and the last channels. So moving forward, we will port one image. Read boy.jpg dot I am show. So this is the size of 320 by 320. Okay, so first thing is you can download this the random picture from the Google. I took from Google itself. So now what we will do, we will set the class index, the confidence value, the B box. B box is the boundary box which I will create for that particular person, cycle, motorbike, and the car. Okay, B equals to model get the confidence threshold. Threshold is used for if my model will confirm it's the particular image which is detecting is correct, it will print the name. Okay, so let me print class index is coming 1 2 3 4. Okay, so 1 means person, 2 means bicycle, 3 means car, and 4 means motorbike. This is the class index for particular label. What I will do, I will print the boxes font scale equals to 3 and the font equals to cv2 dot font Hershey plain for class index and the confidence and the boxes and x dot pattern confidence pattern box, the boundary box. Okay. Then I will write here cv2 dot rectangle to make the rectangle. Set the image and the box is 5, 0, 0. This is the color of the box and this will be the thickness. Okay. Then I will write cv2 dot put text image, then class labels. I will write class index -1 because always index start with 0. That's fine. And the box is 0 and comma boxes 1 body. Okay. Font comma scale so font scale color so this will be the text color 0 comma 255 comma 0 and the thickness so 3. Let me run it. No error. Okay, now plt dot I am show, then cv2 dot cvt color, then comma cvt2 dot color, then bgr to brg. That is why we wrote swap rb equals to true, because every time we will convert bgr to brg, GB, RGB, so we don't have to write again and again. It will convert all the files into RGB. Okay, run it. Okay, as you can see, the motorbike is coming, bicycle is coming, the person is coming, the car will come, the car is coming. Okay, so it's detecting the right for the image. Now we will do this for the video and for the webcam. We are done with this image one, and then now I will write here. Okay, so this is will do for the video. For the video, I will write here cap equals to capture. You can write any name. So cv2 dot video capture. So you can take any random video. I took this Pixels George. You can comment down. Share the link. For app dot is open. So here I will write cap equals to cv2 dot video capture 0, and if not cap dot is open, then raise output error, can't open the video. Can't open the video. Here everything will be the same. Font scale equals to 3. Okay, font equals to cv2 dot font Hershey 10. Okay, so here I will write while true comma frame equals to cap dot read. This is for the reading of the file. The same I will write class index comma confidence comma boundary box equals to model dot detect flame and the confidence threshold equals to 0.55. Okay, everything is the same we did before. So here I will print class index. Okay, so here I will write if and of the class index does not equals to 0, and what to perform is here after that for class index comma confidence comma boxes in zip class index dot flatten is the layers. Okay, confidence dot flatten the box, and if class index is greater than equals to 80, then what to do? Then I will copy from here okay, the same thing I have to write here. So here I will write cv2 dot I am sure this will be the return in the frame object detection by Simplilearn and frame. So if cv2 dot wait key 2 and 0 the ffx equals to ordq. Okay, then here I will write break. Will you break when it gets into 2? The wait key will be 2. Okay, I will tell you what is the wait key. So here I will write cap dot release and cv2 dot destroy all windows. Okay, so now let me run. Let's see error. There will be error. Okay,
CV Python programming language modules. Let me run it again. Are the wait keys. Okay. So video is here. The video is here. As you can see bicycle, the person, the bus, car, traffic light, the person. So our object detection for the video is coming right. Okay, person, okay, person, traffic light, bus. So this is how you can do for the video. Okay. So now we will do for the webcam live. So this is for the video. So if we want to do for the webcam, okay, so we need to just change one thing only. We have to change. Instead of giving the file, we have to write one here. Okay, the rest will be the same. Got it? So I have to just shut down my webcam. So let me shut down the webcam and get back to you. So as you can see, this is the 320 by 320 box. So this is coming right. Okay, so if I will show this, the mobile phone is coming right now. Okay, so this is how you can do the correct object detection. Okay,
Users of Microsoft Excel may format, arrange, and compute data in a spreadsheet. Data analysts and other analysts can make information easier to examine as data is added or altered by organizing data using tools like Excel. The boxes in Excel are referred to as cells and they are arranged in a row and column. The key features of Excel are the spreadsheet document in MS Excel can have headers and footers, and user can protect their data by giving it password protection. And the second one is filtering is supported, allowing you to locate the necessary data in your spreadsheet and replace it with the appropriate value. After discussing what is Excel, let's go through and see what is Python. So, Python is the one of the most popular programming language available today. It is widely used in various sectors of business such as programming, web development, machine learning, and data science. Given its spreadsheet use, it is not surprising that Python has surpassed Java as the top programming language. Python frequently used to create software, website, and to perform data analysis and many more. Because Python is a general purpose language, it may use to develop a wide range of programs and isn't tailored for any particular issues. So the key features of Python are it is open source and free. Python can be downloaded from the company official website. It is simple to download and install. Python is open source because allowing users with solid technical background to modify the code to suit certain business use case and product requirements. Since Python is a language for beginners, most anyone with a understanding of programming can quick pick it up and begin coding. So after seeing what is Python, let's move forward and see what is automating Excel with Python. We all know Python is dominant everywhere, and we also know that compared to other language, Python is beginner friendly and simpler to use. Automation is the one of the coolest thing you can do with Python. So how to automate an Excel sheet in Python? Imagine that you are asked to create accounts for 30,000 employees on a website. What would you think? You will undoubtedly become frustrated carrying out this task manually and repeatedly. Additionally, it will take too much time, which is not the wise choice. So just try to picture that what it is like for employees who work in data entry. Their responsibility is to extract the data from tables like Excel or Google Sheet and insert it in the another location. They read various magazines and websites, get the data there and they enter it into the database. Additionally, they must perform the calculation for the entries. In general, this job performance determines how much money is made. Greater entry volume, more pay. Of course, everyone wants a higher salary in their job. So, however, don't you find doing the same things over and over boring? The question is now, how can I accomplish it quickly? And how to automate my work? Spend an hour in coding and automating these kind of codes to make your life simpler rather than performing these kinds of things by hand. By just writing fewer lines of Python code, you can automate your laborious activity in simpler. So overall, Python Excel automation is a creative method that allows you to build visual reports on Python in a smoother manner, similar to how you would on Excel. Businesses can use Python Excel automation to streamline their operation in accordance with their requirements. So here is one question for you guys. I will give you 1 minute for this. You can comment or you can give answer in chat section so I can see the answers are given by you are correct or not. I'm repeating again. Here is one question for you guys. I will give you 1 minute for this. You can comment or you can give your answer in chat section so I can see if the answers given by you are right or wrong. So the question is, which type of programming does Python support? Object-oriented programming, structured programming, functional programming, and all of the mentioned. So I'm repeating again, which type of programming does Python support? Option A, object-oriented programming. Option B, structured programming, functional programming, and all of the mentioned. So I am starting the timer of 1 minute. Just type your answers in comment section or in chat section. Do let me know your answers, guys. So please, I want that everyone should participate in this. So I'm starting the timer. So your time starts now. So I want that everyone should participate in this, guys. Please do let me know your answer in chat section or in comment section, so I can see if the answers given by you are right or wrong. So 36 seconds or more. Please, guys, I want that everyone should participate in this. So let me know your answers in chat section or comment section. So you can just type the answers or A, B, C, D. Your wish, totally your wish. So 10 seconds are left, guys. Hurry up. Please, I want that everyone should participate in this. 5 seconds more. Okay, so time is over. We will give reply those who gave correct answers, and those who didn't give correct answer, we will give you a reply with the correct answer. Okay, so no worries. So now let's move to our programming part to perform Excel automation using Python. So first we will open command prompt to write command to open Jupyter Notebook. Jupyter Notebook. Yeah. So this is the landing page of Jupyter Notebook, and select open. Select here new, open new file. So this is how the Jupyter Notebook UI looks like. So at first we will import some major libraries of Python which will help us in importing our workbook or worksheet. So the first one is, let me first rename this. We will write automating Excel using Python. Yeah, sounds good. Okay, so the first one is open PyExcel. Open PyExcel. Okay, I have to write import. Yeah, perfect. So a Python package called OpenPyExcel can read and write Excel 2010, XLX format, XLSM format, XLTX, and XLTM files. It was created since there was no library that could read and write Office OpenXML files natively from Python. Since OpenPyExcel was initially based on PHPXL, all praise to the PHPXL team. So OpenPyExcel does not by default provide protection from your quadratic blowup or billion laughter XML assault. Install diffused XML to protect yourself from these assaults. So we will write OpenPyExcel and then yeah. So then we will write for importing our workbook. So we can write here from open py excel import workbook load underscore workbook. Is capital here. So and this is for code for the importing our workbook. So let me write in command like you can import workbook like this. So I can write you can import workbook this. Okay, perfect. Yeah. So here, so let me import workbook then. So I have to write wb for workbook equals to load underscore workbook, the destination of the workbook. So the destination is in like desktop. So I have to write C users LP 09375 stop dash automation dash learn dot cell sx format. Okay, cool. Users SLP this one desktop automation Simplilearn dot xlx. Fine. So our workbook is loaded to Jupyter Notebook. We can see, yeah, perfect, no error. So let's active this workbook for the use. So we have to write ws for worksheet. So worksheet equals to wb dot active. Why active? Like import from OpenAI Excel a workbook, there must be always been one worksheet in a workbook. It is accessible through the workbook.property active. So that's why we have write wb.active. So after making workbook active, so we will print our workbook like we can print. So print ws. So here you can see the sheet 1. So it is showing worksheet sheet 1. Why sheet 1? Because if you open your workbook and see here is your worksheet name, like I can, so this is my automation file. This is Simplilearn. So here you can see the sheet 1. That is why it is showing sheet 1 there. So okay, so let me just finish it. So moving forward, let's change the worksheet name. So I will write here import open pyxl. So like it's your wish that you want to write this import file or like this thing. This is not necessary at all. So now I will import the workbook. So I will write here wb equals to open pyxl dot load underscore workbook open pyxl it is. My bad, sorry guys. So you have to give the path, so I can copy path from here. Yeah, perfect. Okay, sounds good. Here wb underscore sheet equals to wb and square brackets, then you have to write the sheet name. So there we have sheet 1. So sheet 1, okay, correct. So I can change with wb underscore sheet dot title equals to code with Simplilearn. Perfect. Yeah, seems good. Let me save this wd.save and the same copy here, paste. Yeah, so when a sheet is generated, it immediately receives a name. Like they have sequential numbers of names like sheet 1, sheet 2 and so on with the worksheet. You can modify this name whenever you want to, like using the title property. So here let me save this and yeah, no error. So again go to Simplilearn. Yeah, you can see code with Simplilearn. First it was sheet 1 and now it is changed to code with Simplilearn. So let me cut this again. Okay. So if you want to change the color of your sheet name tab where is written code with Simplilearn, so you can write like here you can write wd, or okay, let me make this new one. Okay, right, I will write here. So underscore sheet dot sheet underscore properties tab color equals to, here you have to give hex values, so 4 zeros. Okay, so let me save this. Okay, it is saying sheet 1. Why sheet 1? Because we already changed sheet 1 to code with Simplilearn. So what we have to do is, here we have to write code with Simplilearn. Okay, same Simplilearn, same code. Yeah. So what I will do here, I will just make W capital. So yeah, now it will work fine. Yeah. So if you save or run your code like this, let me show you one thing. Like color is already changed. Wait for 1 minute, guys. I will show you something crazy. So it will see like this W. Okay. So here I will small. So if you save or run your code, not actually save but run your code while your Excel sheet is open. So my Excel sheet is open, code with Simplilearn. Okay. So my Excel sheet is open. So it will give you error. Like which error? I repeat, like what error? This. Okay, let me do one thing. This is 1. Okay. It will give you Simplilearn 1 does not exist. Let me check. This is Simplilearn, code with Simplilearn 1. Code with, okay, W is capital there. Okay, see, this is a permission denied, then the location. It is showing permission denied. So this is something important to remember, that Excel file should be closed while running the code. And repeating again, so like this is something important to remember, that Excel file should be closed while running the code. So first what I have to do is close the Excel file, then I have to run it again. So no error now. So here you can see Code base Simplilearn, that red color came. Yeah, perfect. So moving forward, let's create new workbook. Till we were working on the same worksheet which was present in my desktop. So let's create new workbook. So for that I have to write import Excel SX writer. So I will write here in command to create new workbook. WB equals to Excel SX writer dot workbook, and where you want to save the workbook. So I will give the same path but with different name. So this time I will give only like coders simply. Okay, simply coders. Then I will write WD close. Okay, I will run it. Yeah. So the primary class export by the XLS writer module in the workbook class, and that is only class you will need to instantiate directly. So the workbook class represents both the whole spreadsheet as it appears in the Excel and the Excel file as it is stored on the disk internally. So you can see now, yeah, you can see now the workbook which is created in the desktop with the same name with like simply coders. So this is done. Let's move forward and let's retrieve cell values. So right now we are not having any data inside the workbook. So let's put some random values like names and all. So I will put some random values. We'll put here names. Okay. Here Mayank, Kaushal. Okay. Above. Like Jali. It. Chloe. So let's save it. Let's save it. And let's move to our coding part. So here what I have to write to retrieve cells. Here I just write a equals to a is variable here. So I am assigning is ws that a1 value, the value which is presented at a1. So here I will write in comments like to retrieve cells. Okay. So here I will print a. Okay. What I have to do is like we have created this one file. So it is not giving the this is giving sheet1.a1. Why? Because it is taking from the simply coders one. So what I can do is I can import this file because we have saved data in this file. So let's paste this here and make it active. Yeah. So yeah, you now I haven't write here value. So that is why it is giving the cell name and that A1 name, cell name, A1 only. So now it will print names. Why names? Because at the A1 position we have names. So if you want to like print Anjali, so what you have to do is, okay, let me check this B3. Okay. If you want to print Anjali, you have to just write here, just copy paste this code. Okay, just write here the location B3. You can see Anjali is printed. So this is how you can retrieve cells, and we can do the same for the other cells too. So there is one thing like retrieving, we can change the cells values too. So just we have to write here. So let me give first enter for the better visual. Yeah. So here what we can write is ws, like I want to change the name of uh, I will take this A4 Smith. Okay, let me close this. Okay, I will give here A4 dot value equals to, here you can give the value. So here you can write Smith, you can write John here as a replace value. So I will write here in as a command change cell value. Okay. So what you have to do is just save it, wb dot save. You have to give the path for the same. Yeah. Fine. So let me save this, and let me save this first and run this first. Okay, no error. And let's open our workbooks to see the changes. So here you can see the changes has been implemented in our workbook. First there it was like Smith and now John. So like this you can change the cell values, and let's move forward and see how we can merge the cells in the worksheet. So like just close this, and yeah. So we are doing for the merging cells. So here I will write from open pyxl dot styles import alignment. So here I will write merge cells for your better understanding. Okay. So here I have to write wb equals to workbook Okay, let me active this workbook. wb dot active merge the cell. Which one? Let's take for a while A1 and B2. Okay, A and B should be in capital letters. So after that we have to save this. We will save in this only. So I can copy, I can paste it here. Okay, fine. Like using merge underscore cells, and after giving cell position you can easily merge the cell. So let's see the output. So let me open this Simplilearn file. You can see they are merged together, and like, but what if you want the values at the same times? So you can write here, I have to cut this. So you can write here like from open pyxl dot styles import alignment. A should be capital, alignment. Okay, so the same thing you have to write WDB equals to workbook WS equals to WB dot active don't have to give parenthesis WS dot merge underscore cells A1 B2. So here I have to give the cell value equals to WS dot cell which row which column. So I can write row equals to 1, column equals to 1. So cell dot value equals to, here you can give the value which you want to print at the cell. So here I will write code with Simplilearn. Okay, fine. So what we can do this, we can give the alignment. Alignment equals to alignment horizontal equals to center, and from vertical the same. Center. Okay, let me save this file wb.save at the same location. So I can copy the path from here. Copy here and paste here. So I will. Yeah, seems good. Let me save this. Why it is giving error? Cell object has no attribute alignment. Okay, alignment spelling is wrong. Sorry, my bad. GNMENT. It seems good now. Oh, good to go. So here you can see, like by giving row equals to 1, column equals to 1, basically position, and after giving the value to what to print on that cell, and one more thing is alignment. Like it is not necessary to give alignments, like I just wrote it to cover it like in video. So you can give alignments like right, left. This time I gave the center to print in the center. So let's move and see the results. So you can see the value has been printed exactly at the center of the cell. Well, I will make it like this. You can see the value is printed exactly at the center of the cell because I gave the alignment center. So let's do one more for like to see what is the default place if we don't give the alignments. Okay, if you don't give the center alignments, what is the default value? So let me first remove this. Okay, save, no issues. Okay, yeah. So with alignments, or here what we can do is like from OpenAI Excel dot styles import alignment. It is not necessary to write import alignments. Okay, this is without. Okay, I can write is default value. Seems good. Okay, everything we have to cover from here, so I can just copy from here and paste it here. So what we will do here, we will change the cell value. We will use like C6 and B8. Sorry guys. So here I have to give row equals to 6 and column must be 8. So let's make it B6 B6. Okay, let's column should be 6. So code with Simplilearn, coders of Simplilearn. Coders of Simplilearn, like we are giving the value. So at the same time we have to just save it, wb.save, save. Copy, paste here. Okay. So this time we are not giving the alignments. You can see here we have gave alignments, not now. So let's run this and after that we will open our workbook. So this is saying merge cells. Okay, 2 must be greater than 3. Okay, so here what is happening? Okay, I can write here D6, right? So now it will run properly, I guess. Yeah, it's working. So let me open this. So you can see this is the default value of like it. So here you can see the value is printed at its default location, not in centered or not in right, not in left. It is default location. So till now we know how to merge cell. So I repeat, I hope you guys understand till here. If you have any questions or any query regarding any code or question, just put as in comments. Our team will shortly provide you the correct solution. So moving forward, till now we know how to merge cells. So let's learn how to unmerge cell. Okay. So let me open the code. Yeah. Let me open the code and write for you. So let me quickly write the code how we can merge cells. So we can write open, okay, from open py excel dot styles. So just I can copy paste from here. I have to write here import alignments. Okay, alignment only. So what we are doing here, though we will not give any value or any this. So here I will remove like B6 6. Actually we can give like A6 B6 as a value. So let's see the cells are merged or not by running it. Okay, see permission denied because our Excel was open. So let me save this and close it and run it again. No error. So here you can see, let me zoom if I can. Yeah. So here you can see A6 and B6 are merged. So what should I do to unmerge? I have to write, yes, you can write here like here you can write ws dot unmerge underscore cells. Okay, cells, got it, and just give this same value a6 underscore b6. Okay, colon b6. Let me save this again. No error. Let me open the file. So you can see here a6 and b6 now unmerged. So by just using unmerged cells, you can easily unmerge the cells in your workbook. So let's move forward and see how can you set dimensions for a particular cell or column. So let me close this and go to the workbook again. This is something frustrating by regularly doing the same thing, going next. Oof. So like you need a particular column height should be something and width should be something. So that is what I'm like meant to be dimensions. So let's write code for it. You will see and understand by seeing. So import openpy excel hashtag to set dimensions of a particular cell. Okay, wb equals to open py excel dot workbook worksheet equals to workbook dot active ws dot row underscore dimensions. Okay, one. I will explain you. Don't worry. Height equals to let me give 70 for a while. Okay, ws dot column underscore dimension width. I will explain you. Don't worry. 8. So let me save the file wb dot save and let me copy the path from here. Okay, everything seems good. Okay, y column. Okay, column name is like function no column dimension. Okay, dimensions. No error. So like 1 height 70 and b width is 8. Column 1, let me open the workbook. So here you can see by giving row dimension and column dimension and by adding height and width them, we can set the dimension for a particular cell. Y1 and B for this you can see here 1 for the column, like 2 for the column, 3 for the column. Let me zoom it. You can see now 1 for the all the 1 column row, 2 for the 2 row, 3 for the 3 row, like this. For you can say I use 1 for the particular row, or you can say 1 for denoting row, particular row, 1 2 3 4 5 6 like this. ठीक है? I repeat, and particular alphabet to denote the column. See, A for this column, B for this column, C for this column, D for this column, like this. Okay. So here you can see every cell of row 1 has the same height. This, and every cell of it, and every cell of column B has same width. So like we can do one more thing. We can print value though in a particular cells. Like, okay, let me close this and open this one. So what can I do is I can write here, like we can write at wd cell row equals to 1 comma column equals to 1. Okay, dot value equals to hello. Okay, and ws dot cell, here I will write row equals to 2 comma column equals to 2 dot value equals to coders. So I have to write it here, not below this. Yeah. Okay, cool. Let me give this space line. Okay, so let me save this and let me check. So here you can see hello is for the row 1 and coder at the column B. Okay, fine. So let me close this and okay. Next, I repeat, next, let's see how we can move data to a particular row or column, or you can say a particular cell. Here we need data to make it move. So let's fill some random data on it. So what I can do is I can put some random data of like fruit, vegetables, and some names like Mayank, Anjali, Ubhav, Kaushal, Kahana, and we can give like anything Smith, John, and Chloe, Sarah, and I Sachin. Okay, I think this much is enough. So let me save this, and yeah. So data part is done, and let's move to the this one and write import open pyxl. Okay. So let me write here move cell. You can say move or jump, whatever you want to say. So from open pyxl import workbook comma load underscore workbook will be equals to load can give the path like this, yeah, C and V. Okay, let's make it active. WS equals to WB dot active of X seems good. Okay, so I have to move WS dot move score range. This is I can give. Okay, let me see the data first. Okay, I will make Anubhav here and Mayank here or here. Okay, so let's see again. I forgot. It is B5 and A4. B5 A4. Okay. So what we can do it like O B5 comma like row equals to 2 and call B rows equals to 2 and calls equals to 2. So let me save this w.save and so here what I am doing is changing the position of the value which is present in the location A4 and B5. So and moving them by, you can say the value will jump by 2 rows and 2 columns because I gave here 2 rows equals to 12, columns equals to 2. So let me save this, run this. Okay, and so here you can see. So let me run this, and what you have to do is open this file. Yeah, so you can see A2 means 1, 2. It comes, fruit comes here, and coders come here. So this is how you can move your coding part. I repeat. So this is how you can move the cell values. So let's move forward. And so moving forward, let's see how we can insert a row in a workbook. Okay. So first, what I will do is I will add some data like name here, like fruits, and something like car, and here I can write bike, scooter. Okay, something here coding. Okay, all the data is filled, and all rows are filled by some values. So here we have no empty row present here till now. So what we will do is we will insert a row. Okay, so what we have to write is import open py excel hashtag insert rows. Okay, from open p excel import workbook comma load underscore workbook. To load let me copy the path. See. Okay. So let me make it active. So I want to insert row the position 2 and one more row at the position 5. So let me save this. I will copy from here. Okay, I will make it like this. So let me save this. No error. Let's move to the workbook. So you can see here row 2 is created and row 5 is created with no values. So here you can see rows are added to the particular position, or you can say the indexes. So we have seen how we can insert the rows. Let's see the deletion of the rows. So what we can write is, let me open the code. So what we can write is, let me copy to save our time. Okay, just delete this. So we can write ws dot delete underscore rows, and which row? 2 5. I will delete row number 2 for a while. So let me save this and run this. So now you can see empty row 2 is deleted. So by using insert rows and giving them index, you can insert the row at the index position you gave, and meanwhile you can use delete underscore rows function to delete the particular row. So moving forward, let's quickly write code for the insert column. So for inserting column, I will copy from here. Yeah, insert row column, and this one is for deleting row. Okay, so I have to write here ws dot active, not active, sorry, insert calls at the position second. Okay, at the position 1, and okay, I will make it insert calls at the position 3. Okay, let me save this file by copying this path. Okay, saving. Let me do one thing. Yeah, perfect. So let me open the workbook. So here what I've done is insert call at second position. Here we can't give alphabet, we have to give a number for denoting a position. So here you can see the column is added at the position 1 and 3. So by using insert underscore calls and by giving index, you can insert column in your workbook. So let's do one thing, guys. Okay, first let me close this, and yeah. So what I was saying that let's do one thing, guys. You will tell me how can I delete a particular column. Okay, let me write here the question. Comments like how can you delete a particular column. Okay, I'm giving you 1 minute for this. Just comment the code for this column deletion, or else you can reply on chat. I will suggest you to write a comment because after this session, our team can easily check who gave the correct answer and who didn't give the correct answer. Don't worry, I will provide you the answers at the end of the session, or our team will reply at your comment at the same time. So like for those who are watching this video, like we watch normal video, means you are not watching the live session. So what you can do is just pause the video right now and put the comment how you can delete the column. I'm repeating again, I will suggest you to write a comment because after this session, our team can easily check who gave the correct answer and who didn't give the correct answer. Don't worry, I will provide you the answer at the same time, or our team will reply at your comment at the same time. And those who are watching the video like we watch normal video, so that you can do is just you can pause this video and put the comment how you can delete the column. So I guess time is up, guys. I hope most of you gave the correct answers by putting comments. We will verify your comments and we will back to you soon. So okay, moving forward, let's see how we can style the font in Excel. Okay, this is something crazy and interesting, so you will not get bored. And writing from open py excel dot styles import font. So here I will write for your styling. Okay, so what I can do is like wb equals to open py excel dot workbook ws dot equals to wb dot active. I will, don't worry, I will explain you. Row equals to 1 comma column equals to 1 equals to learn. Okay, and I will set the size of the cell. So ws equals to cell row equals to 1 comma column equals to 1 dot value. Okay, here I have to write font equals to font equals to font, and here I have to write size equals to 24. Okay, here I have to give dot value. Okay, now we can do it for the many others. What we will do it is we will change hello, not world again. We will write coder, hello coders, and here we will write code with simply learn, and here we will write hello YouTube. Okay, so what I will do is like it will 2 column 2 row 2 here. Here what I will do is font size equals to 24, and I will make it italic equals to true. Okay, fine, and I will make it bold. Bold equals to true, and here I will give 3 3 3. Okay, and at the end what I can do is okay by times new one. So let me save it quickly. wb dot save with a path. So let's run this and see the result. So let's run this again one more time. So here what I did is just gave the particular row and column value where we want to print the value, like Simplilearn, hello coders, hello YouTube, code with Simplilearn. Okay, and by using font I am giving the font size and font like italic, bold, and so on. Like this is italic, this is bold. Okay, and here you can see at the end by using name, here you can see at the end by using name we are assigning the styles of the particular text like Times New Roman, and you can give the name of your choice. So why it is not, because I have gave the it is collapsing. So here I have write 444. Okay, now it is collapsing now. Hello YouTube and Simplilearn. So what I will do is now I will run. Now you can see, yeah, perfect. So this is simple one, this is in italic, this is in bold, and this hello YouTube is in Times New Roman style. Okay, so okay, let's move forward and do something with cells. Like what we can do it, let's do color them. Okay, let's write code for this, how we can like color a particular cell. We know how to color the particular tab of sheet, and now let's color it. So we can write is import OpenPy Excel. Here I will write coloring particular cell. Okay. So I will first copy this thing here from here. Okay, I don't think I want this. I have to write from open py excel styles port pattern fill. I want something like this. Okay, so wd dot open py excel workbook. So here I can write open py excel dot load workbook. Okay, workbook, and here I will give the path. Yeah, it seems good. So what I will do is make it active, and I can write here ws equals to wb square brackets. Then I can write name of working sheet. I don't remember. Only sheet. So we can write here fill underscore cell equals to pattern fill patt pattern type should be, I will prefer solid. Okay, and comma my hand, comma fg color foreground color equals to, I will write here f c 2 c 03. Okay, fine. We can make four cells are enough, I guess. So we can write here cell 1, paste, copy paste. So we'll 4 3 2 solid, yeah. So let's change color. We can give 0 3 fc f4. Here I will give 3 5 fc 03. Perfect. Here I can give fc a03. So now let me assign the cells to them. ws like I can assign a1, assign a2 dot fill equals to fill underscore cell. Okay, fill underscore cell 1. That seems good. This I can make it for 4 v. A2 A4 A5 A3. Everything seems good. Let me save this. So I will copy from here. Why error permission denied? Because it was open. So let me cut this. So let me see. So here I'm using the pattern field to fill the color in solid style and giving the FG color like foreground color. And at the below you can see I'm like assigning the cells to a particular pattern fill cells. So let's see the output. Yeah, it's working. Here you can see the results. We colored these for the particular cell like A2, A3, A4, A5. So this is something you can style the color. So let's move forward and see how we can import the image in our workbook, like something here, something here, something here. Let's see. So let me first cut this. Okay, let me do one more thing. Yeah, perfect. Coloring particular cell. So how we can import our file or image, you can say. So I will write from OpenPyXL port load underscore workbook. Okay, load underscore workbook, and I have to write here from OpenPyXL dot drawing dot image import image. Okay, fine. Workbook, write wd equals to load underscore workbook and give, let me copy this and this whole. So logo is for variable used for the image. Okay, so I don't have any image for right now. Let me do one thing. Let me import one image, any kind of image for a while. So I can do like, so this is my image. What can I do is I can give the path like path would be same. We will change here something. Don't worry. Desktop. Don't remember name of the file. This is picture 2. Okay. P is small or capital? P is capital. So I have to write picture 2.png. Okay. So I will give logo dot height equals to 150, logo dot width equals to 150. A bit of resizing to not fill the whole spreadsheet with the logo, so that's why just for that. So ws dot add image to logo comma cell, in which cell you want to print. I will M2. Fine. So here we will save it by using this one. Okay, perfect. Cannot import name image from Opal file during this one. So might be there is problem. Open PyXL dot drawing dot image. Okay, import image. I think I is capital here. Seems logo image. Okay, I is capital here. Yeah, it seems good. Yeah, here is the picture. So what can I do is, so here we need one more library drawing image, variable logo. This one is for the location of the image and giving and height and width, because a bit of resizing to not fill the whole spreadsheet with the logo, like with the whole spreadsheet with the logo. So just a bit of resizing. And add image function is used to append image on it, and m2 is for like this. M2 is for position, m2, like that. It's for in which cell you want to append it. So image is coming to the particular index m2. Okay, so this is how you can import image in Excel using Python. Okay, let's move forward and see how we can import date and time. So let's write code for that quickly. Okay, so what I will do is I will write here import date time. I will write date time from OpenPy Excel import workbook import time. So what can I do is make it WP equals to workbook. Okay, blue should be capital here and WS equals to WP dot active. So what can I write is WS dot cell row 1 comma column equals to 1 dot value equals to date and time. It's something. So I can write, copy it, paste it. What I can do is, let me first change the 3 row equals to 3. Okay, column equals to 2, I guess, value. So here I can assign date and time. Date time dot date time dot now dot string format strf time. So what you have to write it, %y, %m for month, %d for days, %h, then %m for minutes, and % seconds. So that should be in between this. Okay, yeah, perfect. So let me save this. close it. Import data time, not date time. It's date time. Okay, row equals to 1. Data time, not date time. Again, date time dot now. Date time dot date time. Date time. So date time objects has no attribute strf time. Okay, time it is, yeah. Okay. Yeah. Finally it's working, no errors. So here okay. So here I have imported some libraries like date time and so on. strf time used for string formatter and date time now used for the current date time. This date time now is used for the current date time. And so let's run this and see. So here you can see the correct time and date is coming. It can be different from which country you are watching this live session. So what if you want to print the time after like 2 seconds late? So for that we can write here quickly. So I will copy this whole. So like we have to copy this and just what you have to do is let me make for to see the difference. V okay, 3 are enough. So what I will do is 4 5. Okay, fine. What I will add here is time dot sleep. How much second you want? Like 2 for this one and something for this one, like 5 seconds for this one. Okay. So what we can do is let's save it and let's see the results. So here I've used the time.sleep function given parameter as 2 or 4, I guess 5, for printing the seconds difference. So here you can see the difference in seconds. Okay, the time is not coming. Wait, let me check. Okay, why permission denied? Sorry guys. Now I have to run it. Open it. And it is not coming. Why so? Permission denied. Okay. Let me run it again. Okay, because I am giving seconds difference, that is why it's giving permission denied. So let us wait for 5 seconds. Okay, I think 5 seconds are over. Now we can open it. Yeah, you can see 47 seconds and 49, 2 second difference, and 49, 54, 5 second difference. So here I've used the time sleep function given parameter as 25 for printing the second difference. So let's move to the workbook. I repeat, here you can see the difference in seconds. So I hope you understand till here. If you have any questions or any query regarding any code or question, just put as in comment. Our team will shortly provide you the correct solution. I'm repeating again. I hope you understand till here. If you have any questions or any doubt or any query regarding any code or whatever it is, so just put as in comments or our team will shortly provide you the correct solution. So moving forward, let's see how we can add values as an array. Okay. So what I will write, import xlsx writer WB equals to XLSX writer dot workbook. Okay, I will give the path from here. Okay, WS equals to WB dot add worksheet. W should not be capital here. Okay, so what I will do is row equals to 0 and column equals to 0. Okay, so I will write here data equals to, and take is the names, just names. Okay. Just random names they are. Above, let's take one more. Kisle. So for item and data, okay, WS dot write. I will explain you line by line. Don't worry. Row, comma, column, comma, item. Perfect. So here what I will do is row plus equals to 1, or you can write row equals to row plus 1 WB dot close. Okay, let's save this. Let's see our data is appended or not. Okay, first I will explain this code to you. So here I have created one new workbook, name. No, I haven't created. So let me create two. Okay, example. Okay, so I'll run this. Yeah, perfect. So here I repeat. So here I have created one new workbook name example. So at row 0, column 0, I am printing my content values, like for data values. Using for loop, I am moving to the next iteration of the values, like from Anju to Koshu and then Mayank, then so on. So let's see the results. Okay. Yeah. So here you can see all the values are printed. So using these codes of line, you can do things like this easily. So as we know how to write multiple values at the same time, what if we want to retrieve values of a particular row or column? So for that we need data for that. So let me add the full data of let me copy some data from somewhere. So just give me a minute. Okay. It's the blank worksheet. Let me give me 1 minute, guys. Okay, what I will take is this one. I can take this, some values we can copy, like 50 values. Okay, 50 is I know. See, yeah. Okay, we have data now. Simply learn. You have data in the Simplilearn. Okay. Now we can write code for that, like how to retrieve multiple column. So the same I want. See. Let's do wb dot active. Okay. ws equals to wb spreadsheet column in worksheet A. Okay. So what I have to do is just print column values. Column dot value. I hope it will work. wb dot active workbook object has no attribute active. Okay, let me see. Okay, sorry. Import open py-excel. XLS writer is used for to create new workbook. Okay, open py-excel dot load underscore workbook. Now it will work, I guess. Still it is not working. Load. It should work, I guess. Open py-excel. Open py-excel dot load. Okay, sorry, my bad. Here dot. Now it will work. Okay, sheet. It's too much. This is sheet 1. You never know when the sheet will create sheet 1. Yeah, you can see all the list of column A is printed here, all the 50 values, and you can match from here to all the 50's values. Okay, till Travis Scott. So let me match this till Travis Scott. Okay, so I hope you understand till here. If you have any questions or any query regarding any code, so just put as in comment or our team will shortly provide you the correct solution. After doing importing, exporting the values and all, let's perform some basic operation like addition, average and all. Okay. So first we will start with the addition. So I will write here. So we need data in workbook for the addition. So let's take some data from which set? The same Insta data set. So I will take this 50 values are enough. Okay, copy it and let me paste here. So data we have, let's code for it. We have to write here import open py-excel. We are doing sum of columns, not column values. Yeah, like from open py-excel import workbook comma load underscore workbook. So WB equals to load underscore not workbook copy the path. Okay, so I will make it active. So here what I'm doing is, I will tell you shortly. So it is in C, I guess. C or B? Which column? Or B? So B 51, I guess. Yeah, B 51. B should be capital, equals to, see carefully what I'm doing, like sum from B1 1 till B, I guess 50 values we have. 50. Okay, B should be capital. My bad. Sorry. Okay, this is what I'm doing. And wd dot save. Where is the save one? Okay. So here I have added all the values which are between in the range of B1 to B50. And what I'm doing is the result will be displayed on the B51th cell. Okay, so let's run this code. Okay, let's go to the B51. Yeah, result is coming. For verifying the result is correct or not, I won't use calculator for this. So we can use this code for the same for average, product and count. So let's do it quickly. Okay, so let me just copy paste this stuff. CV, this is will be for average. A spelling mistake, average. Okay, what I will do is just write capital average here. Okay, and I will print it to 52. Okay, code is almost same, just one change. Like you have to write, instead of sum, you have to write average there. And just, okay, let's see then. So now you can see this is the 137 point something 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 is the average of these all values. Everything look good. Let's see the count quickly. Let's we code is almost same, just we have to, okay, capital 53. Visible? Okay. This count will give you how many values are there between the range till 1 to 50. So let's check, let's run it again and check if it's working or not. Yeah, 49 values. Okay. So what I'm planning is, let's do one thing now, guys. You will tell me how I can find the product of a particular range. I'm writing question as a command as I did before. So how to, okay, how to find product of numbers, like where the range is between a a2 to a98. Okay, so I'm giving you 1 minute for this. Just comment the code for this multiplication, or else you can reply on chat. You can write just syntax only for the product. I will suggest you to write a comment, because after this session our team can easily check who gave the correct answer and who didn't give the correct answer. Don't worry, I will provide the answers at the end of the session, or our team will reply at your comment at the same time. And those who are watching the video like we watch normal video, or you are not attending the live session, so you can just pause this video and comment on how we can find the product in Excel using Python. I'm repeating again, I will suggest you to write a comment, because after this session our team can easily check who gave the correct answer and who didn't give the correct answer. Don't worry, I will provide you the answers at the end of this session, or our team will reply at your comment at the same time. Those who are watching this video like we used to watch normal videos, so what you can do is just pause this video and comment on how we can find the product in Excel using Python. So I guess time is up, guys. I hope most of you gave the correct answer by putting comments. We will verify your comments and we will back to you soon. So moving at the last of the session, let's do something with charts. So what I will do is, first I will move it bit up. Yeah. So let me write code for that, for the chart. So I will write from open py excel import workbook from open py excel dot chart import reference comma line chart. Okay, we will create line chart. WB equals to workbook, WS equals to workbook dot active. So after this I will set the chart title equals to chart. Okay, let me create the rows. So rows equals to I will do is I will create something like weeks, okay, comma sale, comma veggie sale. Yes, comma not here, comma, and I have to give the values. Weeks are Monday. Okay, let me give the same. Food sale should be like 100, comma 200. Tuesday, comma 200, comma 300. Wednesday, 300, comma 400. For the Thursday, comma 400 30 day 20 comma Saturday. Comma 30. Okay, it seems good. Let me do like for rows. Okay, row in rows. ठीक है. ws dot append row values equals to reference ws comma min call equals to 2 comma min row equals to 1 comma max column equals to 3 comma max underscore row equals to 7. Okay, it seems good. Okay, x dot values equals to reference underscore string equals to chart A2 A7. So chart equals to line chart we are making. So let's add the data to line chart object. Chart dot add underscore data values comma titles 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 underscore from underscore data equals to true. Okay, it should be capital. So let's set x-axis chart dot set categories x underscore values okay, let's set chart dot equals to sales chart dot axis equals to weeks and chart dot y axis dot title equals to fruit and veggies sales. Chart dot legend dot position equals to b. Okay, so ws dot add underscore chart comma h1 cell. So wb, okay, let me copy this code from here Yeah. So here I am importing reference and charts library like this, reference and charts library, and just giving title as charts. You can say here chart. So rows are the data from which we will make chart, and for loop is to append the data on the workbook. Chart add data, chart add data, values titles from data equals to true. This is for adding data to the line chart object, just giving the title x-axis and y-axis and all. So let's save this and see whether chart is visible or not. Let's save this. Okay, what is it going? Cannot import name reference from open file reference. Okay, let me see. Error in line 2. Error in line 2. Okay, sorry, my bad. Okay, now it will. Workbook, fourth number. Workbook. Okay, W should be capital. W should be capital. Now it will work, I guess. Again, that's reference. Okay. X dot values. Chart. My bad. HART. CHART. Dot save. Okay, WB dot save. Okay, finally no error. So let's save this and see whether chart is visible or not. Let me go to the Simplilearn. Yeah, you can see chart is coming and it looks so good.
If you are an aspiring AI ML engineer, then there is no better time to train yourself in an exciting field of machine learning. If you are looking for a course that covers everything from fundamentals to advanced techniques like machine learning algorithm development and unsupervised learning, look no further than our Caltech in partnership with IBM. So why wait? Join now. Seats are filling fast. Find the course link from the description box below.
Hello everyone, welcome to this session. I'm Mohan from Simplilearn, and today we'll talk about interview questions for machine learning. Now, this video will probably help you when you're attending interviews for machine learning positions, and the attempt here is to probably consolidate 30 most commonly asked questions and to help you in answering these questions. We tried our best to give you the best possible answers, but of course what is more important here is, rather than the theoretical knowledge, you need to kind of add to the answers or supplement your answers with your own experience. So the responses that we put here are a bit more generic in nature, so that if there are some concepts that you are not clear, this video will help you in kind of getting those concepts cleared up as well. But what is more important is that you need to supplement these responses with your own practical experience. Okay, so with that, let's get started. So one of the first questions that you may face is, what are the different types of machine learning? Now, what is the best way to respond to this? There are three types of machine learning. If you read any material, you will always be told there are three types of machine learning. But what is important is you would probably be better off emphasizing that there are actually two main types of machine learning, which is supervised and unsupervised. And then there is a third type, which is reinforcement learning. So supervised learning is where you have some historical data and then you feed that data to your model to learn. Now, you need to be aware of a keyword that they will be looking for, which is labeled data. Right? So if you just say past data or historical data, the impact may not be so much. You need to emphasize on labeled data. So what is labeled data? Basically, let's say if you're trying to train your model for classification, you need to be aware of for your existing data which class each of the observations belong to, right? So that is what is labeling. So it is nothing but a fancy name, you must be already aware, but just make it a point to throw in that keyword labeled, so that will have the right impact. Okay, so that is what is supervised learning. When you have existing labeled data which you then use to train your model, that is known as supervised learning. And unsupervised learning is when you don't have this labeled data. So you have data, it is not labeled. So the system has to figure out a way to do some analysis on this. Okay, so that is unsupervised learning. And you can then add a few things like what are the ways of performing supervised learning and unsupervised learning, or what are some of the techniques. So supervised learning, we perform or we do regression and classification, and unsupervised learning we do clustering. Okay? And clustering can be of different types. Similarly, regression can be of different types, but you don't have to probably elaborate so much. If they are asking for just the different types, you can just mention these and just at a very high level you can. But if they want you to elaborate, give examples, then of course I think there is a different question for that. We will see that later. Then the third, so we have supervised, then we have unsupervised, and then reinforcement. You need to provide a little bit of information around that as well, because it is sometimes a little difficult to come up with a good definition for reinforcement learning. So you may have to a little bit elaborate on how reinforcement learning works. Right? So reinforcement learning works in such a way that it basically has two parts to it. One is the agent and the environment. And the agent basically is working inside of this environment, and it is given a target that it has to achieve. And every time it is moving in the direction of the target, so the agent basically has to take some action. And every time it takes an action which is moving the agent towards the target, right, towards a goal. A target is nothing but a goal. Okay, then it is rewarded, and every time it is going in a direction where it is away from the goal, then it is punished. So that is the way you can a little bit explain. And this is used primarily, or very, very impactful for teaching the system to learn games and so on. Examples of this are basically used in AlphaGo. You can throw that as an example where AlphaGo used reinforcement learning to actually learn to play the game of Go, and finally it defeated the Go world champion. Right? This much of information that would be good enough. Okay. Then there could be a question on overfitting. So the question could be, what is overfitting and how can you avoid it? So what is overfitting? So let's first try to understand the concept, because sometimes overfitting may be a little difficult to understand. Overfitting is a situation where the model has kind of memorized the data. So this is an equivalent of memorizing the data. So we can draw an analogy so that it becomes easy to explain this. Now let's say you're teaching a child about recognizing some fruits or something like that. Okay, and you're teaching this child about recognizing, let's say, 3 fruits: apples, oranges, and pineapples. Okay, so this is a small child, and for the first time you're teaching the child to recognize fruits. Then, so what will happen? So this is very much like that is your training data set. So what you will do is you will take a basket of fruits which consists of apples, oranges, and pineapples. Okay, and you take this basket to this child, and there may be, let's say, hundreds of these fruits. So you take this basket to this child and keep showing each of this fruit, and then first time obviously the child will not know what it is. So you show an apple and you say, hey, this is apple. Then you show maybe an orange and say this is orange, and so on and so forth. And then again you keep repeating that, right? So till that basket is over. This is basically how training works. In machine learning also, that's how training works. So till the basket is completed, maybe 100 fruits, you keep showing this child. And in the process, what has happened, the child has pretty much memorized these. So even before you finish that basket, right, by the time you are halfway through, the child has learnt about recognizing the apple, orange, and pineapple. Now what will happen after halfway through? Initially you remember it made mistakes in recognizing, but halfway through now it has learned. So every time you show a fruit, it will exactly 100% accurately, it will identify. It will say, the child will say this is an apple, this is an orange, and if you show a pineapple, it will say this is a pineapple. Right? So that means it has kind of memorized this data. Now let's say you bring another basket of fruits, and it will have a mix of maybe apples, which were already there in the previous set, but it will also have, in addition to apple, it will probably have a banana or maybe another fruit like a jackfruit. Right? So this is an equivalent of your test data set, which the child has not seen before. Some parts of it probably has seen, like the apples it has seen, but this banana and jackfruit it has not seen. So then what will happen? In the first round, which is an equivalent of your training data set, towards the end, it has 100% it was telling you what the fruits are. Right? Apple was accurately recognized, orange was accurately recognized, and pineapples were accurately recognized. Right? So that is like 100% accuracy. But now when you get a fresh set which were not a part of the original one, what will happen? All the apples maybe it will be able to recognize correctly, but all the others like the jackfruit or the banana will not be recognized by the child. Right? So this is an analogy, this is an equivalent of overfitting. So what has happened during the training process, it is able to recognize or reach 100% accuracy, maybe very high accuracy. Okay, and we call that as very low loss. Right? So that is the technical term. So the loss is pretty much 0 and accuracy is pretty much 100%. Whereas when you use testing, there will be a huge error, which means the loss will be pretty high and therefore the accuracy will be also low. Okay, this is known as overfitting. This is basically a process where training is done. Training process it goes very well, almost reaching 100% accuracy, but while testing, it really drops down. Now, how can you avoid it? So that is the extension of this question. There are multiple ways of avoiding overfitting. There are techniques like what you call regularization. That is the most common technique that is used for avoiding overfitting. And within regularization, there can be a few other subtypes like dropout in case of neural networks and a few other examples. But I think if you give example or if you give regularization as the technique, probably that should be sufficient. So there will be some questions where the interviewer will try to test your fundamentals and your knowledge and depth of knowledge and so on and so forth. And then there will be some questions which are more like trick questions that will be more to stump you. Okay, then the next question is around the methodology. So when we are performing machine learning training, we split the data into training and test, right? So this question is around that. So the question is, what is training set and test set in machine learning model, and how is the split done? So the question can be like that. So in machine learning, when we are trying to train the model, so we have a 3-step process. We train the model and then we test the model, and then once we are satisfied with the test, only then we deploy the model. So what happens in the train and test is that you remember the labeled data. So let's say you have 1,000 records with labeling information. Now, one way of doing it is you use all the 1,000 records for training, and then maybe, right, which means that you have exposed all these 1,000 records during the training process, and then you take a small set of the same data and then you say, okay, I will test it with this. Okay, and then you probably, what will happen, you may get some good results. Right? But there is a flaw there. What is the flaw? This is very similar to human beings. It is like you are showing this model the entire data as a part of training. Okay, so obviously it has become familiar with the entire data. So when you're taking a part of that again and you're saying that I want to test it, obviously you will get good results. So that is not a very accurate way of testing. So that is the reason what we do is we have the label data of this 1,000 records or whatever. We set aside, before starting the training process, we set aside a portion of that data and we call that test set, and the remaining we call as training set, and we use only this for training our model. Now, the training process, remember, is not just about passing one round of this data set. So let's say now your training set has 800 records. It is not just one time you pass this 800 records. What you normally do is you actually, as a part of the training, you may pass this data through the model multiple times. So this 1,000 records may go through the model maybe 10, 15, 20 times till the training is perfect, till the accuracy is high, till the errors are minimized. Okay, now, so which is fine, which means that that is what is known as the model has seen your data and gets familiar with your data. And now when you bring your test data, what will happen is this is like some new data, because that is where the real test is. Now you have trained the model and now you are testing the model with some data which is kind of new. That is like a situation, like a realistic situation, because when the model is deployed, that is what will happen. It will receive some new data, not the data that it has already seen, right? So this is a realistic test. So you put some new data. So this data which you have set aside is for the model, it is new. And if it is able to accurately predict the values, that means your training has worked. Okay, the model got trained properly. But let's say while you're testing this with this test data, you're getting a lot of errors. That means you need to probably either change your model or retrain with more data and things like that. Now, coming back to the question of how do you split this, what should be the ratio? There is no fixed number. Again, this is like individual preferences. Some people split it into 50-50, 50% test and 50% training. Some people prefer to have a larger amount for training and a smaller amount for test. So they can go by either 60-40 or 70-30, or some people even go with some odd numbers like 65-35 or 63.33 and 33, which is like 1/3 and 2/3. So there is no fixed rule that it has to be something, the ratio has to be this. You can go by your individual preferences. All right, then you may have questions around data handling, data manipulation, or what do you call data management or preparation. So these are all some questions around that area. There is again no one answer, one single good answer to this. It really varies from situation to situation, and depending on what exactly is the problem, what kind of data it is, how critical it is, what kind of data is missing, and what is the type of corruption. So there are a whole lot of things. This is a very generic question, and therefore you need to be a little careful about responding to this as well. So probably have to illustrate this again. If you have experience in doing this kind of work in handling data, you can illustrate with examples saying that I was on one project where I received this kind of data. These were the columns where data was not filled, or these were this many rows where the data was missing. That would be, in fact, a perfect way to respond to this question. But if you don't have that, obviously, you have to provide some good answer. I think it really depends on what exactly the situation is. And there are multiple ways of handling the missing data or corrupt data. Now, let's take a few examples. Now, let's say you have data where some values in some of the columns are missing, and you have pretty much half of your data having these missing values in terms of number of rows. Okay, that could be one situation. Another situation could be that you have records or data missing, but when you do some initial calculation, how many records are corrupt or how many rows or observations, as we call it, has this missing data. Let's assume it is very minimal, like 10%. Okay. Now, between these two cases, how do we? So let's assume that this is not a mission critical situation, and in order to fix this 10% of the data, the effort that is required is much higher, and obviously effort means also time and money, right? So it is not so mission critical, and it is okay to, let's say, get rid of these records. So obviously one of the easiest ways of handling the data part or missing data is remove those records or remove those observations from your analysis. So that is the easiest way to do. But then the downside is, as I said, as in the first case, if let's say 50% of your data is like that, because some column or the other is missing. So it is not like in every place, in every row, the same column is missing, but you have in maybe 10% of the records, column 1 is missing, and another 10% column 2 is missing, another 10% column 3 is missing, and so on and so forth. So it adds up to maybe half of your data set. So you cannot completely remove half of your data set, then the whole purpose is lost. Okay, so then how do you handle? Then you need to come up with ways of filling up this data with some meaningful value, right? That is one way of handling. So when we say meaningful value, what is that meaningful value? Let's say for a particular column, you might want to take a mean value for that column and fill wherever the data is missing, fill up with that mean value, so that when you're doing the calculations, your analysis is not completely way off. So you have values which are not missing, first of all, so your system will work. Number two, these values are not so completely out of whack that your whole analysis goes for a toss, right? There may be situations where if the missing values, instead of putting mean, maybe a good idea to fill it up with the minimum value or with a 0. So, or with a maximum value. Again, as I said, there are so many possibilities. So there is no like one correct answer for this. You need to basically talk around this and illustrate with your experience. As I said, that would be the best. Otherwise, this is how you need to handle this question. Okay, so then the next question can be, how can you choose a classifier based on a training set data size? So again, this is one of those questions where you probably do not have like a one size fits all answer. First of all, you may not, let's say, decide your classifier based on the training set size. Maybe not the best way to decide the type of the classifier. And even if you have to, there are probably some thumb rules which we can use. But then again, every time, so in my opinion, the best way to respond to this question is you need to try out few classifiers irrespective of the size of the data, and you need to then decide on your particular situation which of these classifiers are the right ones. This is a very generic issue, so you will never be able to just by, if somebody defines a problem to you and somebody, even if they show the data to you or tell you what is the data or even the size of the data, I don't think there is a way to really say that yes, this is the classifier that will work here. No, that's not the right way. So you need to still, test it out, get the data, try out a couple of classifiers, and then only you will be in a position to decide which classifier to use. You try out multiple classifiers, see which one gives the best accuracy, and only then you can decide. Then you can have a question around confusion matrix. So the question can be, explain confusion matrix. Right? So confusion matrix, I think the best way to explain it is by taking an example and drawing like a small diagram. Otherwise, it can really become tricky. So my suggestion is to take a piece of pen and paper and explain it by drawing a small matrix. And confusion matrix is about to find out, this is used especially in classification learning process, and when you get the results, when our model predicts the results, you compare it with the actual value and try to find out what is the accuracy. Okay, so in this case, let's say this is an example of a confusion matrix, and it is a binary matrix. So you have the actual values, which is the labeled data, right? And which is, so you have how many yes and how many no. So you have that information, and you have the predicted values, how many yes and how many no, right? So the total actual values, the total yes is 12 plus 1, 13, and they are shown here. And the actual value no's are 9 plus 3, 12. Okay, so that is what this information here is. So this is about the actual and this is about the predicted. Similarly, the predicted values, there are yes are 12 plus 3, 15 yeses, and no are 1 plus 9, 10 no's. Okay, so this is the way to look at this confusion matrix. Okay, and out of this, what is the meaning conveyed? So there are 2 or 3 things that needs to be explained outright. The first thing is, for a model to be accurate, the values across the diagonal should be high, like in this case, right? That is one. Number 2, the total sum of these values is equal to the total observations in the test data set. So in this case, for example, you have 12 plus 3, 15 plus 10, 25. So that means we have 25 observations in our test data set. Okay, so these are the 2 things you need to first explain, that the total sum in this matrix, the numbers, is equal to the size of the test data set, and the diagonal values indicate the accuracy. So by looking at it, you can probably have an idea about, is this an accurate model? Is the model being accurate? If they're all spread out equally in all these 4 boxes, that means probably the accuracy is not very good. Okay. Now, how do you calculate the accuracy itself, right? How do you calculate the accuracy itself? So it is a very simple mathematical calculation. You take sum of the diagonals, right? So in this case, it is 9 plus 12, 21, and divide it by the total. So in this case, what will it be? Let me take a pen. So your diagonal values is equal to, if I say D is equal to 12 plus 9, so that is 21, right? And the total data set is equal to, right, we just calculated, it is 25. So what is your accuracy? It is 21 by, so your accuracy is equal to 21 by 25. And this turns out to be about 85%. Right? So this is 85%. So that is our accuracy. Okay. So this is the way you need to explain, draw a diagram, give an example, and maybe it may be a good idea to be prepared with an example so that it becomes easy for you. You don't have to calculate those numbers on the fly, right? So a couple of hints are that you take some numbers which add up to 100. That is always a good idea. So you don't have to really do this complex calculations. So the total value will be 100, and then diagonal values you divide. Once you find the diagonal values, that is equal to your percentage. Okay. All right. So the next question can be a related question about false positive and false negative. So what is false positive and what is false negative? Now, once again, the best way to explain this is using piece of paper and pen. Otherwise, it will be pretty difficult to explain this. So we use the same example of the confusion matrix, and we can explain that. So a confusion matrix looks somewhat like this, and when we just take it looks somewhat like this, and we continue with the previous example where this is the actual value, this is the predicted value, and in the actual value we have 12 plus 1 13 yeses and 3 plus 9 12 no's, and the predicted values there are 12 plus 3 15 yeses and 1 plus 9 10 no's. Okay. Now, in this particular case, which is the false positive, what is a false positive? First of all, the second word, which is positive, okay, is referring to the predicted value. So that means the system has predicted it as a positive, but the real value, so this is what the false comes from, but the real value is not positive. Okay, that is the way you should understand this term, false positive or even false negative. So false positive, so positive is what your system has predicted. So where is that system predicted? This is the one. Positive is what? Yes. So you basically consider this row. Okay. Now if you consider this row, so this is all positive values. This entire row is positive values. Okay. Now the false positive is the one where the actual value is negative. Predicted value is positive, but the actual value is negative. So this is a false positive, right? And here is a true positive. So the predicted value is positive and the actual value is also positive. Okay, I hope this is making sense. Now let's take a look at what is false negative. False negative. So negative is the second term. That means that is the predicted value that we need to look for. So which are the predicted negative values? This row corresponds to predicted negative values. All right. So this row corresponds to predicted negative values. And what they are asking for? False. So this is the row for predicted negative values, and the actual value is this one, right? This is predicted negative and the actual value is also negative. Therefore, this is a true negative. So the false negative is this one. Predicted is negative, but actual is positive, right? So this is the false negative. So this is the way to explain, and this is the way to look at false positive and false negative. Same way, there can be true positive and true negative as well. So again, positive, the second term you will need to use to identify the predicted row, right? So if we say true positive, we need to take for the predicted part. So predicted positive is here. Okay, and then the first term is for the actual. So true positive. So true in case of actual is yes, right? So true positive is this one. Okay, and then in case of actual, the negative. Now we are talking about, let's say, true negative. True negative. Negative is this one, and the true comes from here. So this is true negative, right? 9 is true negative. The actual value is also negative and the predicted value is also negative. Okay, so that is the way you need to explain this, the terms false positive, false negative, and true positive, true negative. Then you might have a question like, what are the steps involved in the machine learning process, or what are the 3 steps in the process of developing a machine learning model, right? So it is around the methodology that is applied. So basically, the way you can probably answer in your own words, but the way the model development of the machine learning model happens is like this. So first of all, you try to understand the problem and try to figure out whether it is a classification problem or a regression problem. Based on that, you select a few algorithms and then you start the process of training these models. Okay, so you can either do that, or you can, after due diligence, you can probably decide that there is one particular algorithm which is most suitable. Usually it happens through trial and error process, but at some point you will decide that, okay, this is the model we are going to use. Okay, so in that case, we have the model, algorithm, and the model decided, and then you need to do the process of training the model and testing the model. And this is where, if it is supervised learning, you split your data, the labeled data, into training data set and test data set. And you use the training data set to train your model. And then you use the test data set to check the accuracy, whether it is working fine or not. So you test the model before you actually put it into production, right? So once you test the model, you're satisfied it's working fine, then you go to the next level, which is putting it for production. And then in production, obviously new data will come and the inference happens. So the model is readily available, and only thing that happens is new data comes and the model predicts the values, whether it is regression or classification. Now, so this can be an iterative process. So it is not a straightforward process where you do the training through the testing and then you move it to production. No. So during the training and test process, there may be a situation where, because of either overfitting or things like that, the test doesn't go through, which means that you need to put that back into the training process. So that can be an iterative process. Not only that, even if the training and test goes through properly and you deploy the model in production, there can be a situation that the data that actually comes, the real data that comes, with that, this model is failing. So in which case you may have to once again go back to the drawing board. Or initially it will be working fine, but over a period of time, maybe due to the change in the nature of the data, once again the accuracy will deteriorate. So that is again a recursive process. So once in a while, you need to keep checking whether the model is working fine or not. And if required, you need to tweak it and modify it and so on and so forth. So net, this is a continuous process of tweaking the model and testing it and making sure it is up to date. Then you might have question around deep learning. So because deep learning is now associated with AI, artificial intelligence, and so on. So it can be as simple as, what is deep learning? So I think the best way to respond to this could be, deep learning is a part of machine learning. And then obviously the question would be, then what is the difference, right? So deep learning, you need to mention there are two key parts that interviewer will be looking for when you are defining deep learning. So first is, of course, deep learning is a subset of machine learning. So machine learning is still the bigger, let's say, scope, and deep learning is one part of it. So then what exactly is the difference? Deep learning is primarily when we are implementing these our algorithms, or when we are using neural networks for doing our training and classification and regression and all that, right? So when we use neural network, then it is considered as deep learning. And the term deep comes from the fact that you can have several layers of neural networks, and these are called deep neural networks, and therefore the term deep, deep learning. The other difference between machine learning and deep learning, which the interviewer may be wanting to hear, is that in case of machine learning, the feature engineering is done manually. What do we mean by feature engineering? Basically, when we are trying to train our model, we have our training data, right? So we have our training labeled data, and this data has several, let's say if it is a regular table, it has several columns. Now each of these columns actually has information about a feature, right? So if we are trying to predict the height, weight, and so on and so forth, so these are all features of human beings. Let's say we have census data and we have all this. So those are the features. Now there may be probably 50 or 100, in some cases there may be 100 such features. Now all of them do not contribute to our model, right? So we as a data scientist, we have to decide whether we should take all of them, all the features, or we should throw away some of them. Because again, if we take all of them, number one, of course, your accuracy will probably get affected, but also there is a computational part. So if you have so many features and then you have so much data, it becomes very tricky. So in case of machine learning, we manually take care of identifying the features that do not contribute to the learning process, and thereby we eliminate those features and so on, right? So this is known as feature engineering, and in machine learning we do that manually. Whereas in deep learning, where we use neural networks, the model will automatically determine which features to use and which to not use, and therefore feature engineering is also done automatically. So this is an explanation. These are two key things probably will add value to your response. All right, so the next question is, what is the difference between, or what are the differences between machine learning and deep learning? So here, this is a quick comparison table between machine learning and deep learning. And in machine learning enables machines to take decisions on their own based on past data. So here we are talking primarily of supervised learning. And it needs only a small amount of data for training, and then works well on low-end systems, so you don't need large machines. And most features need to be identified in advance and manually coded. So basically the feature engineering part is done manually, and the problem is divided into parts and solved individually and then combined. So that is about the machine learning part. In deep learning basically enables machines to take decisions with the help of artificial neural networks. So here in deep learning we use neural nets. So that is the key differentiator between machine learning and deep learning. And usually deep learning involves a large amount of data, and therefore the training also requires, usually the training process requires high-end machines because it needs a lot of computing power. And the machine learning features the feature engineering is done automatically. So the neural networks takes care of doing the feature engineering as well. And in case of deep learning, therefore, it is said that the problem is handled end to end. So this is a quick comparison between machine learning and deep learning in case you have that kind of a question. Then you might get a question around the uses of machine learning or some real life applications of machine learning in modern business. The question may be worded in different ways, but the meaning is how exactly is machine learning used, or actually supervised machine learning. It could be a very specific question around supervised machine learning. So this is like give examples of supervised machine learning, use of supervised machine learning in modern business. So that could be the next question. So there are quite a few examples or quite a few use cases, if you will, for supervised machine learning. The very common one is email spam detection. So you want to train your application or your system to detect between spam and non-spam. So this is a very common business application of supervised machine learning. So how does this work? The way it works is that you obviously have historical data of your emails, and they are categorized as spam and not spam. So that is what is the labeled information. And then you feed this information or all these emails as an input to your model, right? And the model will then get trained to detect which of the emails are to detect which is spam and which is not spam. So that is the training process. And this is supervised machine learning because you have labeled data. You already have emails which are tagged as spam or not spam. And then you use that to train your model, right? So this is one example. Now, there are a few industry-specific applications for supervised machine learning. One of the very common ones is in healthcare diagnostics. In healthcare diagnostics, you have these images and you want to train models to detect whether from a particular image, whether it can find out if the person is sick or not, whether a person has cancer or not. Right? So this is a very good example of supervised machine learning. Here, the way it works is that existing images, it could be X-ray images, it could be MRI or any of these images are available and they are tagged saying that, okay, this X-ray image is defective or the person has an illness, or it could be cancer, whichever illness, right? So it is tagged as defective or clear or good image and defective image, something like that. So we come up with a binary, or it could be multi-class as well, saying that this is defective to 10%, this is 25%, and so on. But let's keep it simple. You can give an example of just a binary classification, that would be good enough. So you can say that in healthcare diagnostics, using image, we need to detect whether a person is ill or whether a person is having cancer or not. So here, the way it works is you feed labeled images and you allow the model to learn from that, so that when new image is fed, it will be able to predict whether this person is having that illness or not, having cancer or not, right? So I think this would be a very good example for supervised machine learning in modern business. All right, then we can have a question like, so we've been talking about supervised and unsupervised, and so there can be a question around semi-supervised machine learning. So what is semi-supervised machine learning? Now, semi-supervised learning, as the name suggests, it falls between supervised learning and unsupervised learning, but for all practical purposes it is considered as a part of supervised learning. And the reason this has come into existence is that in supervised learning, you need labeled data. So all your data for training your model has to be labeled. Now, this is a big problem in many industries or under many situations. Getting the labeled data is not that easy because there's a lot of effort in labeling this data. Let's take an example of diagnostic images. We can just let's say take X-ray images. Now there are actually millions of X-ray images available all over the world, but the problem is they are not labeled. So the images are there, but whether it is effective or whether it is good, that information is not available along with it, right, in a form that it can be used by a machine, which means that somebody has to take a look at these images, and usually it should be like a doctor, and then say that, okay, yes, this image is clean and this image is cancerous and so on and so forth. Now that is a huge effort by itself. So this is where semi-supervised learning comes into play. So what happens is there is a large amount of data, maybe a part of it is labeled. Then we try some techniques to label the remaining part of the data so that we get completely labeled data, and then we train our model. So I know this is a little long winding explanation, but unfortunately there is no quick and easy definition for semi-supervised machine learning. This is the only way probably to explain this concept. We may have another question as what are unsupervised machine learning techniques? Or what are some of the techniques used for performing unsupervised machine learning? So it can be worded in different ways. So how do we answer this question? So unsupervised learning, you can say that there are two types, clustering and association. And clustering is a technique where similar objects are put together. And there are different ways of finding similar objects. So their characteristics can be measured, and if they have, in most of the characteristics, if they are similar, then they can be put together. This is clustering. Then association, I think the best way to explain association is with an example. In case of association, you try to find out how the items are linked to each other. So for example, if somebody bought maybe a laptop, the person has also purchased a mouse. So this is more in an e-commerce scenario, for example. So you can give this as an example. So people who are buying laptops are also buying a mouse. So that means there is an association between laptops and mouse. Or maybe people who are buying bread are also buying butter. So that is a association that can be created. So this is unsupervised learning, one of the techniques. Okay. All right, then we have very fundamental question. What is the difference between supervised and unsupervised machine learning? So machine learning, these are the two main types of machine learning, supervised and unsupervised. And in case of supervised, and again here, probably the keyword that the person may be wanting to hear is labeled data. Now, very often people say, we have historical data, and if we run it, it is supervised, and if we don't have historical data, yes, but you may have historical data, but if it is not labeled, then you cannot use it for supervised learning. So it's very key to understand that we put in that keyword labeled. Okay. So when we have labeled data for training our model, then we can use supervised learning. And if we do not have labeled data, then we use unsupervised learning. And there are different algorithms available to perform both of these types of trainings. So there can be another question, a little bit more theoretical and conceptual in nature. This is about inductive machine learning and deductive machine learning. So the question can be, what is the difference between inductive machine learning and deductive machine learning? Or somewhat in that manner, so that the exact phrase or exact question can vary. They can ask for examples and things like that, but that could be the question. So let's first understand what is inductive and deductive training. Inductive training is induced by somebody, and you can illustrate that with a small example. I think that always helps. So whenever you're doing some explanation, try as much as possible, as I said, to give examples from your work experience or give some analogies, and that will also help a lot in explaining as well, and for the interviewer also to understand. So here we'll take an example, or rather we will use an analogy. So inductive training is when we induce some knowledge or the learning process into a person without the person actually experiencing it. Okay, what can be an example? So we can probably tell the person or show a person a video that fire can burn his finger, or fire can cause damage. So what is happening here? This person has never probably seen a fire or never seen anything getting damaged by fire. But just because he has seen this video, he knows that, okay, fire is dangerous, and if fire can cause damage, right? So this is inductive learning. Compared to that, what is deductive learning? So here you draw conclusion, or the person draws conclusion out of experience. So we will stick to the analogy. So compared to the showing a video, let's assume a person is allowed to play with fire. Right? And then he figures out that if he puts his finger, it's burning, or if he throws something into the fire, it burns. So he is learning through experience. So this is known as deductive learning. Okay, so you can have applications or models that can be trained using inductive learning or deductive learning. All right, I think probably that explanation will be sufficient. The next question is, are KNN and K-means clustering similar to one another, or are they same? Right? Because the letter K is kind of common between them. Okay. So let us take a little while to understand what these two are. One is KNN, another is K-means. KNN stands for K nearest neighbors, and K means, of course, is the clustering mechanism. Now, these two are completely different, except for the letter K being common between them. KNN is completely different. K means clustering is completely different. KNN is a classification process, and therefore it comes under supervised learning, whereas K-means clustering is actually unsupervised. Okay, when you have KNN, when you want to implement KNN, which is basically K nearest neighbors, the value of K is a number. So you can say K is equal to 3. You want to implement KNN with K is equal to 3. So which means that it performs the classification in such a way that, how does it perform the classification? So it will take 3 nearest objects, and that's why it's called nearest neighbor. So basically based on the distance, it will try to find out its nearest objects that are, let's say, 3 of the nearest objects, and then it will check whether the class they belong to which class, right? So if all 3 belong to one particular class, obviously this new object is also classified as that particular class. But it is possible that they may be from 2 or 3 different classes. Okay, so let's say they are from 2 classes, and then if they are from 2 classes, now usually you take a odd number, you assign an odd number to. So if there are 3 of them and 2 of them belong to one class and then 1 belongs to another class, so this new object is assigned to the class to which the 2 of them belong. Now, the value of K is sometimes tricky. Whether should you use 3, should you use 5, should you use 7? That can be tricky because the ultimate classification can also vary. So it's possible that if you're taking K as 3, the object is probably in one particular class. But if you take K is equal to 5, maybe the object will belong to a different class. Because when you're taking 3 of them, probably 2 of them belong to class 1 and 1 belong to class 2. Whereas when you take 5 of them, it is possible that only 2 of them belong to class 1 and 3 of them belong to class 2. So which means that this object will belong to class 2, right? So you see that? So the class allocation can vary depending on the value of K. Now, K-means, on the other hand, is a clustering process, and it is unsupervised, where what it does is the system will basically identify how the objects are, how close the objects are with respect to some of their features. Okay, but the similarity of course is the letter K, and in case of K means also we specify its value, and it could be 3 or 5 or 7. There is no technical limit as such, but it can be any number of clusters that you can create. Okay, so based on the value that you provide, the system will create that many clusters of similar objects. So there is a similarity to that extent that K is a number in both the cases, but actually these two are completely different processes. We have what is known as naive Bayes classifier, and people often get confused thinking that naive Bayes is the name of the person who found this classifier or who developed this classifier, which is not 100% true. Bayes is the name of the person, Bayes is the name of the person, but naive is not the name of the person, right? So naive is basically an English word, and that has been added here because of the nature of this particular classifier. Naive Bayes classifier is a probability based classifier, and it makes some assumptions that presence of one feature of a class is not related to the presence of any other feature of maybe other classes, right? So which is not a very strong or not a very accurate assumption, because these features can be related and so on. But even if we go with this assumption, this whole algorithm works very well even with this assumption, and that is the good side of it. But the term comes from there, so that is the explanation that you can give. Then there can be question around reinforcement learning. It can be paraphrased in multiple ways. One could be, can you explain how a system can play a game of chess using reinforcement learning? Or it can be any game. So the best way to explain this is again to talk a little bit about what reinforcement learning is about, and then elaborate on that to explain the process. So first of all, reinforcement learning has an environment and an agent, and the agent is basically performing some actions in order to achieve a certain goal. And these goals can be anything, either if it is related to game, then the goal could be that you have to score very high, score a high value, high number. Or it could be that your number of lives should be as high as possible. Don't lose lives. So these could be some of them. More advanced examples could be for driving. In the automotive industry, self-driving cars, they actually also make use of reinforcement learning to teach the car how to navigate through the roads and so on and so forth. That is also another example. Now, how does it work? So if the system is basically there is an agent and environment, and every time the agent takes a step or performs a task which is taking it towards the goal, the final goal, let's say to maximize the score or to minimize the number of lives and so on, or minimize the deaths, for example, it is rewarded. And every time it takes a step which goes against that goal, right, contrary or in the reverse direction, it is penalized. Okay, so it is like a carrot and stick system. Now, how do you use this to create a game of chess, or to create a system to play a game of chess? Now, the way this works is, and this could probably go back to this AlphaGo example where AlphaGo defeated a human champion. So the way it works is, in reinforcement learning, the system is allowed, for example, if in this case we are talking about chess, so we allow the system to first of all watch playing a game of chess. So it could be with a human being, or it could be the system itself. There are computer games of chess, right? So either this new learning system has to watch that game or watch a human being play the game, because this is reinforcement learning is pretty much all visual. So when you're teaching the system to play a game, the system will not actually go behind the scenes to understand the logic of your software, of this game or anything like that. It is just visually watching the screen and then it learns. Okay, so reinforcement learning to a large extent works on that. So you need to create a mechanism whereby your model will be able to watch somebody playing the game, and then you allow the system also to start playing the game. So it pretty much starts from scratch. Okay. And as it moves forward, it's right at the beginning, the system really knows nothing about the game of chess. Okay, so initially it is a clean slate. It just starts by observing how you're playing. So it will make some random moves and keep losing badly. But then what happens is, over a period of time, so you need to now allow the system, or you need to play with the system, not just 1, 2, 3, 4 or 5 times, but hundreds of times, thousands of times, maybe even hundreds of thousands of times. And that's exactly how AlphaGo has done. It played millions of games between itself and the system, right? So for the game of chess also, you need to do something like that. You need to allow the system to play chess and then learn on its own over a period of repetition. So I think you can probably explain it to this extent, and it should be sufficient. Now, this is another question which is again somewhat similar, but here the size is not coming into picture. So the question is, how will you know which machine learning algorithm to choose for your classification problem? Now, this is not only a classification problem, it could be a regression problem. I would like to generalize this question. So if somebody asks you, how will you choose? How will you know which algorithm to use? The simple answer is, there is no way you can decide exactly saying that this is the algorithm I'm going to use. In a variety of situations, there are some guidelines. Like for example, you will obviously, depending on the problem, you can say whether it is a classification problem or a regression problem. And then in that sense, you are kind of restricting yourself to, if it is a classification problem, you can only apply a classification algorithm, right? To that extent, you can probably, let's say, limit the number of algorithms. But now within the classification algorithms, you have decision trees, you have SVM, you have logistic regression. Is it possible to outright say, yes, so for this particular problem, since you have explained this, now this is the exact algorithm that you can use? That is not possible. Okay, so we have to try out a bunch of algorithms, see which one gives us the best performance and best accuracy, and then decide to go with that particular algorithm. So in machine learning, a lot of it happens through trial and error. There is no real possibility that anybody can, just by looking at the problem or understanding the problem, tell you that, okay, in this particular situation, this is exactly the algorithm that you should use. Then the questions may be around application of machine learning. And this question is specifically around how Amazon is able to recommend other things to buy. So this is around recommendation engine. How does it work? How does the recommendation engine work? So this is basically the question is all about. So the recommendation engine again works based on various inputs that are provided. Obviously something like Amazon, a website or e-commerce site like Amazon collects a lot of data around the customer behavior, who is purchasing what. And if somebody is buying a particular thing, they're also buying something else. So this kind of association, right? So this is the unsupervised learning we talked about. They use this to associate and link or relate items. And that is one part of it. So they kind of build association between items, saying that somebody buying this is also buying this. That is one part of it. Then they also profile the users, right? Based on their age, their gender, their geographic location. They will do some profiling. And then when somebody is logging in and when somebody is shopping, kind of the mapping of these two things are done. They try to identify, obviously if you have logged in, then they know who you are and your information is available. Like for example, your age maybe, your gender, and where you're located, what you purchased earlier. Right? So all this is taken, and the recommendation engine basically uses all this information and comes up with recommendations for a particular user. So that is how the recommendation engine works. All right, then the question can be something very basic, like when will you go for classification versus regression, right? When do you do classification instead of regression, or when will you use classification instead of regression? Now, yes, so this is basically going back to the understanding of the basics of classification and regression. So classification is used when you have to identify or categorize things into discrete classes. So the best way to respond to this question is to take up some examples and use it. Otherwise, it can become a little tricky. The question may sound very simple, but explaining it can sometimes be very tricky. In case of regression, we use, of course, there will be some keywords that they will be looking for. So just you need to make sure you use those keywords. One is the discrete values, another is the continuous values. So for regression, if we are trying to find some continuous values, you use regression. Whereas if you're trying to find some discrete values, values, you use classification. And then you need to illustrate. What are some of the examples? So classification is like, let's say there are images and you need to put them into classes like cat, dog, elephant, tiger, something like that. So that is a classification problem. Or it can be, that is a multi-class classification problem. It could be binary classification problem, like for example, whether a customer will buy or he will not buy. That is a classification, binary classification. It can be in the weather forecast area. Now, weather forecast is again combination of regression and classification, because on the one hand, you want to predict whether it's going to rain or not. That's a classification problem. That's a binary classification, right? Whether it's going to rain or not rain. However, you also have to predict what is going to be the temperature tomorrow, right? Now, temperature is a continuous value. You can't answer the temperature in a yes or no kind of a response, right? So what will be the temperature tomorrow? So you need to give a number, which can be like 20 degrees, 30 degrees or whatever. Right? So that is where you use regression. One more example is stock price prediction. So that is where again you will use regression. So these are the various examples. So you need to illustrate with examples and make sure you include those keywords like discrete and continuous. So the next question is more about a little bit of a design related question to understand your concepts and things like that. So it is, how will you design a spam filter? So how do you basically design or develop a spam filter? So I think the main thing here is he is looking at probably understanding your concepts in terms of what is the algorithm you will use, or what is your understanding about difference between classification and regression and things like that, right? And the process, of course, the methodology and the process. So the best way to go about responding to this is we say that, okay, this is a classification problem because we want to find out whether an email is a spam or not spam, so that we can apply the filter accordingly. So first thing is to identify what type of a problem it is. So we have identified that it is a classification. Then the second step may be to find out what kind of algorithm to use. Now, since this is a binary classification problem, logistic regression is a very common algorithm. But however, right, as I said earlier also, we can never say that, okay, for this particular problem, this is exactly the algorithm that we can use. So we can also probably try decision trees or even support vector machines, for example, SVM. So we will kind of list down a few of these algorithms and we will say, okay, we would like to try out these algorithms. And then we go about taking your historical data, which is the labeled data, which are marked. So you will have a bunch of emails, and then you split that into training and test data sets. You use your training data set to train your model or your algorithm that you have used, or rather the model actually. So, and you actually will have three models. Let's say you are trying to test out three algorithms, so you will obviously have three models. So you need to try all three models and test them out as well, see which one gives the best accuracy, and then you decide that you will go with that model. Okay, so training and test will be done, and then you zero in on one particular model, and then you say, okay, this is the model we will use, and then go ahead and implement that or put that in production. So that is the way you design a spam filter. The next question is about random forest. So what is random forest? So this is a very straightforward question. However, the response, you need to be again a little careful. While we all know what is random forest, explaining this can sometimes be tricky. So one thing is, random forest is kind of, in one way, it is an extension of decision trees, because it is basically nothing but you have multiple decision trees, and trees will basically we will use for doing, if it is classification, mostly it is classification, you will use the trees for classification, and then you use voting for finding the final class. So that is the underlying. But how will you explain this? How will you respond to this? So first thing, obviously, we will say that random forest is one of the algorithms, and the more important thing that you need to, probably the interviewer is waiting to hear, is ensemble learner, right? So this is one type of ensemble learner. What is ensemble learner? Ensemble learner is like a combination of algorithms. So it is a learner which consists of more than one algorithm or more than one maybe models. Okay, so in case of random forest, the algorithm is the same, but instead of using one instance of it, we use multiple instances of it, and we use. So in a way, that is a random forest is an ensemble learner. There are other types of ensemble learners where we use different algorithms itself. So you have one maybe logistic regression and a decision tree combined together, and so on and so forth. Or there are other ways, like for example splitting the data in a certain way and so on. So that's all about ensemble. We will not go into that, but random forest itself, I think the interviewer will be happy to hear this word ensemble learner. And so then you go and explain how the random forest works. So if the random forest is used for classification, then we use what is known as a voting mechanism. So basically, how does it work? Let's say your random forest consists of 100 trees, okay, and each observation you pass through this forest, and each observation, let's say it is a classification problem, binary classification 0 or 1, and you have 100 trees. Now if 90 trees say that it is a 0 and 10 of the trees say it is a 1, you take the majority. You may take a vote, and since 90 of them are saying 0, you classify this as 0. Then you take the next observation and so on. So that is the way random forest works for classification. If it is a regression problem, it's somewhat similar, but only thing is, instead of vote, what we will do is, so in regression, remember what happens? You actually calculate a value. Right? So for example, you're using regression to predict the temperature, and you have 100 trees, and each tree obviously will probably predict a different value of the temperature. They may be close to each other, but they may not be exactly the same value. So these 100 trees. So how do you now find the actual value, the output for the entire forest, right? So you have outputs of individual trees which are a part of this forest, but then you need to find the final output of the forest itself. So how do you do that? So in case of regression, you take like an average or the mean of all the 100 trees, right? So this is also a way of reducing the error. So maybe if you have only one tree, and if that one tree makes an error, it is basically 100% wrong or 100% right? But if you have, on the other hand, if you have a bunch of trees, you are basically mitigating that error, reducing that error. Okay, so that is the way random forest works. So the next question is, considering the long list of machine learning algorithms, how will you decide on which one to use? So once again, here there is no way to outright say that this is the algorithm that we will use for a given data set. This is a very good question, but then the response has to be like, again, there will not be a one size fits all. So we need to, first of all, you can probably shorten the list in terms of by saying, okay, whether it is a classification problem or it is a regression problem. To that extent, you can probably shorten the list, because you don't have to use all of them. If it is a classification problem, you only can pick from the classification algorithms, right? So for example, if it is a classification, you cannot use linear regression algorithm there. Or if it is a regression problem, you cannot use SVM, or maybe no, you can use SVM, but maybe a logistic regression, right? So to that extent, you can probably shorten the list, but still you will not be able to 100% decide on saying that this is the exact algorithm that I'm going to use. So the way to go about is, you choose a few algorithms based on what the problem is. You try out your data, you train some models of these algorithms, check which one gives you the lowest error or the highest accuracy, and based on that, you choose that particular algorithm. Okay. All right. Then there can be questions around bias and variance. So the question can be, what is bias and variance in machine learning? So you just need to give out a definition for each of these. For example, bias in machine learning, it occurs when the predicted values are far away from the actual value. So that is a bias. Okay. And whereas they are all the values are probably, they are far off, but they are very near to each other though. The predicted values are close to each other, right? While they are far off from the actual value, but they are close to each other. You see the difference? So that is bias. And then the other part is your variance. Now variance is when the predicted values are all over the place, right? So if the variance is high, that means it may be close to the target, but it is kind of very scattered. So the predicted values are not close to each other, right? In case of bias, the predicted values are close to each other, but they are not close to the target. But here they may be close to the target, but they may not be close to each other. So they are a little bit more scattered. So that is what in case of a variance. Okay, then the next question is about, again, related to bias and variance. What is the trade-off between bias and variance? Yes, I think this is an interesting question, because these two are heading in different directions. So for example, if you try to minimize the bias, variance will keep going high. And if you try to minimize the variance, bias will keep going high. And there is no way you can minimize both of them. So you need to have a trade-off saying that, okay, this is the level at which I will have my bias and this is the level at which I will have variance. So the trade-off is that pretty much that you decide what is the level you will tolerate for your bias and what is the level you will tolerate for variance, and a combination of these two in such a way that your final results are not way off. And having a trade-off will ensure that the results are consistent, right? So that is basically the output is consistent, and which means that they are close to each other, and they are also accurate. That means they are as close to the target as possible, right? So if either of these is high, then one of them will go off the track. Define precision and recall. Now again, here I think it would be best to draw a diagram and take the confusion matrix, and it is very simple. The definition is like a formula. Your precision is true positive by true positive plus false positive, and your recall is true positive by true positive plus false negative. Okay, so that's, you can just show it in a mathematical way. That's pretty much that can be shown. That's the easiest way to define. So the next question can be about decision tree. What is decision tree pruning and why is it? So basically, decision trees are really simple to implement and understand, but one of the drawbacks of decision trees is that it can become highly complicated as it grows, right? And the rules and the conditions can become very complicated, and this can also lead to overfitting, which is basically that during training you will get 100% accuracy, but when you're doing testing you will get a lot of errors. So that is the reason pruning needs to be done. So the purpose or the reason for doing decision tree pruning is to reduce overfitting or to cut down on overfitting. And what is decision tree pruning? It is basically that you reduce the number of branches, because as you may be aware, a tree consists of the root node, and then there are several internal nodes, and then you have the leaf nodes. Now if there are too many of these internal nodes, that is when you face the problem of overfitting, and pruning is the process of reducing those internal nodes. Alright, so the next question can be, what is logistic regression? So basically, logistic regression is one of the techniques used for performing classification, especially binary classification. Now, there is something special about logistic regression, and there are a couple of things you need to be careful about. First of all, the name is a little confusing. It is called logistic regression, but it is used for classification. So this can be sometimes confusing. So you need to probably clarify that to the interviewer if it's really, if it is required. And they can also ask this like a trick question, right? So that is one part. Second thing is, the term logistic has nothing to do with the usual logistics that we talk about, but it is derived from log. So that the mathematical derivation was log, and therefore the name logistic regression. So what is logistic regression and how is it used? So logistic regression is used for binary classification, and the output of a logistic regression is either a 0 or a 1, and it varies. So it's basically, it calculates a probability between 0 and 1, and we can set a threshold that can vary. Typically it is 0.5. So any value above 0.5 is considered as 1, and if the probability is below 0.5, it is considered as 0. So that is the way we calculate the probability, or the system calculates the probability, and based on the threshold it sets a value of 0 or 1, which is like a binary classification, 0 or 1. Okay, then we have a question around k nearest neighbor algorithm. So explain k nearest neighbor algorithm. So first of all, what is a k nearest neighbor algorithm? This is a classification algorithm. So that is the first thing we need to mention. And we also need to mention that the k is a number. It is an integer. and this is variable, and we can define what the value of k should be. It can be 2, 3, 5, 7, and usually it is an odd number, so that is something we need to mention. Technically it can be even number also, but then typically it would be odd number, and we will see why that is. Okay, so based on that, we need to classify objects. Okay, we need to classify objects. So again, it will be very helpful to draw a diagram. If you're explaining, I think that will be the best way. So draw some diagram like this, and let's say we have 3 clusters or 3 classes existing, and now you want to find for a new item that has come, you want to find out which class this belongs to, right? So you go about, as the name suggests, you go about finding the nearest neighbors, right? The points which are closest to this, and how many of them you will find, that is what is defined by k. Now let's say our initial value of k was 5. Okay, so you will find the 5 nearest data points. So in this case, as it is illustrated, these are the 5 nearest data points. But then all 5 do not belong to the same class or cluster. So there are one belonging to this cluster 1, the second one belonging to this cluster 2, 3 of them belonging to this third cluster. Okay, so how do you decide? That's exactly the reason we should, as much as possible, try to assign an odd number so that it becomes easier to assign this. So in this case, you see that the majority, actually, if there are multiple classes, then you go with the majority. So since 3 of these items belong to this class, we assign, which is basically the, in this case, the green or the tennis or the third cluster, as I was talking about. Right, so we assign it to this third class. So in this case, it is that's how it is decided. Okay, so k nearest neighbors. So first thing is to identify the number of neighbors that are mentioned as k. So in this case, it is k is equal to 5. So we find the 5 nearest points, and then find out of these 5 which class has the maximum number in that. Okay, and then the new data point is assigned to that class. Okay, so that's pretty much how k nearest neighbors work.
And with that, we have come to the end of this machine learning Python full course. I hope you found it valuable and entertaining. Please ask any questions about the topics covered in this video in the comment box below, and a team of experts will assist you in addressing your problems as soon as possible. So thank you so much for being here today. We'll see you next time. Until then, keep learning and stay tuned to Simplilearn.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital programs, and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.